I'm just coming back in 1 minute, but I'll be there.
Okay, we've just gone live to see you going away.
Sounds good. Okay, well, this is day 2 of the Jupyterthon 2022 edition. We have so we had actually Jose and Thomas in here, but now they both went away.
They just ran off as soon as we went live. I don't know what happened to us.
When everybody goes live, everybody just starts freaking out. Cool. Yeah. So, well, thank you very much, everyone, once again for joining day 2. And yesterday was a great day. I mean, there were a lot of different resources being shared, notebooks, topics that I was not that familiar with, and it was kind of cool just to see not only, let's say, like different topics like data science and how data science applies in security in certain areas, but actually how Jupyter notebooks are used through the methodology or some of those concepts, right? So this conference is to kind of show that is how you as a security researcher can learn the tools that would allow you then to get to some of those, research areas, right? That's the goal. Even though some of the topics go deep into certain areas, I think that the main idea is to see a security using those tools, right? I think that that's the goal. And of course, like some presentations also were showing a couple of things that will expedite your experience, right? How you use a Jupyter notebook. So that was also something cool that I learned today, like the magics, for example, like presentation from Ryan from SecureWorks. So that was pretty cool. Today, let me share my screen so we can, for those that are just joining us today on day 2, then you can kind of learn a little bit of the things that, from a housekeeping perspective, and then we jump into the agenda, and then we have a great keynote also in a couple of minutes. So let me share my screen real quick. And we are, of course, so I don't know if I forgot to introduce. So we have Ian is also our co-host. We're both kind of like trying to...
Morning, afternoon, evening.
Good morning. I think we have our keynote. It's like 2 a.m. already for our keynote speakers. That's crazy time for everybody. Pacific East. I think that Thomas comes from Australia, I believe, right? So
yeah, Melbourne. Yeah. So when he arrived, we weren't sure what to greet. It's like good morning, good evening, good afternoon, but there's no good middle of the night. So it's like weird.
Yes. Okay, so we're gonna share. Let me share my screen real quick. So for once again, those that are just joining us today and missed yesterday, but they are catching up. So we have our Infosec Jupyterthon.com site, and there is where you'll find all the information for this event. Obviously, if you're watching it right now, you actually are in the YouTube live stream, but just in case if you want to share the links with somebody else, that will be the link to do. We're also using a Discord server so that we can communicate with others. So make sure that you can click on this link so you can get an invitation and then be able to access the conversation, right? And then, of course, once again, as yesterday, I just want to thank all the community collaborators that are making this conference possible. This is a company and also community agnostic conference, and community because this is not just the cybersecurity community. We have folks that are working with, for example, other communities outside, like the data science community, which is a big community as well. And so we're getting people that are actually in those communities coming to the cybersecurity community to start sharing some of those concepts with a Jupyter notebook, right? So this conference would not be possible without the help of all of the ones that are in here in this image, that you can actually click on each one of them and learn a little bit about them. So, feel free to do that. And also, thank all the organizers in here. If for some reason you want to go back and see what 2021 was, the links are also in the site, so you can see all the other presentations in here from last year. Now, coming to the agenda. So today we do have talks all the way from 10:45 to 6 p.m. I think it is 6 p.m. Yeah. And at the end, we do have actually a speakers panel, actually 5:35. But at 5 p.m., we have a speakers panel. We're going to be bringing some of the speakers from day 1 and day 2 to answer any questions. If you just want to talk about Jupyter Notebooks. If you have anything in mind that you would like to probably get some feedback or just an idea on what Jupyter Notebooks will be in the future based on our experience, this is the session to join at the end. So yeah, we have a lot of cool stuff. So if you can just bookmark this and then read some of the abstracts so that you can see what it is that you would like to see and attend today, this is the place to be. And I guess that the last thing was we talked about that in 2021 we did have a workshop, and we have day 1 and day 2 of workshops. So that material is also available through our site, so you can take a look at that on demand. You can do that probably even after this conference, or you can do it anytime you want. And these two actually align with the 2021 live stream, so you can actually follow the workshops with those actually videos, right? So that's something that I would highly recommend to do whenever you have time, because I think it would take you from the basics of how to use Jupyter Notebooks with a basic use case to maybe some more advanced, to show some of those advanced capabilities that you can use with Jupyter Notebooks, right, in general. And I think that would be all from a housekeeping perspective. If you missed day 1, once again, the links are in the site, so you can also watch that. And if you can also use or follow us, we do have our Jupyterthon, Infosec Jupyterthon, Twitter handles. So if you can follow us, so you don't miss. We're trying to do some of this, kind of like taking some snapshots of what's going on, and then sharing some of the interesting pieces of every single presentation. This is a place to go as well. So yeah, feel free to also tag us in any other, I guess, tweet or how you're feeling about the Jupyterthon today. And I don't think, if I'm missing anything, Ian, about some housekeeping rules for day 2 as well.
No, I think it is well worth going back and having a look at some of the sessions from last year, as well as the workshops, some of the live sessions like John Lambert's Keynote. There's not a lot that's kind of repeated, very little, I think, really. So it's still a lot of relevant content. It's kind of a big block of a video. So there's like 2 8-hour sessions, but somebody has very helpfully gone through in the comments and kind of bookmark the timings for each of them. So you can kind of skip to those and navigate through it fairly easily. I was thinking as well, it might be a good idea to set up a thread in Discord, which I've got the link to the Discord conference chat. We can set up a thread for the speaker panel later on, so people can file questions or interesting themes they want to talk about.
Yeah,
I think that would be a good idea. Otherwise, we might be all stuck there for something to say.
Yeah, good idea. Mm-hmm. Cool. Yeah, and I think also something before I forget, there is so yesterday we were talking about it would be nice to create some type of resource that the community could use to understand some of the use cases about how to use Jupyter Notebooks in cybersecurity. And we talked about maybe create a GitHub repo and maybe have some of that content being shared as an open source resource. And so I was actually talking to Ian and also some other folks from our community. And let me see if I can pull out the Jupyter book. There you go. So there is this project that I put together last year just to kind of share some stuff. So I was working with my brother a little bit. Let's just do a zoom on this one and making sure we're actually good on time. So 7:45, there you go. So we still have 5 more minutes until the keynote. So this project was called Infosec Jupyter Book, and it's something that we wanted to share so that when someone asks what a Jupyter Notebook is, yes, you can Google that. You can go to YouTube and then find amazing presentations and also amazing content, right, from even the developers of Jupyter Notebooks. But we wanted to gather some of that information in one place so that you can go and then maybe also see other resources, but at the same time start learning about some of the use cases. So we put this together. I think it was in let me just check this out. So 3 years ago, technically. So the initial commit was like 3 years ago. So 3 years ago, we kind of put this together. This is a GitHub repo under the Open Thread Research community. This is a public repo. And then we added a Jupyter book on the top of this, this resource. So that pretty much what this is. And then we had a couple of people collaborating. So for example, on the left, you can see some of the basic use cases. This, of course, needs to be reorganized a little bit just to make it more flexible, to add some more content. But so far, what we did is saying, what can you do from a visualizations perspective with Jupyter Notebooks? And so we had a couple of ideas. For example, Pete Bryan from the Microsoft Security Research team, he put together this notebook, and he said, these are some of the basic things that that I've done that I would like to share. So on the right, you can see line plots, bar plots, pie charts, etc. I think that there is another one by Pete as well. So Pete was like all over these ones, trying to show some of these visualizations, how to build them, and those are the things that you could use then when you do data analysis in your security role, for example. I contributed this one, for example, this one was how to do, of course, defense and offense a little bit, like the use cases that you can use with this is how can you start interacting with, Bloodhound, right? A tool that from the SpecterOps team that allows you to first be able to explore the information from an identity perspective on organizations, and then be able to identify relationships and things that could be super helpful for defenders to understand some of those gaps, right? And so what I did is I wanted to show step by step how you can use also, there is a public, Bloodhound server, and then you can just go through some of the ways that you can use Python and some Python libraries to create some visualizations on the top of this information. So that was kind of like the idea with this project, not only to show what Jupyter Notebooks are, but actually some of the use cases in here, right? And so SQL to Pandas. So Jose Rodriguez is my brother, so he just went and also tried to share how, when you think about SQL queries, how that translates to actual Pandas queries, right? So just to kind of give you like a high overview of the resource that we started to build a couple of years ago, and maybe we can revamp this project and make it a community Infosec Jupyter book, which the name was like that, like the Infosec Jupyter book, and then share all those concepts with the community. So that's something that I believe would be super useful, and something that I wanted to share also through this conference. Okay, so any feedback, questions, Ian, probably you have about this? I don't know, like if you knew about this resource before.
Yep. Thomas has already, our keynote speaker, has also done some
yes.
kind of compiling like a searchable website for Jupyter Notebooks. I think it would be great to have something like, I think it's both like a need for an introduction, and also somewhere that you can like one of our speakers today reached out to me on LinkedIn and said, hey, I've got this notebook, and it'd be great to have, rather than to go back and search through. It's a fantastic notebook on kind of like memory diagnostics, memory forensics, know that it's there, so you could kind of refer people to it. You could go and search for these different examples, because that was one of the things about yesterday is like people use notebooks in Infosec, but they use them in a very different ways, and lots of them have different interesting ideas that it's great to go back and consult. And not just ones that appear on conferences like this, but random creations from across the community. It'd be great to have a resource where we could put some of those things.
Yeah, I agree. I think that would be super helpful. And there is something that I'm thinking also it could be is we can have a Jupyter book that will have a sample of some of the things that are related to, for example, there's a lot of notebooks for reverse engineering, for example, that you could use with Python. I mean, our keynote speaker has a lot of experience on that. probably the central resource can have a sample of that and then point to a repo full of like complete repo, right, with a lot of different concepts. I think that would be super cool. One hub that then takes you to different places. I think that would be the idea, right?
Yeah.
All right. Awesome. Cool. So cool ideas. I think that this definitely would be nice to start thinking about as well. So, all right. So it's 10:45 and we can start with our keynote speaker. We do have Thomas Rocha, right?
Rocha, yeah.
Rocha, there you go. All right. So Thomas is a senior security researcher at Microsoft. He works for the Microsoft Defender team to improve detection and research novel techniques. And also Thomas previously, he worked at McAfee in the advanced threat research team. And he also worked on threat intelligence, tracking cybercrime campaigns, and, collaborated with law enforcement also. And, he has performed a lot of, I would say, like, not only in an organization, like doing incident response at scale, malware hunting, and all the stuff, but he has also has been sharing a lot of his research in our community with like Jupyter notebooks. He also has a site, for example, called the Unprotect project, which allows you to see, for example, some of those techniques used by, let's call it, malware. How malware is using some of these like evasion techniques, for example, and he gathers all the information from different areas in our security research community, like different blog posts, projects, and then he puts it all together in a way that you can search that and then learn more about it. And then, of course, like Thomas, in my perspective, like Thomas has this way of working that's saying, all right, I'm sharing this information with you. How can I, in my opinion, like enable others to expedite that exploration process? So he has, once again, notebooks. He has an API also on the Unprotect project. So now you can consume all that data in a programmatic way. So you can kind of see like the researcher thinking, right? Not only trying to put everything there and they say go read it, right? He's also trying to make sure that information is consumable, which is so important. And that's why Jupyter Notebooks it's a thing, right? How can you share a resource that somebody else can use and then go through the similar methodology that he also took in order to go through, for example, a malware analysis process, right? So Thomas, thank you very much for being here, and the floor is yours. Thank you.
Thank you, Roberto. Thank you. Well, as you said, I'm currently living in Australia, and when I accepted to do the keynote for the second day of Jupyterthon, I didn't realize that I have to wake up at 2 a.m. on a Sunday morning. That being said, I'm super glad to be here today and to have the opportunity to share my work with the Jupyterthon community. And talking about sharing, my presentation will be focused on threat intelligence and how an analysis process and workflow can be shared using Jupyter notebooks. So my name is Thomas Rocha. I'm currently working as a senior security researcher at Microsoft in the Defender team, and I've been working with, I actually work with Jupyter notebooks on a daily basis, mainly doing creating some workflow and documenting some of my code for some specific project. If you want to have a look to some of my work, you can visit my website, securitybreak.io, and you can also follow me on Twitter and Mastodon these days. All right. So what I will discuss in this presentation, I will talk a little bit about my experience with Jupyter. Then I would like to talk a little bit more about threat intelligence and what is it exactly. And I will conclude that presentation by, I will talk about in this presentation about Jupyter notebooks and how it can be applied in threat intelligence. And I will conclude that presentation by some practical examples and tips and tricks. Before to continue on that presentation, I'd like to quote Peter Senge, which is a scientist at the MIT, and which is which are currently created a theory about learning processes. And he said, sharing knowledge is not about giving people something. Sharing knowledge occurs when people are genuinely interested in helping others to develop new capacities. It is about creating learning processes. And I believe that creating notebooks and sharing that information with the other will also help them to learn more about some processes and some of the work we are doing as well. My Jupyter story. I started using Jupyter in 2017, and at that time, I wanted to learn more about machine learning. And so I discovered Jupyter because Jupyter was very used in that specific field. And my goal, my project at that time was to create a machine learning for malware detection and classification. So I used the data set with cleaned sample and malicious samples and build my machine learning model around that specific data set. And I realized that it was super powerful to use Jupyter to document the code that I built, but also to exchange that information with the rest of my team. So since that day, I started to use more and more Jupyter to document my process, to document my code, and to share that knowledge with my team and with the community as well. Let's talk a little bit about threat intelligence. So threat intelligence is basically getting to know your adversary, your enemy. You want to get more information about their capabilities and what they can do against an organization or against a specific target. And the goal is to get information and knowledge about the threat actors to make informed decisions. So threat intelligence is a very important concept when you are working in defending an organization, because you will learn more about the capabilities of the threat actors. And on the screen, you can see some of the questions that you want to answer when you are working in threat intelligence. And through that questions, there is multiple data sources that can be exploited to answer that questions. The thing is, when you are working in threat intelligence, sharing is really important. It is important because it will benefit the community's collective knowledge, experience, and capabilities. And all that knowledge will help to understand better a threat an organization may face. So this is very important to obtain that information by exchanging threat intelligence and improving that knowledge base. This is actually a critical tool for the cybersecurity community, and all the people that are working in that field already share a lot of different information. And the goal is basically to take the knowledge of a specific organization or specific people and spread it across the entire industry. So that's very important in the threat intelligence field, to be able to share some information. The fact is, today we are sharing information through blog, through indicator of compromise, feed of indicator of compromises, and all that kind of information. But it could be also very interesting to share that knowledge through different kind of processes. And I believe that Jupyter notebooks applied to threat intelligence is also a perfect example of knowledge sharing. In fact, notebooks can be applied to different kind of field in the security industry. The good thing with notebooks is that you can use them with several languages, such as Python, C#, C++, and many more. And we know that in the cybersecurity industry, we are working a lot with Python. So this is a really good tool to document some of the code and the process we are using. Notebooks can also be used for data analysis and data science. For example, if you want to explore some machine learning applied to cybersecurity or analyzing different kind of data. It can also be applied for threat intelligence analysis different kind of information such as data leaks. And yesterday, Ashwin presented a cool talk about how to analyze different credential leaks. And we also had some cool talk about threat hunting and threat intelligence, also using Mystic Pi. Notebook is also very efficient for incident response. Like, for example, if you want to build a procedure for forensic analysis or even log analysis, you can totally do that with a notebook. And of course, you can use it for enriching data, indicator of compromise, and creating visualization. I think that's also one of the most powerful features of notebooks, creating visualization and putting the data, making sense of all the data you have. Threat intelligence sharing using notebook is also the main topic of this talk, actually. And I think it's very interesting to use notebook in the threat intelligence to exchange the knowledge and practical analysis. When you are sharing some information about a threat, you are not always sharing about the procedure to analyze the threat. And I think that using Jupyter could help mining this gap. The good thing with threat intelligence using notebooks is also that you can share workflow and procedure to analyze and share some practical tools to your team and to the community. And the goal with that practical tools will be to be reused for any other use case. So that's the beauty of notebooks, and that's how we can use it in threat intelligence. Okay, I would like to talk about some of the notebooks I've wrote and some practical example. So that one is a notebook which I created, and it's actually using the VirusTotal API. And the good thing also with notebooks is that you can create some interface. In that case, I use the library IPyWidget, and it's a simple interface where you can look for a specific observable, an IP, a domain, a hash, and you can add a specific filter. So in that case, I look for a specific IP, and I want to filter for the samples that are communicating to that IP, and I want to get the samples that are only flagged as being emoted, and I get the result. And this kind of tool is super simple, but also very powerful, because you can you can run this notebook in a server or in Binder, and everyone in your team can access to the notebooks and use directly the specific notebooks to request some of the data. Another one that I did was in early 2020. At that time, ransomware website leaks were actually skyrocketing, but they didn't have yet all the resources online and all the websites that are currently monitoring the websites. So at that time, with some friends, we decided to create a scraper to get the information from the number of leaks from the ransomware website leaks. And I actually created a Jupyter notebooks to making sense of that data and exploring the different information that we had in the data we scrapped from the leak website. And in that case, you can see just some statistic about the number of leaks per ransomware family. Another use case that I've been working on by the past is using some malware similarity using the Jacquard distance and graphies. So what you can see on the screen is basically some experimentation about strings similarity. On the left, you can see 3 different clusters. And so the samples that I used are part of the North Korea arsenal. And in that case, I wanted to isolate different malware family from the samples that I had. So what I did, I extracted the strings from every of the samples that I had, and I calculated the Jacquard distance between them just to understand the similarity between them. And I get the result of 3 different clusters with 3 different malware family. And when you see a line which is built which is a bit bold, that means there is a high similarity between the two samples. On the right, what I did, I actually just extracting one of the common strings that was available in those samples, and I wanted to put in perspective which samples were using actually these specific strings. So this was some experimentation about malware similarity and also visualization, just to understand what kind of malware have sharing similar features between them. Another use case, so this one is extracted from one of my notebooks, which is currently connecting to my ELK instance. So basically, I used to aggregate and index some data in my ELK server. And I used to build some Jupyter notebooks to making sense of the data, extracting some of the information, and doing some further analysis. So in that case, what I did after requesting my ELK instance, I get some of one of the samples that I wanted to get more information. And I used Mystic Pi to get more information about this specific sample. So I started with a hash. And I wanted to get the domain which was related to that specific hash. It's actually a Remco strat. And from that domain, I wanted to understand if there was more sample that was communicating to that domain. And I extracted all that samples. So that's very interesting because from a huge data set, you can investigate and pivot from a single samples to different kind of indicators of compromise, such as a domain and different and additional hashes that are connected to that domain. Another use case is exploring the contileaks, and I will actually show you briefly the notebooks. So last February, when the contileaks are basically leaks related to the Conti organization. And what I did with a part of the contileaks, which is actually the Jabber logs, I wanted to explore that data in a meaningful way, and I decided to build a Jupyter notebooks around that data just to explore some information. And I will show you briefly some of the data I extracted from there. So the beginning of the notebooks is just some explanation about what is the goal of the notebooks, what kind of data we have in the leaks, some configuration. And then I started to explore the logs. So the logs were actually compiling in a JSON file, actually a JSON file per day. So the first thing I had to do was to merge everything into a single JSON file that I can use directly with Python. As soon as I merge everything into one single file, I created a routine to translate the logs, because the logs were actually the chat were actually written in Russian. So I wanted a simple way to translate everything into English, just to be able to understand the logs and getting more information about it. So I did that using the Deep Translator library, as you can see here. What you can do, what I did after loading the different, loading the logs and translating the logs, I also started to explore that information, and I realized that some of the logs, some of the words were not correctly translated by the Deep Translator library. So someone on Twitter published a proposal translation about the slang. So what I did, I created a dictionary, and I actually browse all my logs and replace every slang that was incorrectly translated by the correct translation proposed in the dictionary. So automatically, I get more details about, I get more information, more useful information about the logs, and I've been able to correctly translate the information written in Russian in English. Then the next thing to do, mostly when you are working with a lot of data, the first thing to do is basically to have an overview of the data before to deep dive. So what I wanted to have here is basically extracting some timelines just to visualizing what kind of what days the users have been the most active. And I created this simple timeline just to visualize the different the number of discussion per day. But this one was not super useful. So what I did using the Bokeh library, I actually generated a dynamic graph where you can just put your mouse over some of the line and get some additional statistic. And I think that's also very interesting because with Jupyter, you can analyze your data, explore your data, and you can also create some visualization like that to have an overview of the data. Another thing that I did is creating a kind of search engine. So basically what I wanted is a simple way to explore the logs by looking for specific keywords. So what I did here, I created a small search engine where you can actually run, you can actually enter a specific keyword, let's say, for example, BTC, and search for it into the chat logs. And I've been able to extract every conversations that was related, that contains the BTC keywords. And it was also very useful if you wanted to get information about get the conversation and the discussion about the specific users. If we have a look with the users Stern, for example, we can get more information about the discussion from that specific user. And you can filter specifically by some specific keywords. So this is a simple and basic way to extract some relevant information, but it was super powerful because I've been able to extract and to target specific information that I wanted to have during that investigation. Another thing to do with that kind of logs is actually putting in perspective the relationships between the users. So what I did here, I put in perspective the users by having some statistic about which user were the most active and sending the most messages into the chat logs. So here we have the most active users. And I also wanted to have something a little bit meaningful and see the connection between the users. So what I did here using the PyVis library, I created a dynamic graph that you can explore and zoom in, zoom out to search for a specific users and see all the interactions these specific users have. And this is very, I think this kind of visualization can be very useful for the understanding of the most active users and the most important users in the chat logs, but also to identify some specific users that was probably less active, but was part of the affiliate network as well. So this kind of dynamic visualization is completely possible with Jupyter notebooks and is super great. This one is an example, but you get my point, and you can imagine what you can do with some dynamic visualization. The next thing that I did with that specific notebooks is actually leveraging Mystic Pi for enriching some of the data and extracting some of the most some relevant information, such as indicator of compromise. So what I did here, I actually used the IOC extractor, IOC extract module from Mystic Pi to automatically extract indicator of compromise, such as hashes, domain name, but also IP address. And which is very powerful with that specific module is that you can also add your own regex. So in that case, I added a regex for Bitcoin address, Bitcoin wallet. And so I also extracted all the wallet that was discussed in the chat. And it was very powerful as well to just get more information about some of the money that was exchanged between the users. So I did a bit of cleaning because some of them were also some false positives. So I had to analyze a little bit more and clean a little bit all the indicator of compromise I was able to extract. What I did as well, I did a little bit of enrichment. In that case, I used green noise, OTX, and various total from using Mystic Pi and the TI lookup provider just to enrich some of the data that I had and get more information about them. Here, I get some information about DIPs. Some details about a specific IP that you can also do with Mystic Pi, and additional details like here. I wanted to create a map. I'm not sure if I run. Yeah, I didn't run it. So yeah, basically what you can do here is extracting automatically some relevant information such as indicator of compromise, and started to enrich all that information just to make more sense about all the data and understand pretty much everything. And yeah, that's it about this specific Jupyter notebooks. It is available on my website, so if you want to have a look, feel free. Before to conclude on that presentation, I'd like to share with you some Jupyter threat intelligence tips, and basically the kind of process and best practice I try to use when I'm creating Jupyter notebooks. So first of all, when you are creating your notebooks, be sure to include every time the setup instructions. Like the library that you will use, a brief introduction about what will be discussed in the notebooks. I think this is very important for the next person that will reuse your notebook, just to do not spend too much time on configuring everything and installing the package that you are using in the notebooks. The second thing is, before analyzing different kind of data, is getting to know well your data. So before starting to run some code on the data, extracting relevant information, be sure to understand the structures, the file format. Is it a CSV? Is it a JSON file? Is it an unstructured data format? I think this is really important to take the right decision to start analyzing your data. Then, as soon as you started to load your data into your notebooks, the next thing is to have a broader understanding before deep diving, meaning take some time exploring your data, take some time understanding what kind of data are available in your data set. And you can use visualization to doing that. As we saw with the Contelix, you can create some statistics, exploring the user's connection, for example. Visualization is probably one of the most powerful feature of Jupyter, especially because it allows you to directly visualize what kind of data you are currently analyzing and looking and exploring. Then do not hesitate to document what you are doing and also your code. That's also the power of Jupyter. You can document pretty much everything you are doing, document the code, document every steps of your analysis. And then share your notebook with your team and with the community if the data and the notebooks is not sensitive or confidential, because it will benefit your team, but also the community. And finally, get feedback and improve your next notebook. So that's basically the process I try to use when I'm starting a new Jupyter notebooks. And yeah, this is the kind of the tips I wanted to share in that presentation. I also create different Jupyter notebooks which are available on my website, so you can have a look to it and reuse directly the code for your own purpose and your own goals. Some of them can be run on Binder, so you can completely reuse the code on Binder in your web browser without downloading the code. And yeah, if you want to have a look, feel free to check it. To conclude on that presentation, I believe that sharing data is nice, especially in threat intelligence, like blog report, indicator of compromise, and so on. But I think that sharing how to analyze that data and how to process that data is outstanding, because you're not only providing information, you're also providing knowledge through the sharing of Jupyter notebooks applied to threat intelligence. Jupyter is the perfect companion because you can workflow and high-value procedures that will benefit the team and the community. And you can also the power of notebooks is this is repeatable, explainable, and most of all shareable. Through that presentation, I wanted to demonstrate the value of threat intelligence sharing using notebooks and how the community can learn through our analysis processes and workflow. As discussed at the beginning of this presentation, sharing knowledge is not about giving something to someone, it's about creating a learning process. Thank you very much for your attention, and if you have any question, just feel free to let me know.
Awesome. Thank you very much, Thomas. Very, very informative. I mean, the I would say best example into some of the areas, right, that Jupyter notebooks could be so useful. I like also how you were able to, let's say, like you were able to accommodate your use case to a Jupyter notebooks. Say, for example, the Conti leaks, right, chat logs, right? Rather than probably doing like a search and replace, or no, not search and replace, but a search of a specific string by doing a Control F and then opening the document, right? You kind of like accommodated that use case into how can I use a notebook to not only do a search, but they've been able to even like present it in a way that makes sense and it can be consumed by by you and by others, and how you build also those like a kind of like a dashboard search capabilities, right? And the code on the top to explain the logic. I think that that's a perfect example that you can continue doing Control F if you wanted to, and then go through all that. But there are other ways, other things that you can do. And Jupyter Notebooks is a great tool to,
Exactly.
to empower you. So.
Well, I used Power F, Control F to searching the logs at the beginning, but then I wanted to have a meaningful way to extract some of the information and also something that I could share, because Control F, I mean, you cannot really share it to the people, but building a full procedure of analysis, I think it's way more powerful.
Yes. So I think that the key word, like you're saying, is like sharing. It's like once you want to share this so that someone else can reproduce, go through the same process that you went through, right? It's very important to have something that would be easy to consume. Once again, I think that those are the keys, because yes, people can, like I do it as well. I just Control F. GitHub, I learned how to do like the searching in GitHub, but of course GitHub has more capabilities than GitHub search, right? Then so I kind of like that just basic process, that for anyone in the call, or for anyone that in the stream, or anyone that will watch this in the future. So I think that it starts from there, right? How can you take some of the things that you might be already doing right now that you might not feel that there is much that you can do to improve the process? If there is something that you can programmatically do, I mean, at Jupyter Notebooks, it's a good way to start going that route, and then that would set you so that you can then share that with somebody else. I think that that's the key, right?
Exactly, and you're not only sharing a specific process for a specific data set, because people that will use that that notebooks can also apply this code for something else, another data set as well. So this is not only restricted to the data set when you are sharing the notebooks. It can be applied to many different kind of sources.
Yes. Ian, you have a question, right? I think.
Well, some kind of like questions. I mean, I was wondering, maybe while I'm asking, I know I'm putting Thomas on the spot here, but maybe I think we have a couple of minutes. Maybe you could show us. You did some kind of prototype of like a searchable notebook, I think, for your own notebook.
Yeah,
it was kind of cool.
It's actually still a work in progress. Unfortunately, I wanted to discuss more about it today, but it's not ready, unfortunately. But as soon as we have something more ready, I will be happy to share it with the Jupyterthon community.
Okay, I really like the use of PyVis, right? The graph. Because we struggled a bit because that works in a sort of a slightly weird way that it it creates by default. It's got a nice Python library, but by default it creates like an HTML document, and then it creates an iframe and displays the document inside. Which works on most platforms, but not on others. So we need to support like Azure machine learning. It doesn't work in that environment. I'm not sure it works that well in VS Code, but we found a way through Adine. One of our co-workers worked out a way to be able to kind of display that. So we're going to kind of, because we've been wanting like an interactive graphing tool that doesn't require you to install, some other additional process running it outside. So we looked at that, and we were going to add that to Mystic Pi as like an option. So that would be cool. And it was also really powerful, like even quite simple kind of like line graphs and bar graphs. You don't need like necessarily very complex visualizations to show you like patterns of things. I'm a big fan of doing that. Sometimes even if you can't see the detail, you can see from the kind of the broad sweep of like, thousands of events across 3 weeks. Just the changing pattern is useful on its own.
Yeah. So I don't know if we have any questions in there, but I have one. So what is your favorite library, I guess, for specific use cases, right? So let's say for malware analysis, right? What is your favorite? What is the one that comes to your mind? You're like, oh, this is the one that at least you should have that.
For malware analysis, I'm actually rely a lot on Capstone and Killing, which are two different tools for disassembling and binary instrumentation. So basically, you can run it and just get more information about the samples and reverse engineering some piece of code and creating some routine as well. This is very powerful when you have to do some decryptions or some reverse engineering task. But yeah, that's the one that came in my mind. Capstone and Killing.
Nice. Awesome. Thank you, man. Thank you. Yeah, I think that's sometimes when you want to dive into some of the topics, because that's how I also think sometimes that if I want to for example, use a Jupyter notebook for something that is not what I see all the time, right? I say, all right, what can I do from a malware analysis perspective, right? And then I try to figure out like what to dive into first, or what to learn at least. And there is so much out there to like try even for similar scenarios, that it's good to hear from someone that has probably gone through a lot of libraries testing what is the best for some of these things. So super useful, man. Thank you for
I actually wrote a blog post about the 10 library for reverse engineering and malware analysis.
Yes, you did actually. Here it is. 10 Python libraries both for malware analysis and reverse engineering. Okay, I'm gonna put that in the Discord. I like that.
Yeah. Awesome. One thing we might want to talk about in the speaker panel is there's already like a bunch of ideas for that, but the one of the things that struck me as I was watching Thomas's notebook, and that's true of some of the notebooks we saw yesterday as well, is being able to extract like a chunk of them. We had this, we actually published a kind of like package called Mystic Notebooklets, and the idea was like a chunk of a notebooklet that did some kind of bit of functionality that was more kind of reusable and maybe accessible than, because that's one of the things with notebooks. Often you see like a long notebook, and it's like, how do you, I really like this bit, but it may have a dependency somewhere else in the notebook. It's like that would be a kind of nice thing alongside the notebooks to be able to extract like the PyVis part, or like, hey, let's make this kind of reusable, and without necessarily going all the way to like checking it into a kind of formal package like Mystic Pi or something like that. But like, here is like from this notebook, here are the kind of reusable chunks, and I can just import those. Jupyter doesn't lend itself to that, but there are other things like Jupytex and stuff like that help you do that kind of thing. But maybe that's something we want to chat about later on. It's an interesting area for me.
Definitely.
Yep. I don't think we have any questions. If you have any questions for Thomas, feel free to add him to the Discord thread in there. And one last thing that that I wanted to at least share before we go on break, because we're supposed to go on break for 5 minutes right now. But so Thomas also is the creator of some of those cheat sheets, I think it is, like for how to use grep, awk, like all diff, like all those different things, and they are super famous. I mean, I see him everywhere. Like, yeah,
it's crazy, right?
it's crazy. Like I really like him, so I think that's something would be nice to share.
Sure.
Yep. So thank you on that for everything you do. There are so many different resources. Like, when someone goes to your site, first of all, I'm super jealous about your site. It has like a great color, great way to dive.
Thank you.
Dive into all that knowledge, and you have like everything in there, man. There is a lot because it takes time to to do your day-to-day job, right? And then plus do all these other resources on the top, and making sure that they're organized so that people can actually benefit from it. First, it says a lot about you as a security researcher and also as a community member, right? So, I want to thank you. I love to see those things. So I appreciate everything you do, man. So thank you very much.
Thank you. That means a lot. Thank you very much.
Awesome, man. All right. So, yep. Go ahead.
Hey, Thomas, if you can
go ahead.
Paste the URL to your site in the chat, I'll kind of leave it up on the screen over the break.
Sure.
Yes. Okay. Yep. What were you gonna say, Thomas?
I was going to say that for the colors, I'm actually blind color, so that's why
okay.
that's probably the secret why it's not so difficult for me to pick different kind of colors.
Nice. Good to know. Yeah. Good to know, man. All right. Thank you, Thomas. Right. And we're gonna go on break. Thank you, man. And we come back at 11:30. 11:30, so just a few more minutes, like 3 minutes, 5 minutes. We're going to go back, and then we have our next talk, Becoming a Cyber Data Analyst, my first machine learning model by Jose Rodriguez. So to join us in only a few minutes. All right. Thank you. right. Cool. So thank you very much, everyone, for coming back. Just a few minutes, right, of a little break. And so with us today, we have for our next presentation, Becoming a Cyber Data Analyst, My First Machine Learning Model, we have Jose Rodriguez. So Jose is actually my brother. It's actually amazing to see him also in the industry and working in security. And the cool part is that, for example, just to give a little story, just how I've done it with other speakers as well, is so Jose, his background is a lot in, let's just like plain simple mathematics, right? Like he was a great student overall in math, teaching math, helping others in math in high school, in college, etc. And then when he came to the States, right, with me, we started trying to figure out some of the things, right, that we could do together. And then I say, hey, Jose, why don't you start, applying your mathematical, concepts, things that what you learn, and your experience teaching and sharing it with others for cybersecurity. And I'm still very, very impressed, not just because it's my brother, but seeing someone going through, learning a new language for both of us, right? Learning English, but then trying to learn a new thing, like in cybersecurity, with so many things to do, take something that he felt comfortable with and then apply it to this field. It's amazing. It's amazing to see that process. And I love that he's also now sharing his knowledge, his expertise with the MITRE ATT&CK team. So he now works for the MITRE ATT&CK team. He's helping on the defensive side of things. For example, you might know that there is a data source update into the MITRE ATT&CK framework. So Jose was kind of like the mastermind behind it, kind of like under, just kind of behind the curtains, right? Doing all that awesome work and trying to share it with the community. So thank you very much, Jose, for everything you do. And so super excited and looking forward to this one, because I really want to build my first machine learning model. I have never done one, so I think this might be the one to do it with. So take it away, Jose. If you can share your screen, and then we can start the presentation. All right, I think we're having some technical issues in here. Actually, Jose is like in the same place as me. He's like across here. So I'm trying to be like, all right, I need to mute myself and stop my volume here and try to make sure everything works. So I think that's just maybe kind of causing some of these issues, but let's see. So he's like rebooting maybe his computer, right? Are you rebooting your computer? All right, so let's just wait. I mean, technical issues in there. But something about this presentation that I actually like is that, for example, every time you think about, how to actually, build something, right? Usually when you talk about people that are doing machine learning, it's kind of hard to it's kind of hard to to actually understand even like what the goal is sometimes, because of the terminology of several things in machine learning. As a cybersecurity analyst, it's kind of hard. So when I talk to Jose, it's kind of cool to see that when he tries to explain his methodology, he says, I'm calling it this way because of these other things, right? So it's pretty interesting to to have that thing. And explain stuff. So I'm going to just pass it out to Jose. He's ready. I'm going to mute myself and then add your stream. So give me 1 second, Jose.
Okay, can you guys hear me? Okay.
Yep, we can hear you.
Okay, thank you. Just give me 1 second. Where is the... there it is. Okay. Okay, thank you. Thank you all for the introduction. Thank you, Roberto, for it's always very interesting to learn something new here in the cybersecurity industry. Every week, every time I'm researching about a specific topic, I always learning something new, and that's what I like about this field. And I'm happy to share the basic knowledge and everything I'm learning every day about how to implement data science techniques into cybersecurity. Roberto already introduced me. I go by CyberPanda H in Twitter. I work with the Minor Attack team, and I consider myself a future bartender. I'm currently learning a lot of things from YouTube, so that's a new hobby for 2022.
Can you change your stuff to slide mode or not?
Just
slide on the top side. So there you go, and present from. There you go. Awesome. Thank you.
Yep. Okay. So the agenda for today is, I'm sorry. So the agenda for today is we are going to cover the basic ideas of detection analytics in cybersecurity, the cyber data analyst role that is related to this type of task within the industry. And then we will start talking about one of the main skills or knowledge that we need to have in order to accomplish this type of role in the industry, which is data modeling. And then we will focus our analysis in predictive analytics, and we will share at the end a basic use case on how can you start developing your first predictive analytic model. And the ones that I will share today, I will share just basic ideas of about logistic regression and artificial neural networks. So detection analytics. Why detection analytics? Let's start understanding the concept of a data analytic. A data analytic is basically how you use data in order to drive and support your decisions, right, and actions. That's in general. That's the concept that you can apply to any industry. And then there are three basic methods that you can use when developing data analytics, which is descriptive, predictive, and prescriptive. So the idea of this presentation is how can we start applying these concepts into cybersecurity? And in order to do that, I would like to share with you a basic detection research process, which is the one that we use, Roberto and I use a lot, and also we share with the open thread research community, that goes all the way from defining a research goal, all the way to validating detection strategies, documenting the whole process, and sharing these with the community. So currently, like most of the use cases that we have when trying to apply data analytics is it considers descriptive analytics. So we are trying to identify what already happened in our environment, right? So to give you more details about this, let me share with you a really quick story. So this is a timeline, and in different organizations, we are constantly generating events. And some of us are collecting these events, and we can, at some point, a malicious event could happen in our environment, right? So in general, I would say it takes some time to identify this vulnerability that has been exploited by adversaries. So once we identify this potential vulnerability in our network environments, what we start doing is analyzing the threat, analyzing the vulnerability. We start understanding the adversary tradecraft, and so we start defining a detection strategy. And then once we come up with a strategy, what we do is we start querying our database, right? We start querying our database to validate if this malicious behavior has happened in our environment. So the idea of this presentation is how can we start reducing the time between since the malicious activity happened all the way to the identification of this malicious behavior. So what I'm proposing is we already know, we already understand our environment. We know how to use descriptive analytics. We already know how to query our data, check whatever happened in the past. But we need to also use a predictive approach which will allow us to collect, aggregate, analyze, and model the data. Now, I'm not trying to say that we need to change what we are doing right now in the industry. We need to complement that approach, because you cannot predict anything if you do not understand what is happening right now in your environment, right? So you might be asking yourself, okay, but why do I need to learn about data modeling? Is this something that organizations are investing in this type of activities? Well, actually, just to give you an example, I will share with you the cyber data analyst role that is part of the NIST workforce framework for cybersecurity, aka the NIST framework. So this framework provides you with information about different roles that you will find in the cybersecurity industry. And the information provided by this framework is not only for us, like people that are working in the industry, it's also for employers and also for education and training providers. In fact, I've checked the other day. I was checking certifications that are being mapped to this framework. Within this framework, you will find 7 categories, and then we will focus on the operate and maintain category, because this one gives us some specialty areas that are related to data administration. And within data administration, that's where you will find the data analyst role that you can perform in the cybersecurity industry. And what I really like about this framework is that they provide you with different context about this position, abilities, knowledge, skills, and tasks that you will perform if you're working in this type of position in the industry. You can read more about it in the link below, but something that is like very or pretty common in all the descriptions of this content is the use of data. How can you start modeling your data in order to come up with some ideas, some more insights, so you can support your decision process when trying to identify malicious or non-malicious behavior in your network. So let's start talking about data modeling, right? What is data modeling? A data model is basically something that you use to describe reality, right? In this case, it will be our network environment. But let's say there are 2 basic types of data models. One type, which is called first principle, which is basically, let's say, just to give you an example, if you guys remember a little bit about physics, there are some formulas, concepts that you can apply to any scenario. Like, for example, let's say laws of motion, right? For Newton. You have a formula, and any observation that you can take from the reality needs to follow this rule, this formula. That's one approach, right? So you first have the model, and then the data is aligned with this formula or this model. And the other type of models that you can develop or create is those that are based on data. So you don't have that formula, that magic formula that relates all the variables that you have in your network environment. So you need to start from the data, and from there, try to identify the relationships, hidden patterns among these data elements, so you can create the data model, you can create your formula. There are different modeling approaches, kind of similar to the methods that I described before. So we start with descriptive, right? So what has happened in the past or is happening now and why, trying to understand our data, our current environment. And just to give you an example of this type of data models, back in 2020, I made a presentation with my friend Jamie Williams, also from MITRE, where we talk about how to model an adversary performing a persistent technique in an environment based on the data. So after understanding the relationship between objects, we were able to aggregate all that data and generate, this is what we call a query, right? A detection query, where we started to aggregate, correlate different events, trying to identify the malicious behavior. So as you can see, there is no mathematical formula. Is basically, the formula is just the query where we are performing joins or just aggregating data, right? This is I would say a basic and a really good example of a descriptive analytic. And then the other level is the predictive one, which is the focus of this presentation. We need to identify a way to predict whenever we have a new network connection, whenever we have a new event in our environment, how can we reduce the gap between the generation of the malicious event and the identification of the same one. And then the last one is the prescriptive, which is, I would say, an application of after you define something, what are the next steps, right? It's like you are getting a recipe from the model. That's not part of this presentation, but it's something that you need to consider when you're learning about data modeling. So as I mentioned, we will focus on the predictive type of models. So let's start talking about predictive modeling. How can you start developing your own predictive models, right? So we will use as a reference the cross-industry standard process for data mining methodology, aka CRISP-DM. So this methodology is kind of old. It's from 1996, but what I like about this methodology is the sequence, the basic sequence that you can follow when developing your models. This methodology consider 6 steps, all the way from understanding the project. When I say project, I mean the goal, right? What is the goal of this project? What are you trying to, I would say, what is the question that you're asking to your data, right? What are you trying to accomplish with this model? All the way to the deployment. In this presentation, we will cover all the steps until evaluation. The deployment is more like a data engineering, maybe type of activity. But we will focus on the other 5. So this is the basic sequence, right, that you can follow. And then sometimes after the evaluation of models, you can deploy the model, or sometimes you just need to go back and redefine your goal because the data or the model is probably not helping you to accomplish your goal, right? And you need to restart the cycle again. And which is also important is that in the center, you will always have the data. Remember, you need to collect data in order to be able to develop this type of models. Now, in the process understanding, as I said, you need to define the goal. What is what you are trying to accomplish? In the data understanding is the data that I'm collecting. Is this data helpful for my goal? How is the data being collected? Is this process also helping me, etc.? Once you understand the data and you validate that data is kind of aligned to your goal, you can start preparing the data. You might probably need to transform your data. You might probably need to, I don't know, maybe remove the data that is irrelevant. And this step, data preparation, is aligned with data modeling because you need to prepare your data based on the model that you are trying to create, okay? And then the evaluation step is always a good practice when you're developing predictive models, that you need to create more than one model, okay? Different approaches, different algorithms that you can use so you can compare your models, you can compare your results. And of course, at the end, if everything is good and the model, like the evaluation is successful, you can think on deploying this model in your environment. So let's jump into the use case on how can you start applying each of these steps, okay? Let me I will change to here. So the data set that I'm gonna use is a public resource from on GitHub. It's from this book, Machine Learning for Security Cookbook. The data set is a subset of a KDD data set. Is a knowledge and discovery and data mining tools competition. So the data is a subset of a bigger data set. But I think it's good if you are starting to learn about predictive modeling. And the data contains network connections context. So we will see in a little bit. So for this presentation, I have prepared this notebook. I was kind of surprised yesterday when I was listening to Roberto and Ian, kicking off the conference, that most of the attendees to this conference, they are kind of interested in Python. So that's what I said, well, why don't we try another language like R, right? So I can also show you how R is also, I'm sorry, how Jupyter notebooks are also flexible and allow you to work with different languages, not only Python. And I will tell the story using Jupyter notebooks on how to create these models. So the first step was project understanding, right? So the idea is in this phase, you need to answer to questions like, what is the problem? What is the expected benefit of this project? And how would a solution look like? So the problem is simple. This data set, as I mentioned, it contains network data that is tagged with normal and not normal connections, which means malicious and non-malicious behavior. So the problem is we need to define a model using this data. We need to define a model that will allow us to identify malicious behavior, right? And the expected benefit is that, of course, if the model can identify malicious behavior, we can start defining response and mitigation processes, right, in our network. And how would a solution look like? I would say we need a model that allows us to tag. Another word that you can use is maybe classify. I will give you a more detailed explanation later, but the idea is to define a data model that would allow us to classify or distinguish between malicious and normal behavior. Okay, so that's the goal. Okay, remember that one. The second step is data understanding. So in this phase, what we need to start asking to ourselves is, okay, what is the data? What data are available, right? So as I mentioned it before, it's a data set that we will load into our Jupyter notebooks using R, and we are going to represent this data in an organized way. And when I say an organized way, I'm talking about a data frame. And think of a data frame as a table, right, where each column represents a variable and each row represents an observation, right? So I will also try over the description of each phase. I will try to, on purple, I will pull some of the terms that you will probably read or listen when someone is trying to explain to you the basics of data modeling or predictive modeling. So I'm going to use the term observations for every row, okay, and the term feature for every column, which is basically the main idea here. Identify what are the features or variables that you have in order to create the model, and what are the observations that you are going to use, that you are going to analyze to find the relationships. Okay, something very interesting about this data set is that we have, if we check the dimensions of the data frame, we have 41 columns, and then we have more than 40,000 records, which is good. We have more observations than columns. You need to be careful in case you have less observations than columns. Then the type of analysis would be different, or it might be impossible. Now, something interesting about this, all these 41 features, is that we need to identify which one within this data set will be the most important, I would say, feature that is related to our goal. In this case, there is if you use the str function, there is a variable at the end that is called label. This variable gives you the tag if the connection is normal or not. So in predictive modeling, that variable that contains, like the information that is part of your goal, that's what we call the response variable. Okay, that variable will contain the information about that is related, that is directly associated with the main goal of your project. In some cases, you might have this variable. In some cases, you might not have this variable. I will tell you the difference in a little bit. The rest of variables, that's what we will call the predictors. Okay, we will use predictors, which means the other features, to identify the relationship between these predictors and the response. So let's keep reading or understanding, getting a better understanding of our data. And the other thing that is important to note is that R, similar to Python, when you load a data set, these programming languages, they guess the type of data. So it could be from a programmatic perspective, right? Integer, characters, long, etc. It's kind of different than, for example, Java, where you can define the type of data since the beginning, right? But let's add more context about these data types from a more predictive analytics perspective, right? So there are some basic classes that you need to consider that are categorical or qualitative, and quantitative or numerical. Categorical data is basically you are describing each observation using a characteristic, right? A tag that you can add to the data. And the quantitative or numerical, we all know about this type of data. It's just basically numbers, right? That describe our observations using numbers. The difference between a number from numerical and a number from categorical is that when you are working with numerical data, you can the mathematics behind or the mathematics when using this type of variable makes sense. Like you can add them, you can subtract them, you can multiply them. Okay, but in a categorical variable, you cannot do that. For example, if you talk about categorical, imagine an IP. It's a number, but you cannot add IPs, right? Now let's continue with our analysis. So one example of nominal data is flags. Then we have examples of discrete and continuous variables, count and duration. And I'm using here the his function to show you how can you understand more about this data, like from visually, right? Using in this case a histogram or it's kind of like a bar plot. Now, the other step when understanding our data is how is the data relevant to the problem? And we already talked about this, remember, about the response variable. The response variable for this data set is the column that is called label. So label has all the features, or sorry, all the values that allows us to identify a network connection as normal or not normal. Now, it is important to identify if we have this response variable as part of our data set or not. Why? Because depending on the type of data you have, and if you have or not the data in your data set, that's how you can start defining, okay, what are the type of algorithms that you can start using in your project. So if the values of the response variable are given in your data set, and you also have values for the predictors, you are working in a supervised learning type of models, right? And within the supervised, if you have the response variable in your data, in this case we have label, right, with all the different type of attacks. If the response variable is quantitative or numerical, you can perform a regression analysis. If your response variable is categorical or qualitative, you can perform classification tasks with your data. If you only have the predictors and you do not have the response variable as part of your data set, you are working in an unsupervised learning environment. And then you can do clustering, which means grouping of data, or you can just try to reduce the dimensions of your data set so you can improve the visualization, or you can improve the analysis. You can expedite or facilitate the analysis of your data. And the last one is reinforcement learning, which is kind of between supervised and unsupervised, because in reinforcement learning, we do not have the response column, the response context, but we can add that context using rewards. And that's something that we are not considering for this presentation, but feel free to reach out to me later so we can start talking more about reinforcement learning. And there was also a really nice presentation yesterday about this. Now that we understand that our response variable is categorical, right? Sorry, are we good with the time?
We're good. You have another 10 minutes.
10 minutes, okay, thank you. So now that we know the type of response variable that we have and the type of analysis that we can perform, we can define that our response variable, right? We have that variable and the data in our data set, which is a qualitative response variable. So that means that we need to, when we are defining the algorithms or models that we are going to use in our project, we are working in a supervised learning environment. And since the response variable is qualitative, we can perform a classification analysis with that data. Okay. Now, regarding data quality, quantity, and recency, there are different ways to analyze, different approaches that you can use when analyzing your data to get a better understanding of it. But I will share with you some basic ideas. Like, for example, if we talk about data quality, right? We need to understand that, as I mentioned it before, some R or Python, for example, they guess the type of data. So we need to be sure that that type of data is aligned with the predictive modeling type of data, right? Now, but we will do that in the data preparation stage. Now, we are going to start analyzing variable by variable. That's what we call univariate analysis, right? You are going to analyze column per column. You can start using descriptive statistics. For example, in this one, we have just a counting stack operation on the response variable label. You can see here the different type of attacks. And something interesting about this is that, as you can see, most of the data is considered normal, and the rest malicious. But the distribution of values for the different type of attacks is not distributed like in a uniform way. We have more Apache 2 or back type of attacks. So this is what we call an imbalanced data. So we need to consider that when transforming our data. We need to find a way to correct this situation. Why? Because if we work with this type of data, we might add bias to our analysis. The model will focus more on those type of attacks that are more frequent. And then in numerical data, we also, it's kind of similar to the concept or the idea of unbalanced data. But in this case, if we start analyzing the distribution of frequency of the variables, we will see that we have some ranges of values that are more frequent than other ones, right? So you can use concepts such as skewness, right, which give you a measure of the asymmetry of the distribution. If it is kind of like centered, right, like a beautiful like bell in the center in the average of the values, but you can use the skewness function to calculate this metric. And this metric, if it is positive, it will tell you that the distribution is skewed to the right, which is kind of similar to this image. And a negative skewness will give you the opposite. So this is something that you also need to consider, because it is a good practice trying to transform our data to change this type of distribution to a more symmetric one. Okay. Now, what else can we do here? Oh, we also need to consider, we need to check if our data set contains missing values. And thank God, we don't have missing values in this data set, so we are good. But there are different techniques that you can use in case you have missing values in your data. Now, once we finish this first stage of univariate analysis, which means per column, we can perform a multivariate analysis, which means try to find relationships, interactions between all your columns. So in this case, what I like to do is I like to use the summary function just to get a better understanding of the minimum, maximum values of all the numerical values. And I like to do this because it is important to pay attention to the scale of the numbers. Again, similar to the unbalanced data, your model might I would say, tend to add bias to those variables with a bigger scale. Okay, so for example, if you compare the duration of the connection in seconds, the maximum value is 2100, but when you see source bytes, you see it has 107,000 bytes. So just based on the scale, the model might consider source bytes as a more relevant variable for your model. So you need to find a way to correct this situation. And one idea could be to standardize all the variables. So let's continue. You can also start learning about association between variables using scatter plots, which is a really good idea. This is a graphical approach. Or you can also start using, if the association between variables is linear, like in this graph, right? You can see there is the plot is it looks like a line. You can use correlation coefficients to try to get a better idea of the strength of the association between these two variables. Now, let's jump into the data preparation and modeling. Now that we have a better understanding of our data. A minute? Okay. So let me just jump directly to the model. So some of the preparation that you can do is, for example, remove data that is not relevant. Something else that you can do is, regarding the unbalanced data for the response variable, what you can do is just put together all the type of attacks and consider all of them as only one category. This is also good because you are preparing your model to face different type of attacks at the same time, right? Not focusing only in one. And the first model that we are going to review is logistic regression. Just give me 1 second. Oh, something important also is, it is a good idea to separate your data between training and testing sets. And this is just for cross-validation. So your model is prepared to analyze new data, right? So that's one way to make your model prepared to face new type of attacks. And also, we are going to use the testing data sets to compare prediction accuracy. So the first model that we are going to use is multiple logistic regression. So logistic regression is a model that actually is used when you are dealing with a response variable that is categorical. In this case, you have 0, for example, for non-malicious data, and 1 for malicious data. So logistic regression will try to predict the this type of variable, but not based on the value, not based on the zeros and ones. It's going to model the probability of a record of being a malicious observation. Okay, so it's not going to model the value itself. The model will work with the probability of an event being malicious based on the data that it has in the predictors. So you can use the GLM model or function to just put all the variables in R, and then we will use the binomial family. When I say binomial, it's basically to identify that we only have two possible values for our response. It could be malicious or non-malicious. And then R will give you all the estimation for the parameters for each of the variables. And then it will give you also, the last column is what we call the p-value, that will give you if the each of the coefficients is significant for your model, which means if you can use it in a model to predict the whole population of data that you have in your network environment. And in this cell, what I'm doing is basically making the predictions, right? If each observation is going to be malicious or not, and then from all the testing data sets, it classified correctly 12,000 records or observations, and it classified incorrectly 4. Now, the last one is going to be artificial neural networks. So in this type of models, what we usually have is neurons, right? We have a first layer on the left of all the variables or inputs. Then you have in the middle, you have hidden layers of neurons. Think of each neuron as a relationship, an equation that relates all the variables that are on the left, okay? So the idea of a neural network is to start identifying what are the best coefficients for each neuron So at the end, you have the last layer, the output layer. So you can use a neural network to classify this between malicious and non-malicious. And basically, what the neural network does is it starts with random variables as inputs. It goes to the right, which is also known as a forward pass, and then it goes back, and based on the values that it gathered, like the classification, if it is not correct, you can use backpropagation. It goes back to the input values and it modifies the values until it reduces the error of classification. That's when we use the graded descent concept, which is basically you run one iteration, it tries to matches all the points, it fails, then it tries to matches again all the points, it fails again, and then at the end it will find like the best estimation of parameters or coefficients, so your neural network can identify malicious and non-malicious behavior. And just to finish, this is the code to generate the neural network. And in this case, I got 12 elements that were classified incorrectly. So if you compare these two models, just a basic statistic that you can use is the misclassification error for logistic regression and artificial, which means what is the percentage of values that are misclassified. In this case, just by running this with the default values, the logistic regression performed better than the neural network. But if we start learning more about how to modify these parameters, we can maybe define a better artificial neural network model that will get a better misclassification error statistic. And that's it for.
Awesome.
Sorry for the delay.
Can you turn off your? Yep. All right. Yeah. Thank you very much, Jose. Yeah, probably just some technical issues at the beginning, kind of like short the time a little bit. But what I like is that you have the notebook, all the notes like very detailed, and how someone can go to the same GitHub repo that you use this use case from and kind of walk through, right? Like the whole process from data cleaning, understanding the goal, to actually going to the model. Having that methodology, I think it's great to see. So thank you very much for taking that use case, because sometimes when I look, for example, how to create a model like this one, the data doesn't match my use case, right? And I think that sometimes is where we stop, because I don't care about classifying or understanding how to recognize a cat, right? And that's just me. Like, that's just me as a researcher. When I see that, I just don't feel as engaged. But if I see network data and then I walk through a process with network data, then I'm like, oh, okay, now it makes sense. I'm looking into bytes, I'm looking into time. Those two values are not the same. So that's what it makes sense to, categorize my variables better. So yes, thank you very much. We don't have much time for questions, of course. So if you can go to the Discord channel, if there is anything. But thank you so much for sharing your approach and your methodology. So thank you, man. All right, Ian.
Hey, sorry, I was trying to mute and unmute because trying to keep echoes to a minimum. Right, so our next guest is Alex Maurice. Did I pronounce your?
Yes, Alex Maurice.
Alex works for Graphistry, like senior data science, like head of some of the artificial intelligence research. And for me, almost as exciting as that is his origins as a theoretical physicist. And I did want to ask him about like the current progress in string theory and whether that's still like, but maybe that's a discussion for another time. So Alex is going to kind of continue a little bit on. I can also put this useful URL for Graphistry. Continue a little bit of the topic that Leo started yesterday, and digging down into kind of specific details on UMAP and using it to kind of visualize kind of embeddings in event data and entities. So we're running a little bit behind. So without further ado, I'll hand it over to you, Alex.
Excellent. Well, it's a real pleasure to be here, and it's a pleasure to meet you, Ian. I just learned about Mystic probably a year ago, and really incredible stuff. It's a pleasure to be here. Let me see if I can share my screen.
Okay, I'll remove myself.
Let me see if I can get the right window. Doesn't seem to want to. There we go. Okay, so can people see my screen right now?
Okay. Yep, I think that's good.
Well, great. This is work done with Leo Majerovic, who's CEO and technical founder of Graphistry, Tanmoy Sarkar, who's an engineer that we just brought on and has been doing some incredible work. And I just want to shout out to Cody Webb, Thomas Cook, and Brendan Lodge. A lot of the work here has also been influenced by them, and really appreciate their inputs. So, what are we actually trying to do here? Now, just to give you guys a little background, I'm a data scientist, classically trained, and I'm not an expert in anything related to intrusion detection or things like this. But the beauty about this toolkit is, Graphistry and PyGraphistry in particular, is that it allows you to very quickly do exploratory data science at GPU speeds. So when I started looking at this, I learned from Leo and company here that alert fatigue is a big issue here for teams doing this. So what we're trying to understand here is alert fatigue, alert reduction, how to empower teams for incident response, and really at the end of the day, how to make exploratory data science really fun over what I would consider painful data. So just to give you guys a little bit about the different parts we're going to talk about here, we're going to describe Graphistry AI. Graphistry AI, we're trying to make it very simple for people to basically bring your own data frame and just drop it into the Graphistry API and build models very easily by just setting a few levers. Under the hood, there is featurization and UMAP. And I'm not going to go too much into those details here, but just rather give you guys a very high view of what UMAP is. So UMAP can be thought of as better clustering, and in particular, topological fuzzy clustering. So you can imagine now that you lay out your data in a certain way, and it's actually describing a surface in some high-dimensional space. UMAP is good at interpolating across that surface and then reducing it down to a lower dimensional surface. Also, it's the age of, we're in 2022 right now. There's a lot of old algorithms that have been used for a long time. UMAP is the modern version of that. So what we can do is, take these, Splunk data, logs data in general, and very quickly embed them and then visually explore them. I'm going to go over some use cases here in these different demos, and then at the end, we'll do some conclusions. So here, we're taking in quite a big data set of Windows events over many, many days. And there's lots of login data over many different systems. So this can be really thought of as a truly like maybe a mid-sized type company that is it has a tremendous amount of logins and things like that. So can we actually find computers that are acting anomalously? What resources are being accessed? Can red teams sort of spot the red team activity? And so on and so forth. Now, if you guys saw Leo's talk, he used an RGCN, which is a really nice, it's in this class of graphical neural nets. And these can be powerful ways of sort of understanding and embedding the data. What I'm going to be focusing on today is UMAP in general, and sort of doing essentially this sort of a dumb thing with it. You can just basically throw in the data and it'll organize it and understand it very well. So let's take a look at the data in general. We have source and destination. We have source computer and destination computer. We have some other sort of metadata here. And on the surface here, you're sort of wondering what this might do, but we can certainly plot it. And in this case here, we've got the red team data that was happening, post facto. So some red team group identified these things here. So we sort of have like an ace in the hole here. But let's see if we can actually identify them without actually knowing those labels in the first case here. So what I'm going to do is something very simple here, and I just want us to focus on these cells here. I'm going to create a new feature column where I'm just concatenating some of the metadata together. And I'm going to do this twice. And I'm going to look at the second one here, just source computer and destination computer, versus the first one here where I also include the auth type and the login type. Now, what this can be thought of, morally speaking, is similar to creating a 2-word sentence or a 4-word sentence per event that's happened there. You'll also notice here I'm dropping duplicates, and this is just a way so that we don't take into account multiple documents that we've already trained on here. Just for fun, I'm going to put the red team labels on the front of the data set here just so we can keep track of them for downstream modeling. And now we have a data set that essentially has put together these small documents here. And now all I have to do is throw that data into the Graphistry Nodes API. You might think that we should use the Edges API, but certainly you could, like this, and then just state which source and destination columns you want to bind. But in this case here, since we're just doing the featurization in UMAP, we really just care about featurizing that one column that I pointed out earlier. Now, there's some bells and whistles here that we don't have to worry about too much, but essentially setting certain combinations of these things here will tell the featurization engine under the hood exactly what type of model to build. In this case here, we're building something that's akin to a topic model. People might have heard of topic models. They're very useful ways of taking in, for instance, a corpus of news articles and understanding the different topics that exist in that. So the reasoning behind it is thinking of things like a business article will use certain words versus a biology article will use very different words, or a theoretical physics article. And so by understanding the co-occurrence of words within that space, it learns a latent distribution in that variables in those words. And then you can use that then and send that to UMAP. So I've enriched the data a little bit here. And let me actually just show you guys the plot itself. Okay, so right now, every event is a point in this space, but luckily I have a confidence score.
So we're not seeing the graph. Is that like maybe not shared?
Oh, is it? Let me see here. Oops. You know what? Let me actually just share my entire screen.
Okay.
Thank you for that, Ian. Okay. Do you see it now?
Hold on. Yep.
Hey, thanks, Ian. So this is now laid out every event as a dot in the plane. And what I'm going to be able to do now is in that enrichment call, I've added the confidence by which the red team labels were found in a given cluster here. So I've taken this embedding, and then I've used dbScan to basically identify all the different clusters here. So, there's a cluster number here, and I can actually color by that and show you guys in real time what that looks like. So you see it's done a very good job at identifying individual clusters as a cluster label. So now that I've got that cluster label, I use the red team introspected data, and I can actually then assess how many of the red team events actually occurred in each one of these clusters. So doing that, I find that there's a, oops, did I do the right one? Yes, this is the confidence. So you can see the confidences here are actually quite well. The different, these are very low confidence, oops, these are very low confidence scores here. So there's very low probability that you're actually going to find a red team event in here. Versus the ones that are colored red up on the top here. And let me just actually scan over so you can see a subset of them here. These are what we consider very high probability events. And so, if I'm a red team, doing this type of analysis, I can now encode the data. And if I now see a new event, it'll land somewhere in this plane, and I can very quickly assess, okay, if it lands in here, it's probably okay. If it lands in here, don't even worry about it. Anything in the purple sort of grape color here, don't even worry about it. And of course, that might be something that you have to run introspection on post facto again to make sure that that's correct. But certainly from this data set here, it's actually incredibly surprising that that we have such good ability to separate the data just based on the fact of computer-to-computer connections, along with a little bit of metadata. So just again, to see the relative strengths here, when I look at the different clusters, I actually see that there's a few clusters here where I get very few events, and they've got a tremendous number of other types of events. But eventually I get to a point where, cluster 4 and beyond, smaller events and very high confidence that these are potentially bad. So with incredibly little work, I've been able to then featureize under the hood, UMAP it down to a two-dimensional representation, and that's been able to separate the data in a way that allows a team to very quickly go from looking at something that's painful and difficult to something that's richly interactive and telling us something. Just for fun, under the hood, it's made this type of topic model. And if this was something like an article or a set of articles, you would actually see certain keywords come out in that article that would make sense to the human mind. But likewise, it's done the exact same thing here, but in the space where these things are actual documents. Now, another thing I want to do is just show you quickly that you can actually use the API that we've developed here. You've trained now on this data set. So now let's say you get another batch that comes in through whatever your logs system is, be it Splunk or whatever. And now you can actually transform that, get new embeddings, and then I can scatter plot it here. So this has the same topology as we saw earlier. The blue is sort of the totality of the data. The green is just a random sample that I've taken and then projected down. And then the red are what it predicts as anomalous or red team events here. And you see that these are sort of the areas where you might get some false positives, but these ones in general here are very good at distinguishing where the bad data is. So, this is like an incredibly surprising result that something so simplistic could be very useful. Now, I'm going to show you guys another version of this, where again, it's so incredibly simplistic, but it's incredibly powerful. So in this case here, we have another data set that that comes from excuse me. Yeah, so these are different IP addresses. They contain alerts, and they're trying to identify different types of observed events. So there's a lot of different things I could say about this, but for simplicity here, just look at the data. So we have a node, which were essentially the honeypots that were put out, and we have the target and source columns here, and they've got a tremendous amount of data in them. This data you could then munge through, you can then flatten, expand out, and do these different types of explosions that you'll see on the side here. But we're going to show that you can just actually just throw it into the API here. And what I've done is I've done that same trick where I've concatenated the target and source JSON blobs together and produced a new text column. And I'm just going to topic model that as well. So once again here, we're just throwing it into the API. In this case here, I'm increasing the embedding dimension of the topic model to a higher value. But this could be, if you think you had a lot of data, you could change this. In the previous example, it was 32, but we're going to stick with 42 here. And I'm going to run that enrichment just like I had before, and we can see it right away. So likewise here, this is not like a red team event, but what we can do is we can look at the different categories. And I should say that now that none of these categories are actually being fed on. The model has no idea where these categories live. But you see that, if I have something like an attempted exploit, they sort of group themselves differently. So right away, if I'm a team looking at this, I can actually start parameterizing what those exploits look like in the different groups here. And then I can, understand that, oh, this sort of falls into this type of class, okay? So we've got a malware cluster, we've got some phishing, we've got some unauthorized access that goes along with this exploit up here, right? So you can sort of understand this through a co-occurrence. And UMAP has now organized all this data into a very clear map that allows you to understand the data quite well. So, that's surprisingly interesting. You can also then add, for instance, like this data set here has a time variable. You can then add that time variable, and then UMAP will lay it out in a beautiful way too. And you can start understanding things through the time series perspective. Fortunately, I didn't have it in this plot here. Now, let me think here. I want to show that. So that works quite well. But there's another thing that you can actually do. And what is a little involved here is I can take this graph and I can assess a certain style of graph metric on it. So I can look at weekly components or Louvain or things like that. And then I can basically build out a feature space with those components. And then I can, for instance, plot that. So what this allows us to do is actually group these things into both a correlation ID and then an incident ID. So this is really where we can start taking the data and reducing it much, much, much further so that you can ask the question, is this new alert that I'm getting part of something that I've seen before? Is this a new event? Has somebody on the team already handled this type of event? And then you can begin to, basically cluster along those two axes there, those new axes, and then you can actually see for a given IP or a given computer, you can see all the different alerts and events happening around that. So in terms of alert fatigue, this is an incredibly useful way to, at least from my perspective, to turn something that is, a potentially huge ball of different alerts and events and reduce it down to a much smaller space where you can say, okay, this looks like something I've seen before. Can we actually turn that into some remediation that happens post fact? Are there any questions right now? Because I can show one more thing. I think we've got about 5 minutes left. Okay, good. So likewise, let's just continue down the street here. We're going to import this data set here that you can find at this link. And again, this is now a data set that has a little bit more enrichments. It looks at different S&D ports. You have different states, and it includes source and destination, or sorry, packet sent. We can repeat the procedure here. And what's nice about this exact example here is not necessarily the plot itself, which is interesting. All right, so now we've got this plot of relationships here, but let me actually turn it to compact layout. But this would be sort of like a snapshot of what's happening on your network, and it might be difficult to understand exactly where the bot is, but obviously if you have the labels, there they are, right? So in this data set here, the idea that we wanted to understand is, can the actual UMAP coordinates or the featurization coordinates give us good features that show that we can use in a predictive model? So in this case here, I just want to highlight something. This might be a little bit technical for people, but imagine that I've laid out all my events down from 0 to, I've just taken the first 10,000 or so, okay? Now, if I look at the featurization, which are the clusters or the different columns here, this is what it's laid out as. Now, what I've done is judiciously put the bot data up on the top here, and then all the rest of the data on the bottom here. So you can see that the automatic featurization has produced features that are very clearly discriminating for a random forest or any type of logistic regression model. It shows you a very clear boundary that if I see a lot of data in these columns here, this is probably fine network traffic, whereas this one isn't. And this is not taking into account all the different features that we've seen up on above here. Duration, packets, and so on and so forth, and produce those features. So, just to wrap up here quickly, hopefully you've seen a very quick way to bring your own data frame, throw it into the UMAP API that exists for free in Graphistry, and you can then, clone this notebook, test it on your favorite data sets, and then we expose a scikit style API that allows us to plug this into different types of production settings here. So you can choose whatever your poison is here, or specialty is. And then finally, I just wanted to say that this is easy to pip install. Just pip install Graphistry with the bracket AI. There's a whole host of different versions of this. If you just do the base one, Graphistry, you'll get the full visualization suite. It's GPU accelerated. You can log into Graphistry Hub, get a free GPU accelerated account. Now, for some of the contributions here, we've shown that, at least in one of these plots here, that we've got a 97% alert reduction. We've shown how to do visual search and pivoting very quick within the tool. There's a ton of other things you can do within the tool here that's super useful. You can look at things like, hops out, 2 hops out, 3 hops out, and so on and so forth to see infiltration patterns. There's a lot of stuff here that I've glossed over. One of the things here is that I'd like to just shout out for is that we're looking for infrastructure engineers. Cody's one of our best guys up here, and he's being put on a big project. So we're looking for some others here. You can also join us on our Slack, reach out to me on Twitter or LinkedIn. Twitter, I'm just starting to get interested in, thanks to Leo, but LinkedIn I'm actually quite good on. And definitely reach out at info@Graphistry or join our Slack.
Well, cool. Thank you very much, Alex. That was I was kind of gripped there, trying to understand, trying to follow along. So we do have a few questions. I've got some questions as well, if I have time for them. But so the first one is like, how would you? This is like from a relatively early part. Like, how would you choose the right number of topics?
Great question. There's a few things that you can do just from an exploratory side. Choose 32. There's some tricks that you can use, like the Lindenhouse bound, which you can look up, and it's basically something like a certain type of square root on the number of rows. And so, in general, when you're choosing these types of systems, if you have an incredibly high cardinality of features, you might want to do like a square root trick, right? And if you have very low cardinality features, you might get by with something like 10. In general, just play with it. What's fun about the API is that if I make that type of choice and plot it, you'll see actually for higher number of topics, you'll see clusters potentially start separating more, and so on and so forth. So there might be a sweet spot. If you actually have a target label, for instance, then you could throw it into HyperOpt or a similar system and actually tune that parameter to get the highest recall or highest precision or whatever the metric is. So there's a lot of things that you could do there just to play around and tune that. But again, the system is designed with some sort of sane presets. So you don't even need to set those things necessarily, just throw it into the Nose API.
I thought there was something significant about the fact that you chose 42. It's like the answer to everything.
It might be the answer.
So the second question is more kind of practical things. So it's like for us from Slawco PC or Slavco PC. So it's like, from what I can gather, the visualization part of Graphistry is done via an API to your servers. Is there any way to use it on-prem? Because there's obviously a problem of sending confidential, sensitive data to a third party.
Yeah. So what I'm describing here is PyGraphistry, which is the fun open source and free version. But yeah, we go on-prem. We have one click. You can go to Graphistry's website, and we have one-click deployments on AWS, Azure, and so on. If you need something that's, we actually do a lot of government work, so we have, highly secure containers that are air-gapped and things like that are exist on-prem. So all that's completely possible. And actually, depending on, if you get this on-prem, it's blazingly fast, right? What I'm doing here is I'm talking to the East Coast, and it's streaming all that data right back into the browser, just like a Netflix show would. So it actually gets faster.
Okay, cool. So Leo's sneaked on and planted a question, but I think it'd be an interesting one to answer. It's like, can you describe how we use UMAP to auto-generate correlation IDs for tying together alerts and even events into incidents and quantify how that was done? I had a question that was somewhat similar.
Great. Yeah, I wanted to, I purposely glossed over that just because it was getting a little technical, and I just wanted to show how to use the tool as a sort of a blunt hammer. But yeah, so the idea is that in the space of features, I can correlate things very easily with UMAP. Now, once I have the correlation, is this a real correlation? Is it spurious? There might be a timed component to it, right? So what we're able to do is use that clustering trick using Louvain, using different types of metrics, and then from that, if 3 of those, let's say, different clustering metrics agree on that event, then I have a high confidence that that's actually a correlation ID. So once I get that correlation ID, then I can look at the set of different events that happen to point to that same correlation ID, and that's where I get the incidence ID. So it's a drastic reduction from raw events to correlations through UMAP, through enrichment through the graph metrics, and then finally to that incident. So that's what, maybe I should share my screen again, but that's where that you get the computer connected to the incident ID. And so a responder at that point could then say, oh, I've seen this before, but this is actually part of a different incident bucket than the one that was handled last time, or it was part of the same one.
Okay, so my primitive kind of understanding of so you can take actually quite deeply nested things like columns with embedded dictionaries and stuff like that, and that the process kind of breaks those out into individual features, like the contents of those things. Because I come across a lot of log data, like Azure AD has like things like that, where there's a lot of like packed stuff about metadata about a login, like protocols and stuff like that. And then it clusters using dbScan to like groups based on the similarity of those features.
Mm-hmm.
Is that kind of like roughly?
That's roughly it, yeah. And the beauty about the topic modeling part of the API is that you can throw it all that JSON data. It's doing TF-IDF under the hood. So anything that shows up many times in a column, like a parentheses or a bracket, it just understands that that's not a useful feature. And that's why you see those very nice column headers that had sort of thrown away all that extraneous. So that's where it really comes in handy, because you don't actually have to, JSON normalize it. You don't have to do any of these things. You can actually be very blunt about it. As long as you're sending it in as a string, the API handles that very well.
And is it, there's probably some more questions as well, but it's a follow-up question to that. It's like, it strikes me as one interesting way of using that is like, I'm thinking of like, thinking kind of somewhat Microsoft-centric data, but like Office activity has a lot of like logs like that. It seems like finding non-correlations, finding clusters like outliers is also an interesting thing, because like patterns of, for a given account, if it's doing something weird, then it's probably not going to be behaving, and much like you showed the bot, kind of like the different kind of feature spectrum of the bot. That seems like also a really useful thing to like, this is like behaving in a very odd way because it's doing all sorts of operations that most users don't do.
Exactly.
And the kind of thing you would only see if you aggregated lots of data over time.
Yeah, I mean, again, like I'm not an expert at all in this space, but the fact that, like morally speaking, you can imagine that this is like a better version of a standard deviation analysis. And I actually had a whole section on that too. Can I just do simple standard deviation on the features themselves to see red team versus not? And it turns out that it's incredibly hard to visually see that, even from an analysis perspective, versus what's happening when you then UMAP it. It's actually taking into account that topological structure in the higher dimensional topic model space. And it's in some sense doing like a standard deviation. It's the smaller clusters that are farther out from the centroid, where it's laid them out in the two-dimensional coordinates, just happen to be the ones that were the red team, right? So I mean, this was an incredibly surprising result that you could then very easily run dbScan over that, get a cluster ID, and then just say per cluster ID, what is the confidence that I'm going to find a red team event, because we have that data post facto. And the fact that these confidences were, averaged over all the buckets, were 95% and above.
Yeah, I'm just checking the questions. Yeah, it strikes me. I had a conversation with a data scientist from Google a few years ago, and they were using something similar to TFDF. I can't remember.
TF-IDF?
TF-IDF, yeah. Kind of applying Google's natural language stuff to network traffic. So treating each kind of like communication as a sentence.
Great, I'm glad you brought that up. So I found, or Leo found a, and I won't remember what it's called, but essentially somebody used a transformer model on security logs data, right? So it's a language model in and of itself. And that model now you can actually load into the API here, and you could actually have a transformer model read whatever the security logs data is, and then you can actually produce really high fidelity features using that type of transformer model. What I've showed here is a topic model, but Graph supports any type of model that exists on sentence transformers, which is a really popular library that takes care of all the pre-processing and things like that. So I'm not sure that model is on sentence transformers, but you could easily upload it there.
Mm-hmm.
And then if you wanted to do it more remotely under the hood, we could also support that too.
Cool. Let me just check whether we've got time for a couple more questions. A lot.
Maybe I was rushing a little bit. I thought I only had 25 minutes.
Yeah, you did, but like Roberto allowed a bit more in the when he actually laid out the agenda. So we're meant to be going to a break now, but if people need to go for a break, but if you have time to stick around for a couple of minutes. This is from detect.dev. I know that these visualizations reduce highly dimensional data to 2D graphs, but there has been a similar effort to represent these models as 3D graphs, like Plotly's 3D scatter plot. Are these useful to Grok understand relationships? Oh, this is very annoying. It keeps moving. That are harder for. So let me repeat that last sentence again. Are these useful to Grok relationships that are harder for 2D graphs to represent?
Yeah. So if you want to hear sort of my personal bias, years ago, I helped build a company called Quid, which was also a graph visualization company. It wasn't nearly as sophisticated as Graphistry, but there we experimented with three-dimensional representations. And personally, I didn't find it any more useful. Now, if you want to data science the UMAP vector itself, right? So I've gone from let's say a 32-dimensional space down to a 2-dimensional space. I can actually set that as a parameter. I can say 3, 4,
Mhm.
5, and then you could scatter plot it to your heart's content. Or you could say potentially a UMAP vector of 10 dimensions, right? So now you have really strong separation in that space. It's a Riemannian fuzzy topological manifold. And then you can send that, for instance, through to deep learning models, whatever you care about. Now, personally, Graphistry doesn't support 3D. Leo, maybe that's something that we'll do in the future. My bias is that it doesn't help too much. And the beauty about the representational learning that happens with UMAP is it's really trying to exclude things that are actually, stacked on top of each other in that higher dimensional space. Lastly, we don't support this yet, but if you look at Leland's UMAP on UMAP Learn, you can actually guide UMAP with a deep learning model. So you can actually do really cool things like get maximal separation given some predictive target here. Now, we do support supervised UMAP. So for instance, if you have a column of red team versus not, and I didn't show that plot, but it actually produces an even more spectacular separation between the red teams and the not. But in general, the ones I showed, we didn't do that because we wanted to show, like, if I knew nothing about anything, the red team labels are completely unknown. How well does it actually separate those red teams?
Yeah, that's always the problem with like applying like any kind of supervised learning to security stuff, is finding decent label data that this is really an attacker, and attackers always look like this. So yeah. So unsupervised is always like.
Yeah, so I mean, you can go to like SecRepo and things like that and look at all these data sets, and it was surprising to me, coming from a data science, career, that there wasn't more label data. So that's why I showed you right at the end that there was this botnet data, and that has actually many different types of labels, bot flow, bot this, bot that, and that was one of the only ones that I really found that had truly good labels. So if you know of any others, please let me know, Ian.
Yeah, not offhand. I think the thing is, it's like the problem with using supervised learning in this context is you can train something to look at a whole bunch of past attacks, but who's to say that the next attack will look anything like that? It might be
Yep.
like entirely different kind of vectors.
Yeah.
So
Yeah, I think this is one of the hardest spaces to actually be a professional in from a data science perspective, precisely because of that. So for instance, like in the graphs that I showed you, we showed very good separation, but there were 4 or 5 red team labels in the main centroid that had a very low confidence. So what happens then, right? What if those are the most important? So ideally, you'd be able to enrich the data somehow to start understanding those attack patterns, so that you could then potentially get a little bit better separation.
yeah. Okay, that's great. We were kind of 5 minutes into the break, but so that was really fascinating. I could talk about this probably for the rest of the day, but 2 really interesting kind of machine learning things to start the day to wake people up. So thank you very much, Alex. That was just that was fascinating.
Yeah, really a pleasure to be here, and thanks for having me.
Thanks for
pleasure to meet you.
Thanks for giving us the time. That was great. So we're now going to switch to a break for how long? Until 1:30 Eastern time, 10:30 Pacific time, and I guess that's 5:30 UTC. We'll see you on the other side. Hey, so I think it's almost time to come back. I have this like habit of like when I'm sitting here, kind of like messing with my hair, and like after a few hours, I should really try and avoid doing that. So 1:30 Eastern Time, 10:30 Pacific Time, and 5:30 UTC. So welcome back. Delighted to welcome here Mehmet Ergen. Did I pronounce your surname properly? I don't give a cyber. Yeah,
Mehmet Ergen.
Ergen. Probably better known to many of you as Cybermonk. I'm kind of interested why the monk. That's like an interesting. Is that got any background?
Yeah. I mean, kind of. I like that sort of spirituality. Let's say.
Oh, nice. Okay. So Mehmet's researcher, data scientist working at Binalyze, and if you follow him on Twitter, you'll see he's like does everything, all kinds of notebooks, kind of bot analysis, seems to be involved in lots and lots of things, and has a really interesting topic today. One of the kind of complaints, John Lambert, who I work for, is that had sometimes a complaint about Jupyter notebooks is they're often very long and kind of, you have to go scroll all the way through them. Couldn't you have it as like as a dashboard view, like and there are things like that, panel, HVP Plot, and I think that's what Mehmet is going to talk to us about today. So I'm fascinated. I've never really used any of them, kind of looked at them, so I'm very much looking forward to that. So I guess we can kick off if you're ready.
Yeah, let me share my screen. Slides, video file, screen. I think I should take it here. Okay. Screen one.
We should have obviously set this up a bit earlier on, but
yeah. Can you see it now?
Yep.
Okay, great.
Yep.
Hi, everyone. Thanks for having me. My name is Mehmet Ergen, and today I'm going to talk about taking your analysis to the next level with interactive dashboarding libraries and hopefully making it available to everyone. A bit about me.
Can I just
Zoom?
could you zoom in a little bit so we can see the text a little bit better?
How is it now?
Yep, I think that's good. Yep.
Okay.
Thanks.
No worries. So a bit about me. I'm a security researcher and data scientist at Binalyze, and I'm a Microsoft Security MVP and Mystic Pi Council member. I have blog and GitHub repo for threat hunting, detection, and research-related stuff. And apart from that, I'm a Lindy Hop dancer and handpan player. Today, I'm going to briefly about interactive dashboarding libraries, and then give you a demo of HVP Plot and panel, and then I will conclude my presentation. So interactive dashboarding libraries is basically they make data analysis interactive. Instead of coding, you just click buttons and change some parameters on the screen. And they enable developing shareable data apps. And what I mean by that is you can develop something and then share with your SOC analysts or with the community, and then they can use and they can reproduce the same stuff. And therefore, it enables end users to perform data analysis without requiring any Python or data analysis knowledge. And I think which is great because Ian was talking about the issues or some of the problems with starting starting to Jupyter Notebook or learning it, and it might be intimidating because you feel like you are writing code, etc. And not everyone wants to do that, of course. So this removes the interactive dashboarding libraries remove this barrier. In general, there are 4 main libraries for interactive dashboarding. The first one is Dash. I think it is the oldest one. It requires medium effort to learn, and it has Jupyter support with Jupyter Dash. In fact, it's mainly a separate tool or application development environment, let's say. And with the Jupyter Dash library, it supports the Jupyter Notebook. Unfortunately, it requires front-end engineers, so it's not a good option for us, I think. And the second one is Streamlit. It requires low effort to learn, and unfortunately, it does not support Jupyter. At least a few months back, it didn't support. Maybe they have plans for the future. I don't know. And it recently got acquired by Snowflake, and we don't know what's gonna happen with this Streamlit after the acquisition. And it mostly supports single-page applications. The third one is Panel, which is my favorite. It requires low effort for learning. It supports Jupyter, and it also supports multi-page applications. The last one is Voila, and I think Voila was a separate open source project, and then they adapted it into Jupyter ecosystem. It requires low effort again, and requires front-end engineers, unfortunately, and also supports single-page applications. So for this reason, well, just by a chance, I think, I don't remember how I came across with these libraries. It was a few months ago, and I saw the Panel was the best option for my analysis and making it interactive on Jupyter. So this is a bit about the libraries. First, I will talk about the HVP Plot. So HVP Plot is a plotting library, but it's also more than a plotting library. It's an high-level API for data exploration and visualization, and it basically supports many of the common data types like DAS data frames, Pandas data frames, etc. And using the API, it uses intermediate representation libraries, which are HoloViews and Data Shader. This lets you, Data Shader lets you work with a very large amount of data. And then it plots the data based on your preference, like bokeh, matplotlib, or plotly. So you can choose any of them. Let's see how it works. If the demo gods allow, of course. First, I'm getting some sample data here. So this data is coming from Microsoft Defender for Cloud Apps, if I remember correctly, and if Microsoft didn't change the name. I have machines. This is kind of a time series data. I think it is recorded every hour or so. And I have application name, application category, the score of that application, and the total megabytes download and upload. Normally, to use HVP Plot, we just need to import the required method. In this case, I'm using the Pandas data frame. So I'm importing the HVP Plot Pandas method, and this adds the plotting methods to the data frame itself. But because of a bug, I had to import these libraries as well for my presentation. And also the panel library, which I will explain later, uses widgets, and HVP Plot also uses the widgets of the panel library. That's why I also imported it here. Quick exploration with HV.Explorer. HVP Plot has a method called Explorer, which lets you quickly explore the data. And you basically provide the data frame, and then it has some parameters that you can provide. And by calling this method, you get an object. When I run this cell, it welcomes me with this beautiful window. So here, I can basically select the plotting type here. I think it supports almost everything. I don't know. For example, I can choose scatter plot. It directly plots the data, and you can also hover and see the values. I can select my index. And then y-axis. Now I can also use these options. For example, I can group by machine name. So this is generated here on the right. I can select the workstations, the machines separately, and then it plots the data by filtering based on the machine name or based on the options that I provide. It has also other options or arguments that you can provide. So this is just a one line, and it provides something quite powerful. So you don't have to write lots of code just to get this visualization. After deciding what you want to plot here, for example, you can manually create your plots just with the line of code. Here I'm providing, I'm getting the data frame, and then as I mentioned, I'm just calling the API, the HVP Plot, and then providing the plot type. And I can also provide this plot type, by the way, in the parameters, and that's also possible. And then I'm providing some of the options and arguments. After running this cell, it gives me this beautiful plot. So I have the time generated and total megabytes. And I can select the machines, and I can select or deselect the application scores. And when I hover on the dots, I can see the other details of that data point. And of course, these are possible as well. We can also combine these plots. So I created one plot, which is kind of maybe a bit generic, let's say. And HVP Plot has two options. One is layout, and the other one is overlay. Here I'm creating two different plots, one for the first workstation one, and the second one is for workstation 2. I'm just querying the data here. And then after that, I'm calling, again, the HVP Plot API. And then providing the options. Now I have two objects. And then just by this plus operation, I get another object. So it gives me two plots at the same time, and they are synced. What I mean by synced is that here, if I select a certain area, and if you look at the left part as well, it gets updated. And same applies here. So this is quite useful, especially when you are comparing two data sets or two different machines or files or whatever. It gives you quite a good overview. if you want to overlay two different plots or bind them together into one, and this is the operation that you need to do. When I run this cell, I'm gonna get only one plot, and these two workstation 1 and workstation 2 plots gets together, and then I can analyze the data interactively. Apart from these functions, we can also use interactive pipelines. And for example, just a few seconds back, I created a group by option, so where I can select the machine names, but I can also add more functionality. And that's why at the beginning I said hplot is not only a library, the plotting library, it's more than that. First here, using the panel, I'm gonna create some widgets. So this is just the machine names from the data frame itself. I'm just getting a list. And then using panel library, I'm creating a select widget. So with this widget, I can select the machines, and then same for application selector. Then I can create a function, and the function gets machine name and application name, and then filters the data frame and returns that data frame, filtered data frame. With HVP Plot, I can bind these three components together. So this is the function, this is the first widget, machine selector, and the application selector. And then I can make them interactive. When I run this cell, I get a data table. And when I select any of the applications or machines, it filters the data. And if I look at the type of this object, it's basically still an HPlot object, but the underlying data is the data frame itself. So it just wraps the data frame and then lets you play with it. And you can also still call the data frame, the pandas related functions here. I can add more functionality to this plotting. Let's say I want to filter based on the time frame, but I don't want to run, I don't want to change a parameter and then run the query again and again. Here I'm creating a date range slider and then creating a filter mask for it. So this is the still interactive object. And on the interactive object, I'm providing these widgets values as a condition value. And then in the interactive object here, I'm using the filter and then again calling the API. So now I can still select the applications and machines, and then I can play with this widget. So it immediately refreshes the data and plots it. These are the main features or basic features of HPlot. It has more features. Now I will explain a bit about panel. Panel has three main components. It's basically a dashboarding application or dashboarding and application tool for Python. And it has three main components. The first one is pane. It wraps almost any type of object into a renderable view. And the widget, as you just saw, is a control component that you can just play with it. And panel is an hierarchical container to lay out multiple objects into one. I already imported the libraries, and I'm going to use the tabulator widget. So panel has lots of extensions. If you go to their website, you can see lots of widgets and you can use them. I'm using tabulator, which is kind of an Excel, let's say. I'm adding the tabulator is a widget that allows displaying and also editing the data frame. And to show that, I'm adding an additional column comment to the data frame. Sorry. So here I'm creating a tabulator object, and it's a widget, and it just gets the data frame as an input, and then it has lots of options that you can provide. I'm making it the selectable, the rows with a checkbox, and here I'm saying that these 3 fields are not selectable, are not editable, and the comment column is editable with a text value. And I'm providing some header filters. So based on these header filters, I can filter the data. And again, as a text input, and it uses the function SQL-like. And also I can make it resizable, and I can enable or disable header sort. And also I can persist the selected rows. And it has more parameters apart from that. So it is still an object here, so it does not directly plot the data when you assign it to a variable. I'm calling the variable the object. So here I can select rows, and I can add comments. I can also, I'm not going to do that. I think there was a bug when I tried. But you can basically enter a machine name here, enter an application name, and then filter the data. And you can go back and forth between the pages. And when I come back to the first one, as you see, the selected rows are still available. And I can access these selected data or selected rows with the selected data frame property. So here I have the data that I selected, and I can just export or send this data to a database for further analysis, or maybe I'm doing an analysis, and then these are the suspicious events or the malicious ones, and then I can just send it to somewhere else. I can make it more interactive. Here I'm creating a widget again for the date range, and it gets few options. So it's quite easy to create these widgets. And same for the machine that we just did, but this time I'm using multi-select because I want to select several machines at the same time. And I can provide the starting values here. These 2 widgets I created can be applied as a filter to the tabulator object that we just created. So this is the tabulator object, and then I'm adding these 2 widgets as a filter. The date range slider will be a filter for the time generated column, and the machine selector, the widget, will be a filter for the machine name. Then finally, I'm putting all these pieces together into a dashboard. So here I'm creating a column, and then in that column, I'm providing the date range slider. And then on a separate row, I'm putting the machine selector and the tabulator object. And also I'm putting the interactive plot that I created at the beginning. Now I have a kind of dashboard where I can play. So I can basically filter the data based on time frame, and I can select one or more machines, and this filter is still applied here. I can still add comments here. And still browse other pages. and this is the plot that we created earlier. And these are not linked together, but it's also possible. At the moment, they are separate, so I can still select the machines and the applications to see the plot. And one of the best features of tabulator, or some of the widgets have this feature, they have callback functions. So you can watch some specific parameters or specific events, and then based on that, you can trigger some other functions. Here, I'm creating just the basic function. And then on the tabulator widget, I'm saying that when I click on a row, it triggers this function. I can also create another function and apply it to the onEdit event as well. Now this function is applied to the tabulator object. When I click anywhere, so it triggers the function, and then it writes or whatever the function does. I can also make it cell specific. So if I click on a machine name, I can trigger one function, and if I click on an application name, I can trigger another function, etc., etc. So this is all nice, but still we are in Jupyter Notebook, and someone needs to run the cells, right? And the nice thing about panel is that we can serve the notebooks as a web application. I just removed some of the irrelevant stuff, removed the output related cells here. So I still have the markdown, and I'm importing the libraries, reading the data, creating the same tabulator and widgets. What I can do, if I go to my Python environment, I can run this command: panel serve this dashboard application dashboard.ipymb file, which is the notebook here. And when I provide the show option, it automatically opens the browser for me. So on a server application or on a server deployment, you can remove that. And you can also serve several notebooks at the same time. So when I run this, I think I'm just right on time. This is the application that we just created. So I can play with the widgets. I can select machines. I can filter. Let's say maybe I forgot. Okay. So it filters the data as well. Still, I can add comments. So I think this is the next big thing in the Jupyter world. And I can see lots of opportunities to incorporate these libraries into security operations or data analysis or any Infosec related stuff. And this concludes my presentation. If you have any questions, I can answer them.
Whoa. Okay, that was kind of life-changing presentation. That's really good.
Exactly. I was quite excited yesterday after seeing your presentation, to be honest.
Yeah, that was because I've looked at HVP Plot before and used it in a couple of notebooks, and I think it's a really cool bit of technology. I mean, we mostly use Bokeh inside of Mystic Pi for visualizations, but this gives you that same kind of pandas extension, and the composability and all that kind of widget-based stuff is just really cool. But I stopped using it because I think it took a dependency on panel, and it kind of, when you imported it was like broke, like this very unpleasant kind of, oh, panel's not installed. Like, wow, I don't want panel, but now I do want panel. Yeah, that's
the nice thing is, I mean, not the nice thing, but the funny thing is that if you look at the versions of those libraries, HVP Plot is at the moment 0.8, and panel is at 0.14. So they are not even version 1. And even with this, well, let's say alpha versions, maybe, and they provide immense value and power.
Yeah, I think that's kind of, I remember Pandas was around for like years and years before I got to version 1. People were using it in production all over the place. So I don't know. I think it's, and we did the same thing with Mystic Pi. It was probably around over a year before we got to version 1, maybe a year and a half. And you're kind of a bit embarrassed. You don't like, is it really ready? Does it like feel like a full-time, you know, we're prepared to like bet a lot of money on this actually working. So some of it's like shyness, I think. But yeah, so we had a few questions, but mostly people saying, "Oh my God, this is awesome! Thank you for sharing."
My pleasure.
And I thought it was awesome as well. And I did do some lookup, because one of the problems that we have we've been looking for like something like Tabulator, like an interactive data frame editor to use in notebooks, but usually these things depend on a Jupyter extension, which kind of works fine in Jupyter Classic and Jupyter Lab, but a lot of our customers use Azure Notebooks in AML, or they use VS Code, and a lot of these things don't work. You know, there's no kind of equivalent. But this seems to support a broad, like including Google Colab and
yeah, it also supports VS Code. I think they recently added that support, if I remember.
Yeah, that's awesome, because I used to be a dedicated Jupyter Lab user, and then I've kind of over the last year switched to VS Code for notebook editing, which I really like. Let me have a look at. Well, the first question was from me actually. So I just wonder what you meant by like a couple of the other things like Streamlit and Dash not supporting Jupyter, because I thought they were kind of notebooky Jupyter-like things. Could you expand on that a little bit more?
Related to Jupyter support or specific to
Dash?
Dash?
I mean, you said in you had like a little table at the beginning, and you said that.
Yeah. I was doing a research on these libraries because I was trying to find the best one that I can use for my purposes, and I have come across some blog posts, and they were saying that they were comparing these 4 libraries, and one of the main drawback, I mean, all of them has some powerful areas and some drawback. For example, the Dash, it's a separate application, in fact, but they have a library called Jupyter Dash, so you can use Dash in Jupyter with that extension or library. I don't know what it is exactly. But you need to know front end, so you need to have HTML, CSS, etc., etc. And I don't think it's a convenient option for a security operations center or for a company, because you already have less people most of the time, and just finding someone that knows front end and developing those applications is kind of difficult, in my opinion. But for maybe for a vendor, it might be the best option, because if you are developing some enterprise grade application, then of course you can choose Dash.
Yeah. Okay. Yeah. So you mean you need, like, a lot of them you need to deploy to like a web server of some sort?
Yeah, it requires more effort. And regarding panel, I think I learned it in 3 days or something. I just watched their tutorials and then went through the examples. They have a tutorial package. You can also find it on their website. It basically walks you through most of the steps, and they have also a 3 or 4 hour long tutorial. It's kind of a big one, so they start from the beginning and then finish with some sort of advanced dashboard, so you can see what is possible and what's not.
Cool. Couple of other questions. So can Panel or any of the dashboard libraries you work with real-time data update?
Real-time, if you mean streaming data, yes. Panel and HVP Plot supports streaming data, so you can just stream and then it starts plotting the data real-time.
Okay, cool. Do you know like what kind of infrastructure you need to set that up? Because I know Boca supports but you need to deploy the stuff to a server in order to support.
Yeah, for that, no, you don't need anything. I mean, you can just do it in Jupyter without doing any extra, without putting an extra effort or installing anything extra, because this Panel and HVP Plot is two libraries of Holovis. Yes.
Mm-hmm.
The Holovis is the main organization, I think, and they have 5 or 6 different libraries, and they have a library called Param, and then a library called Holovius and Lumen, etc. But the most high-level ones, those are a bit low-level kind of. You can still use it, and they are still relatively easy. But at the top level, you usually use HVP Plot or Panel. But if you want to go more advanced, then you can use those libraries, and they support this streaming feature. And you just provide some kind of configuration again, as I just showed. So it's quite easy to create those dashboards, even real time or using a data. And the data shader is a great feature. If you have gigabytes of data, for example, it basically summarizes the data instead of getting all the rows, and then based on their distribution, it creates this plot. It's the same plot, but the underlying data is a bit different. And it's kind of using Google Maps, because when you use Google Maps, you have a view standard, and then when you zoom in, you start seeing more details. Mm-hmm. So, but when you don't zoom in, it doesn't render that detail. So it's kind of the same architecture or method, I can say.
Maybe you can come back next year and give us a talk on data sharing. That's another area, because often there's the kind of things you can see when you aggregate the data on a big kind of visual panel. Like some of the Graphistry stuff showed that in a different way. It's that would be kind of cool. I'm just checking to see if we had any other. So a question from Leo: can Tabulator embed in Streamlit?
To be honest, I don't know. The Tabulator itself is a JavaScript library, and it is open source. So it's not something specific to Panel or HVP Plot. So it is possible to use it, but I don't know if Streamlit supports it, because I haven't used it before.
Yeah, I think it depends on its kind of widget model. From what I was reading from the Panel stuff, I think it has it relies on, because the whole thing with widgets or any of the stuff that lives in the JavaScript world, it needs to have some way of communicating between JavaScript and Python and back again, and it uses the kind of widgets, traitlets infrastructure. So I'm not sure whether if Streamlit uses that. That's a kind of possibility. I mean, Ashwin might be able to comment, because he's I wouldn't say a Streamlit expert, but compared to me, he's a Streamlit expert, so he's used it a little bit. Or you might want to say a couple of words about Streamlit. I guess we have a minute left for the next session?
Yeah, I haven't used it. I think, yeah, I was just checking because since I saw 4 options before going deep dive, I wanted to find the best option.
Mhm.
Although Streamlit has more support probably, and it's very popular, and there are even online courses for Streamlit. But if you search for something related to panel or HoloViz, there is only the YouTube videos, the long tutorials, and the documentation. That's all.
And now there's your presentation at Jupyterthon, so that's like
Yeah.
knowledge repository. Cool. I think we're about at time. That was really fascinating though, and I just lots of stuff too. And I think it was well received by other people as well. So
Yeah, thanks.
I
think we can also add this functionality to Mystic Pi.
Yeah, I think so. That's what we were kind of discussing in the side channel. That's like awesome. Well, thanks very much, Mehmet.
For me.
Still have problems pronouncing your first name, Mehmet, right?
Yes, Mehmet, or you can call Mehmet. That's okay. Much easier.
Okay, thanks very much. That was just fun.
Thank you.
Okay. And it's over to Roberto, I think. But we can't hear him. Unmute.
There you go. Yeah. Yeah. Thank you very much, Ian. So we have our next presentation. Thank you, Dimitri Trisna. Right? Did I say it? Maybe I think I'm missing one. Okay.
Yeah,
thank you very much. Thank you for joining us. So I actually was reading a few blog posts. I think it was last year. I think it was where there was a use of like security data sets, and then I don't know how to apply some data models in general, I guess, to take the basic analysis approach to a little bit more advanced. And then there was other kind of like concepts in those blog posts, and that's when I started hearing about you. And then I was like trying to look like, for example, like where you work at and all this stuff, and now I see like, well, he works for Microsoft as well. So I just like went directly to internal chats. I was like, hey man, like I didn't know you were part of Microsoft. So I'm really happy that to see you here. I like your approach a lot, like, very technical from a, data science perspective, but also understands the security field, right? So super excited about your presentation. And just to make sure that I cover some of the stuff in the bio that was super interesting. So you have a very interesting bio, first of all. But one of the pieces, well, over 10 years of experience in security, working as a senior software engineer in Microsoft. But then you also have your, red team engineering, security data scientist background. But then at the end, I like how you say, more personal note, central free time dilemma is whether to beat deity AI in Civilization 6 or read methods of rationality for the 4th time. But there is a practically no free time since I'm raising a 3-year-old neural network. So that was very, very funny and interesting when I was trying to prepare for to do the bio. So thank you very much, and looking forward to your presentation.
Cool. Thanks for introduction, Roberto. Yeah, let me share my screen. Yeah, I hope you see it now. And basically today I want to show. Yeah.
Can you zoom in a little bit if you don't mind? Is that possible?
Even more. Yeah, like that.
I think that was good, right? So Ian, I think Ian Rashman, anybody would like to check just making sure it's not that small for me.
Yeah, that looks good.
Good. All right.
Yeah, cool. Thanks. Yeah, basically, what this method? It's like I titled it shell language processing, but I believe it's more of a play with the words around natural language processing, where the shell is as well language, but it's not natural. It's a pretty static language that we see in Linux or other Unix environments. basically bashes and everywhere, and we collect ton of telemetry for security needs, right? Not only for administrative needs, but to figure out whether something bad happens on systems. And oftentimes we see really like basic heuristics on top of this data. Like in processes, what happens, we try to catch something basic. Here, I would like to share maybe 2 slides. I hope you see them. It's basically, we in security classification, we have those bad commands that we know explicitly bad, like mimikatz for Windows. We have commands that are explicitly good, and it's easy, right? We can define some specific static heuristics of bad things, and that's it. Profit. We solve security, but unfortunately not. We have this huge blob of gray area that we don't know whether it's bad or good, and it depends on the context, right? And basically, security and detection engineering itself, it's not attempt to answer what is bad, but it's attempt to answer what is not representative for your environment. And here, actually, ML methods come handy. They allow to learn sort of the way your environment behaves and segregate that gray blob of usual patterns against something unusual, something bad that may happen. And here we will talk about this in this notebook. So there is huge amounts of data without released potential, and let's try to take a look how this might look in regular Python. Basically, we have a list of strings, right, that represent some activity. In this cell, we loaded benign commands and malicious ones. Basically, we decoded in memory to not store the malicious commands. Malicious commands I collected myself, and benign are part of the NL2 bash dataset. It's roughly 12,000 commands, not that a lot, but suitable for our analysis. Malicious commands are like collection of stuff. It's only 123 commands, but again, it will be enough for our analysis. And they represent mostly like reverse shell connections, yeah, like spawning the shell from Python, bypassing sudo, and other stuff that I found across the web for this analysis. And we can start play with data, take a look on the lengths and everything, but we will not focus on EDA this time. We specifically go right away for pre-processing this data for ML modeling. In ML world, we have this X parameter or let's say variable that usually represents the input to the model. At the same time, Y is the expected output from the model. And therefore, we define X row as like sum of benign and malicious commands, and Y we define zeros for benign commands and 1 for malicious ones. So basically, all ones or ones represent the malicious command. And if you start browsing or looking for courses or materials on this topic, usually you see huge emphasis on actual building models. What model do you choose? Like logistic regression, gradient boosted trees, and etc., etc. But from our experience, arguably the hardest step for security analysts, for security engineers, is specifically pre-processing, where we get this input string and we get a numeric array. Basically, how do we encode this string in numbers? And that's a lot of people cannot wrap their head around, and that's what we're trying to answer in this notebook as well. So this consists of 2 steps. Actually, there can be more steps, but for the sake of shell, we really can focus on 2 of them. Basically, tokenization is a splitting or of like sequence of characters into tokens, which are more of a like unique patterns of text. In natural languages, those usually are words or part of the words, but in a shell, it is more trickier, as we will see in a moment. And encoding, basically how do we encode this list of tokens into the numerical representation. So what's with tokenization? Yeah, in Shell, actually, we have those weird parameters where the space not always represent a starting of a new token, because space can represent part of the regex, for example, that is used and is an input of set or awk or other commands. At the same time, commas, pipes, and other punctuations have special meaning that we want to usually preserve. And one thing is that in ODD often comes with the already preprocessed arguments, and we can utilize this and take basically those arguments as is and get the list of tokens right away. But we would tell that this is not perfect tokenization, and we suggest you to join those strings to a longer sequence, like basically the actual long command, and perform a tokenization later. As part of our research, yeah, the same basically applies to the malicious commands. We really need a dedicated tokenizer for this. And as part of our research, we defined the shell tokenizer, basically a dedicated tokenizer that takes strings like shell commands and splits them into individual components based on our understanding how shell works. It is underneath, it utilizes Bashlex library, which kind of contains itself classes of shell commands like pipe and redirection, etc. And we utilize those classes to build this tokenizer. This tokenizer is good, and so far we found the best, but it's not that fast. So you should consider a trade-off. If you need a really high quality tokenizer, we suggest you use this. If we can work with the lower quality data sets, but tokenizers, but faster, we can use another ones, as we will show in a moment. Then we go to encoding. What actually is encoding? It's basically how we count those tokens in a string. And there is a simple encoding schemes like one hot. Consider these three strings. I love dogs, I hate dogs, and knitting is my hobby and my passion. And you can just count words that appears, not even count, but flag them as with one. If the word appears in the sentence, we just flag them with a digit 1. There is another type called a bag of words or term frequency, or as well count vectorizer, which basically on top of the one hot performs counting. Here, for example, we counted my to be 2 times in the last third sentence. And you've heard probably about hashing vectorizer, or if not, it's a way to use this term frequency and bag of word technique with the hashing crate. Basically, the same logic applies here. However, it's more memory efficient. Just you can think about that that way. And the last one we will cover here is basically the FIDF, which sort of similar to this count vectorizer or bag of words technique, but takes into account relative appearance of those words in the whole data set. So we divide this term frequency, those counts, with the number of containing documents containing these words. Therefore, unique words for this data set will have a higher value. So all those encoding schemes are available easy for everyone, for example, from sklearn or other libraries. And like here we use TF vectorizer. Basically, same can be applied to the hashing vectorizer, and we can just replace it here, and it will work as efficiently. And we can use here, instead of shell tokenizer, which is slightly slower, we will use verb tokenize, which still preserve punctuations, however, is not that tied to the shell syntax. And here, basically, in the last line, we basically transform these raw commands into this TF-IDF encoding, and we can take a look on what features the TF-IDF considers to be important for it. Here we take top 100 tokens, but print only 15 of them. So TF-IDF takes a look on those parts of the commands that can appear. And here we got all 1,200 and something commands, which are both malicious and benign. However, encoded in 100 dimensions, because top tokens are 100. So this looks like this. Command like top something something is now represented in this array. So this array defines this command using top 100 tokens that TF-IDF encountered in all dataset. And as we can see, it's pretty sparse like array, but some of the elements describe that this element contains some specific tokens. And yeah, now basically these, again, the same can be used for hashing vector either, and just for the sake of analysis, let's do the same with the shell encoder as well. It allows to achieve the same results with this SLP technique that we showed. So we have 4 encoded commands now: hashing vectorizer, TF-IDF vectorizer, and 2 of them are using this SLP tokenization, whatnot, and TF-IDF, just to show the difference. And right away, this array is ready to get passed through the machine learning model. So let's spin the neural network, right? No, please listen to Mike. Don't go to the neural networks right away. It's often a caveat. You don't need really NNs to solve most of the problems in, let's say, in security domain, at least for now. Usually it might be a huge time waster. And first of all, we suggest you to focus on more simplistic techniques, especially if this represents a tabular data. It's a proven that XGBoost, for instance, is one of the most optimal algorithms that we can use right away off the box. It offers the less training time with the highest accuracy on tabular data based on this survey basically published this year, outperforming many deep algorithms like neural networks. And yeah, and how XGBoost works, it's gradient boosted decision tree algorithm, which it's hard to explain really fast, but sort of it's huge amount of decision trees, which itself are if-else's, and it's a clever way to combine them. That's basically is a gradient boosting, clever way to combine them so they learn on each other's mistakes. And it works really pretty well. And I'd say this should be your first selection if you want to try a simple model. Go for XGBoost model classifier, for instance. And before we jump to the training, I'll touch on cross-validation concept as well. So every training happens, of course, on training data, but we want to evaluate this data as well. So there usually is a so-called test, or sometimes it's used a validation set. If we have a validation set, then we will use a test set later on, but oftentimes we just refer to train and test set without using a validation terminology. So we use training data and we use some test data to validate this data. And since we have small amount of data here, we want to utilize all of it for training. And in that way, if we use all of it for training, we want to use some part of it for testing. And cross-validation does this. Basically, it loops our data and all the time tries different parts of data for a training, and different fold or part of data is used for testing. Each of those estimations is a different model, basically independent from each other. A bit chaotic description, but I believe the image itself represents the idea pretty well. And again, sklearn comes handy. We can use a cross-validate and stratified key-fold function and class to use this. And here is this XGBoost classifier that is one of the best models we can use out of the box with minimal configuration tuning. So basically, let's loop over, I don't know, 2 TF-IDF implementations we had above, and train a cross-validation, like a set of cross-validation models on top of each data, and get the average scores that these models achieve. And this code does actually this, and here we see that accuracies are close to perfect, right? Accuracy 99%, accuracy like 1, like practically perfect. But what is the problem with our data? If we predict always benign, so we say that always benign is all zeros, we already get 99% accuracy, and that's the problem with the security problems. Security challenges. We have a huge amount of benign data and really small number of malicious examples in our environments. So we need a more clever techniques to evaluate our models. And here comes handy the so-called recall, precision, and F1 scores. So if we consider this scheme, always when I touch those topics, it is pretty hard to grasp them fast. But I suggested to dig deeper, but like precision is a part of true positives against of all positive answers, and recall is basically correct answers out of all desired outputs. And F1 is sort of harmonic mean between them. It balances them together. And if you want to evaluate your models more accurately in security domain, often I suggest you use F1 score right away. And here we can see, if we scroll up, that average F1 scores are different. And here it is 0.05, and here it's 0.6, and we can evaluate models on that scale as well. Another way to do this is using a so-called ROC curves and fixed positive threshold. I'll not go in details like how plotting works, but we just can plot those ROC metrics for the results of all 4 encoding schemes, and we can see ROC curves. And that curve that takes more area basically represents the better result. And here it describes how much of the detections we have under some specific true positive false positive rate. For example, here under 0.1 false positive rate, we detect about 95 of the samples. And yeah, but how this variability appears of what they detect? It's because our models have a probabilistic nature. Our models doesn't output zeros or ones, right? For example, this is the labels that we want a model to get, but we get something like this in the output. We get the probabilities, and model thinks that this second sample out of this list is a malicious with a probability 0.47. So basically, gives roughly 48% of maliciousness. And we can take a look how well our model performs on the scale from 0 to 1, and we see that most of the samples have really low probability of being malicious. However, some of the benign samples are getting those high scores. And here, this is box basically represents a distribution of malicious samples, and we see that model is less sure about maliciousness of those samples. So some of them getting low probabilities, some of them getting high, and the span of their probabilities is much wider. So yeah, we can play with the threshold and get, for example, those 11 benign commands are above the 0.0 threshold from here up, and we can try fine-tune our model based on those benign samples. From fast look, I see that redirects stdr redirects to std out are something that models don't like, or yeah, it might consider this as a malicious as representative for maliciousness, and we want to include more examples of benign activity like this in training set. So yeah, it's a problem for security. We have a huge number of benign samples and small number of malicious ones. Another way to treat this is augmented data. So we can create synthetic examples. For example, consider this simple line of reverse shell with the OpenSSL binary. We can generate other variants of this reverse shell, right? We can try different file name for the FIFO queue, or we can try different port, different 443, for instance, or we can try different, I don't know, shell, not SH shell, but bash shell. So this way we can address these challenges, and this is an exercise for you if you need to apply those techniques. So yeah, basically recap. Don't use deep learning models unless you know why you need that. Evaluation of ML solution, often accuracy is not enough. You use F1 score, or better, use detection rate with fixed false positive threshold. That's the best way to represent utility for security needs. And yeah, to get a better generalization for models, use augmentation techniques for malicious techniques. They may provide a better so-called generalization of production models. One more thing I want to cover with you, it's unsupervised learning and anomaly detection, which is hype topic in security, because people always want to detect anomalies, right, in their networks. And one of the simple algorithms is isolation forest, which sort of again, a simple logic that carves out outliers from your data, but is less effective with the more dimensional data. Still, we can try apply this model on our data. So we define an isolation forest again from sklearn. We take TF-IDF encoding again, and we just predict and get index of outliers. -1 means outlier. And when we apply to all of our data, I need to run this, right? When we apply to all of our data, basically we get a huge number of outliers, and that's the problem. Let's plot this in 3 dimensions, and we see something like that. And this is what you see when you purchase ML solution by some vendor that applies it to your network, right? You see huge number of anomalous activities right away, and that's the problem. In your network, there is indeed huge number of anomalous activities every day. Every day a new connection appears. Every day a new user logs into a new server, and this consists of bad questions for unsupervised machine learning that we see. You really cannot ask those broad questions to the model. Like binaries, they have temporary names. The network traffic is so diverse environment that everything is anomalous at some degree. However, good questions go from a direction with the grain of domain knowledge, and here you actually are needed as a security specialist. You need to ask more narrow questions to the model. For instance, in Linux, what are the anomalous Python arguments that appear in your environment, or anomalous systemd command that might represent some service persistence, or anomalous SSH login source to a specific, for example, jump host. And in that case, when focused on specific TTP, those models get desired utility. In Windows, it might be, I don't know, again, select the tier 0 servers like DCs or SQL databases, like critical ones, and get users, flag anomalous ones. Processes that load NTDLLs. It's too versatile for manual heuristic, but you can get an anomaly score with the algorithms like isolation forest, or RDP connections. Narrow down specific scope of servers that you're interested in and ask anomalies in that scope. Let's take a look on the first I don't know, problem, anomalous Python arguments. Here we just carve 100 benign commands of our data set, right? And let's define a Python reverse shell. So from that, like basically 100 benign commands. Oh no, basically I carved all the Python commands from our raw data set and multiplied that by 100 to get some number like up. And a single reverse shell command is in there. So a huge amount of activity that is homogeneous in your environment and one unusual command there. And let's apply isolation forest on top of that. And that's what we see. That's the desired picture that we want to get. Like relatively small number of activity and pretty easy to get some anomalies out of that. And here we actually get anomalous command is our Python reverse shell. Here a note maybe for red teamers, like really fast one. There is a huge activity of adversarial machine learning in the industry, how you bypass or tamper with the ML models. And here, what actually is adversarial here? We just want to take a look on some legitimate sample. For instance, legitimate Python benign and 10 samples out of that. We see some JSON path activity like sysstdin, JSON lot, read lines, and we can take those parts of commands and add to our reverse shell. They do not do anything really. We can, I don't know, load test, and we can add garbage code that utilizes those tokens that ML model will use to distinguish the bad command from good command. And if we define this like extended reverse shell that utilizes some of the known activity, known benign activity, then what we get is isolation forest doesn't predict any more anomalies. Basically, there is no anomalies in this data set anymore. So the summary on this talk and final thoughts. ML is not a silver bullet. It will not substitute you. Really, it is a tool that you can master, and have an edge over adversaries in your environment. The pre-processing from our point of view is the most challenging part, and here we offer ready-to-use code samples how to do this, basically on a raw strings. And we showed this example for ODD, but I believe it can be applied to Sysmon or basically any security relevant telemetry like cube audit logs, etc. And detection rate with fixed false positive threshold is the best way to evaluate your model before pushing to production and get a lot of augmented data, and your models will perform really well. That's it, I believe. I hope I'm in time.
I thought Roberto was going to give me back. So it caught me by a bit by surprise. Yes. Hey, thanks very much, Dimitri. That was fascinating.
Maybe a bit technical, but I hope it finds its user, right?
I thought it was really good. Is this maybe the second or third time we've seen this acronym that I can't pronounce, the TFDIF?
TFIDF, yeah. I've heard you mention it with one of the previous speakers. It's common encoding scheme, but
sorry.
Yeah, but I'd say maybe not the best. Hashing vectorizer usually is performs a little bit better. I suggest to use it.
Yeah, a couple of people I know have been using it to actually a colleague of mine, which I think Pete mentioned yesterday, Varney's kind of created. We're just about to publish it. Sort of unrelated, really, but it's using TF-IDF to analyze threat reports and try and map them onto MITRE ATT&CK things. It's not something I understand fully, but it seems like for many kinds of things that look, when you look at machine learning models from other, maybe astronomy or biotech or something like that, they're like everything is numbers there, so they becomes readily kind of I can just apply this DB scan clustering algorithm to all these numeric values. But when you're in a world where stuff is primarily text, like command lines or account names or URLs, then you're sort of like, oh, how do I convert this to a number? So
that's basically what is my observation. It's one of the most significant challenges security analysts have, how to transfer their data to this numerical array matrix scheme that basically later can be applied to any of the models to span across it.
I'm just looking at the if we have any specific.
Yeah, I think
go on.
I can ask a few questions from Discord. First of all, I think this is great. Like the notebook has like a lot of interesting pivots. Are you going to publish the notebook, or is it already available somewhere?
It's basically available already in the repository. I can share, and I see the Roberto sharing in Jupyterthon Discord. I can post it there as well.
Yeah, that will be great. And then I can basically ask a few questions from Discord. I think Blue Spark mentioned like there's similar project from AppSecure command lines. I'm not sure like if you have seen. Yeah, he was saying like would embedding build specifically for shell commands is better than TF-IDF, or
it's tricky. It's multi sort of layered. This question requires a multi-layered answer. One is the tokenization. Before you need to build any embedding, here comes the tokenizer, and how to split those commands in this atomic units. It's a tricky one, and based on what tokenization scheme they use, it might differ. And the second one, embedding, is basically already a neural network. It takes a sequence of tokens and tries to learn a representation of it based on the co-occurrence tokens. And this is super promising direction. We don't have a really pre-trained embedding schemes for the ODT yet, and it definitely can, like TF-IDF, it's sort of a dump technique. We can call it already sort of like for simple one. And embedding is more of a it's up to date, like last maybe 10-ish years technique. There are even more cool techniques. I'd say we can use like masked language models, but basically we, as a security industry, we need to catch up with the NLP industry here and provide some pre-trained models for people to use.
Okay. And one other question that I think we had was, is there a public data set that you can recommend for playing with unlabeled or labeled version of this kind of data? Like the command lines.
It's another painful question. We really don't have a lot of data because it's pretty sensitive, right? The commands that run on servers, no one wants to share them, and luckily there are some collections basically which I used NL2Bash. It's a collection published 4 or 5 years ago by researchers from question and answering portals. They scrub the Quora and Stack Overflow. It gets some set of commands, and but besides that, it's pretty sparse. Those commands I used in this notebook, they are as well available publicly in the repo. I will share as well in the Discord if you want to play with that. But it's still kind of sparse. Usually, if you work, you get some internal data and a lot of that.
Yeah, there are like some data sets with win log dumps that I think he has suggested, but Yeah, we can check. And then there's one more like follow-up questions, and I don't have a clue about this. Is there a sentence transformer or HF model you can recommend? Maybe something specifically you can answer, or maybe in Discord if you prefer.
Yeah, I see. I don't think there are probably, I don't know what is meant by sentence transformer, but probably any sort of language model, pre-trained weights that you can download and use, and there are no such models for at least shell or sysmon data, sort of any behavioral data that we telemetry that we get from either Linux or Windows commands. And that would be, again, cool to get that. And in fact, that's one of the research directions I'm working on too as well. But again, you can try download any NLP or Codex models. Codex, for instance, is a model that's trained on Python and other coding languages. It might get some decent results for you, but I think some small model that you train purely on your data, even using classical techniques, might work better than those ones because they are like two different data is used for them.
I have got a quick question. I was interested in the part where you were talking about like generating kind of new synthetic variants of kind of like shell attacks. And I was kind of wondering, like, what a lot of people don't publish their data from their attacks very much. I know Roberto and Jose and the Open Threat Research have got the security data sets. But one thing people do keep up to date is Sigma scripts, like pattern matching. I'm kind of wondering, I mean, this is much easier to say than actually do, but I wonder if there would be a way of like analyzing the Sigma data and kind of generating template kind of patterns that look like up to date. You know, you look at like, oh, it's searching for this on a command line or this in a syslog entry, and kind of generate patterns of data with variants. I mean, I realize that's much easier to say than to actually do it in practice, but that might be at least a way of like keeping up to date with like current attacks rather than relying on, you know, stuff that's like multiple years old.
Here, we definitely see a huge breakthrough in generative AI this year, right? All those generative models are like, yeah, they are mind-blowing. And here I'd see you will not get a lot of utility if you train purely on Sigma data, because Sigma, again, it's nothing for a large model. It's like how many samples we have of valuable Sigma rules, several thousand or maybe several tens of thousands, and that's nothing. But if we take some pre-trained models on natural languages and say them, look on Sigma syntax, and and ask later, we want to get something similar but for slightly different stuff, I think it's a viable direction to basically give me a Sigma rule for, I don't know, this side loading of DLL, and it will give it. And I believe we can merge the NLP world with security here. It's a good direction.
Yeah, because if we can generate like artificial landscapes and sci-fi worlds and stuff like that, maybe we can generate attack variants. Obviously, it needs somebody much smarter than me to actually do the work, but that's
like you post a disassembled binary in a prompt and say get me a Sigma rule for that, and it will put it out. But yeah, for that it still needs to find what is distinguishable for that binary. I don't know, but it's interesting direction for a startup. You might.
Okay, well, maybe I could be an early shareholder.
Yeah.
Do we have one more? Somebody. I'm not sure how. I'm not sure how you pronounce it. TH3Y 3TI posted Talina tool NL to bash which is generating a bash command from natural language. I'm not sure that's the same thing. It's not kind of generative model exactly, but
I believe that's actually the data set that they used.
Okay.
It's
right.
a research. They used this small data set I mentioned. Yeah.
Yeah.
Let me take a look. I see this link in a.
Yeah, I thought
Yeah,
I was
that's
bringing new news, but it's actually old news.
Yeah, it's again a set of around 10,000 bash commands they use for train their own model to use it as a generative the data set I use in this notebook.
Right. The Yeti. Okay, that's how you pronounce it. Rather than, I was thinking it was THE and THE. The Yeti. The Yeti. Of course, I should look at the. I should have looked at the picture, and they're immediately obvious. Cool. Well, thank you very much. That was really fascinating. Continuing the kind of deep dive. The theme for the day is obviously like machine learning applicability to Infosec. It's we've had like 3 quite different sorts of views and approaches so far. 3, or have I lost count? Maybe there's more. Yeah, Roberto, do you have any comments?
No, I was gonna say thank you very much. Yeah, sorry, I was in the background, like doing a couple of things, adjusting a few things in the agenda as well. But I was, listening to all the stuff, and it seems that there was definitely a lot of interest in this talk as well. I could see that some of the attendees are very technical in these concepts, like to understand some of these concepts and libraries being used, and so that's pretty cool to see as well, because I'm taking notes of what are the things that I need to read more about. So I'm also on that. Going back to Ian's initial keynote, like I'm in the parking lot in that area. I'm waiting.
I may have fallen into the chasm, but like, interesting. I know there's interesting stuff out there, but I just don't know where to go.
The problematic thing is that those methods develop so fast that even if you actively involved in their learning, you still fall back. And for example, like convolutional neural networks or recurrent neural networks are sort of already outdated today. They are like substituted with their transformer models, and it's like never-ending cycle. So yeah, I don't know.
Yeah, but I like once again, I think that this is a theme, as Ian was saying, right? That it doesn't matter what the topic is, like how you're using the notebooks to accomplish like the documentation of the research. And I think that that's also what we're trying to do as security researchers, right? But seeing how flexible it is to do all these use cases is the fun part of like this conference, to see everyone's approach to how to use it and what is the purpose, right? What is the goal of using it? And then like companies like Graphistry, like how you can connect it with other services that would then extend that functionality, right? So it's super cool to see all this stuff. But thank you very much again. Super cool. It was nice meeting you in person, virtually. That's pretty cool, man. Thank you.
Yeah. I think one of the next steps, is like how can we? It's kind of a bit of a theme of my thing. Is like how can we encapsulate them in ways that like mortals can, like, oh, I just want to apply this to, I don't really understand what's going on here, but I want to apply this to my data set, and I just like a couple of operations. I think that's obviously it's difficult as like new techniques and stuff like that emerge. These things get outdated very quickly, but if we can kind of progress to that stage, we have like because I'm aware that like was it 55-60% of people who registered for the conference are kind of beginners in notebooks, maybe not beginners in ML actually, but like beginners in notebooks. So, like, how do we make it usable by the masses, which I include myself in that kind of category? Yeah, fantastic talk. Thank you.
Yeah. Cool. So I think that now is 3 p.m. Eastern, 12 p.m. Pacific time, and we can go on a 10-15 minutes break, and then we are going to have another presentation. So So we have 1 and 2 people that had a couple of emergencies today, so they cannot be with us. So I hope everything it's okay with in general with them. And I was thinking maybe we can have, so Ian is stepping in with one presentation that he did internally at Microsoft, I believe, and it's about some visualizations that he put together, right, for the internal conferences at Microsoft, right, Ian?
I was trying to like keep mentions of Mystic Pi down to a minimum today, but I kind of.
Yeah, but thank you very much for stepping in, man. And so I have adjusted the agenda. I'm going to do a quick quick update just to make sure that we cover this break. But then the rest of the presentations should be the same. So the day ends the same way. We just have Ian covering the majority of the next two, and then we jump into the one Windows memory triage with Janantha at 4 p.m. 10 minutes Eastern, 1 p.m. 10 minutes Pacific time. So let's take a break right now for 15 minutes, and let's go back at 3:20 Eastern, 12:20 Pacific. All right. Sounds good?
Yep.
Cool. Thank you all. All right.
Yeah. Thanks, Demetrius.
All right. So we're back. Let's see. I was just checking the agenda again, making sure it looks good. So yeah, the agenda is updated. I just want to make sure that everybody is aware. So let me just do like a quick thing here. So if you go back to the agenda again, so we finished in the previous talk was shell language processing, went on break. Now we have Ian, and then the whole the whole agenda continues. So just making sure that was clear. So now we have Ian, and I think we have already introduced Ian 2 times already for the past year. So so Ian, you can just take it away, but actually, let's at least make sure, because some people might have only joined us for day 2. So Ian is a principal developer and security engineer at Microsoft, and one of the main, I would say one of the creators and also the main developers and maintainers of the Mystic Pi library. So if you want to talk about open source, not only of a project that is used in the community, maybe for some research, this is also used actually by an enterprise, right? So Microsoft uses it as well for certain in certain areas when it comes to research. So it's pretty cool to see that kind of mix of people contributing from the community and being used by anyone in the world, right? And kind of like battle tested as well a little bit by some of the functionality that is being used for, Mystic is being used for, right? So thank you, Ian. You take it away, man.
Hey, thanks, Roberto. So this is potentially a bit of an error-prone slot. It was like we were like in a bit of a panic an hour ago. It's like, 2 people are cancelled. What are we going to do? Play music for like 40 minutes? Or and I said, well, I could do this this thing that we did.
So I would be fine with the 2 hours music, man. I would be like relaxing for 2 hours with your music. So.
So we did this session. I know visualization is kind of popular. I'm not going to cover all the visualization. It's just like the visualization capabilities in Mystic Pi. So some of the Bokeh-based visualizations that we've created. That was one of the things that was one of the original motivations for creating Mystic Pi. Is I was kind of entranced with the whole world of Jupyter notebooks and Python and all the Python ecosystem. I thought, well, there's everything here that you need to do, Infosec work, investigations, hunting. And I searched for like a long time. So it's got to be like a decent timeline control. It's got to be like a process tree viewer. And I couldn't find anything. So, eventually we just decided that we would have to write them. So that's kind of, they were one of the first like things that fairly early on in the history of Mystic Pi. I wanted to add this. So this is a workshop thing that we did internally, but it's on GitHub on a Mystic Pi training repo. The only thing there is that like these workshops, and there's as you can see, this is session 7. I think there were like 8 sessions. So Ashwin's got one there on like analysis, and these are time series, which is really good. These are all like pretty much have like captive data. So some of them you can kind of look through. Some of them need kind of connections to real data sources, but most of them kind of work on local data. And there's like, basic introduction, some of the enrichment stuff, and this one on visualization, which I think because it's visualization is like kind of maybe more appealing to look at. So I'll leave that URL there for a little while. Oh, I've got to actually go to my VS Code. I can't. Here we go. Right, so we're going to be looking at kind of timelines, process tree, graphs, and a few other things if we have a bit of time. So I've already run my kind of like init notebook thing to get everything going. So first of all, the timeline, as I said, it's based on Bokeh, which is part of the PyVis suite that includes like hollow views and data shader and stuff like that Mehmet was talking about earlier on. And they all have like a common pattern of interactivity. So the timeline will work, essentially it's very ubiquitous. It will work with anything, any kind of data, any sort of data frame that has a timestamp, essentially. It allows you to group things, show more detail with like hover. And I think a couple of, I think Mehmet's talk, I can't remember whose it was. Somebody showed like a timeline. I think it was like with the tooltips, you could kind of move over, and all of our things, as I mentioned yesterday, all invoked in a single line from a pandas accessor. I did have a little note that if you, like a lot of, I heard some while ago that one of the most popular tools in SOCs is Excel. Like people get logs, pull it into Excel, do a lot of like manipulation, searching, and stuff like that. So if you have data in Excel, this is like one thing you need to get it into a data frame is, excuse me, my voice is kind of cracking a bit. The OpenPyXL, and then you can use these to read stuff into Excel. One problem I found with it is it's not very good at, Excel is not very good at handling date times. So you don't get any kind of time zone information. You might need to like mess around a little bit. I think the dates are imported as strings. So you may need to do a little bit of fiddling to kind of convert it, but you can do that. We're going to be working with local data, that's stuff that's on the repo. We have a, this is just to show you that you can import Excel into a data frame and use it there. So we're going to be working with local data. We've got a version of our data provider, query provider, that just reads either local pickled or CSV data, mainly for like demo purposes like this. But it looks very much like the other providers. So we have like the provider and then the name of a query we want to run. And this is Microsoft Defender data, Defender for Endpoint. They typically, you can see it's got like 103 columns. It's very rich kind of data set. It includes information about the parent process, the file hashes, and all that kind of stuff. So very basically, we've got this in a data frame, and to plot a timeline, the only thing we really need to tell it is which time column it is, or which is the time column in the data. And it should give us a kind of a basic timeline. So we do have these kind of interactive controls where you can kind of zoom in. There's also a sort of mouse wheel that you zoom in and out, and you'll see like hover tools, like the tooltips, currently only displaying the time. We also built, this is like Pete Bryan's genius, built this kind of rather nice little thing where you can see all of your data and able to zoom in on it kind of like more interactively or in a different way. So that's the basic timeline. Like this Boca toolbar appears on all of our plots, and there's just an explanation of the tools. Like as they're selected, you can and we can have a look. If we have the pan one that allows you to like go backwards and forwards, box zoom, reset the thing to the default, and then the wheel zoom, which is kind of my favorite. It means you can just use the mouse wheel to zoom in and out. And you can also save the thing to PNG. I think I already mentioned this thing. You can like drag the edges, but you can also drag the whole thing around to like pan along your timeline. The timeline plot supports like a lot of different parameters. So you can add things like titles, you can add secondary data sets. And I'm not going to go through all of these, but I'll just show you a couple of them. So the first and one of the most useful things is to be able to group the stuff by one of the columns. So here we can do the same kind of timeline, but we can split it out into the processes that are executed by different users. Still kind of not very interesting tooltips there. And then you can obviously do this with different kinds of groupings. Might be the process name. That's probably like to give you a lot of things in the vertical column, but that's immediately more useful than just seeing all of the processes. One nice thing would be to be able to display more data on each of those things as you hover over it. So we can have a look at the columns we've got in our data set. I said there's a lot of columns, 103 columns. We want to pick a few of those to show some interesting tooltips. And actually, oh yes, I probably need to do that. Maybe take source columns. Oh, I'd already. This was kind of an interactive training thing. Source columns. Oh, maybe source columns. I can't remember. Can't remember the. There we go. Source columns. And we just give it a list of process name. Let's pick a couple of others. Correct process account name. Maybe the command line, or if I could find it. So now we have the same plot with hopefully more informative items. And you'll see like this is doubled up. Great process name. Did I type the same thing in twice? No. This typically indicates that we're looking at more than one item under the cursor. So we can kind of zoom in a bit to try and isolate them. And you can see that it's kind of immediately more informative. You can kind of like traverse across the processes, seeing a little bit, and if it gets too dense, you can expand out and see individual processes. We have some kind of variations as well, some variants on the basic timeline. One which is pretty simple. It just does the same thing, but it sort of highlights the beginning and end of a particular grouping. So here we're grouping by created process account name, and it shows you just more clearly the beginning and ending of like when those sessions happened a lot here, the entire timeline, but some of them like begin later. So that's just like a bit of visual sugar, I guess. We have another thing. If there are scalar values associated with these things, so you might think of something like number of bytes transmitted, or some other kind of scalar value that you want to represent on the timeline. We also have something that's timeline values that allows you to do that. And this is a little bit more complicated. So what I'm doing is here combining this bit, which really this is just a query that returns a data frame. So the plotting bit is all this bit at the end. And the one additional thing we're adding here is like the value column. So this is network flows, and we're going to plot vertically on the graph, like just the number of flows for this particular one. Otherwise, it's the same kind of concept. Okay, so that's timelines. I think that was most of the variants, and there's a lot more things you can do with it. You can add titles and something more interesting than a timeline. Multiple data sets. I think this doesn't work. I mean, in Jupyter Lab and Jupyter Classic, the Bokeh legend here allows you to like deselect and select these, which is useful for separating out different kinds of things. We're grouping here by layer 7 protocol. This doesn't seem to work in VS Code. I need to talk to the VS Code developers and see if they can fix that. Okay, so second thing, which I consider as like an essential tool in the SOC analyst, is the ability to visualize a process tree. And here we're taking the same process DF we had above and building a process tree. And this does a lot of stuff for you already. So it kind of will pick out some of the common kind of commands like the user, the command line, stuff like that to display. You have like a little bit less control over what's displayed here, mainly because it just messes up the display logic if you have too much stuff going on. There's a similar kind of thing that you can like scroll around. By default, it colors these things by level, but you can also supply a parameter that maybe you want the coloring to be based on some other column, like the name of the process, or maybe the logon ID or something like that. It allows you to kind of navigate through it more easily. You can, I think, yep, this is exactly what I'm doing in O. So let's say, let's take our initial thing, and I think we'll group by process, if I can remember this. Work. Is that the right name? No. Let's say I need to copy and paste from a previous example because I can't remember the name of the column. Created process name. Did I mistype it? No. Well, impromptu talks often give you impromptu errors. For some reason that's kind of missing. I'm not sure why that is. But in theory, you can do that. Group by is not a recognized argument until. Oh, okay. This was an example of valid options. This is an example of our inconsistency of parameter names that I was talking about. I think it's maybe a legend column. Let's look at my hints. Legend col. Sorry about this. Okay. And now we're kind of coloring them by the process name. You can also have a simple data viewer at the bottom, I think, as well. And I can't remember the parameter of that, but you can it will display like a table of the individual values, and as you select these ones, it will show you below. We also have a bunch. Oh, one thing I didn't mention is that the process tree obviously needs to know a lot more about the data than something like the timeline, which only needs a timestamp. So process tree needs to be able to work out what process ID, parent process ID, process names, stuff like that, to be able to build the relationships between these items. So in many cases, it will recognize the schema of the data you're sending into it. So it will recognize it in the case of like Microsoft Defender, like Sysmon, Linux Audit D, Windows events. In other cases, you might need to supply it a schema. So this is like a simple dictionary where you just map, and you can really need to consult the Mystic Pi documentation about this, but it's very simple. You supply a dictionary that's a mapping dictionary that says this field is process ID, this field is parent process ID. So you can reuse it with, as long as you have like 4 basic elements, like the process name, process ID, parent process ID. You can kind of use it with any data. We do have some kind of utilities to go along with the process tree. This is not really visualization, but we can build our process tree separately and then do some kind of analysis on it. So we can get the roots. These are all the things that were in the tree that didn't have any parents. Pick one of those and get its children, immediate children, or get all of the descendants. So there's some kind of utilities that go along with process tree. Use that. We can obviously query the data frame itself to get certain types, and it shows you here the keys of some of these things. And because these things all return data frames, these kind of queries, you can also plot the subtrees from these things. So this is not a very interesting one, but just if you've already narrowed it down to, a particular account or stuff to do with only with PowerShell, you can create subtrees that are maybe easier to look at than something with like a few thousand nodes in the tree. So that's process tree. So we recently added, I think in the last few months, a way of kind of plotting arbitrary graphs from data frames. Now, this is nowhere near as sophisticated as Graphistry or even PyVis. It uses Bokeh, although we are planning to have PyVis as an alternative kind of interactive display for this. So, but this allows you to, from a data frame, you can just transform an arbitrary thing into a graph. Now, some people might say a data frame already expresses a graph, but you specify a source column and a target column, and they're the nodes in your graph. You can add additional things like the attributes you want to display as hover items, and whether it's like a directed graph or just an undirected graph. So let's have a look at this. We're going from our same processes graph here, and we selected the account name and process name, and we're just going to plot that directly. You can also output this as a network X graph and import it into other things if you want to do that kind of thing. Now this is looks a little bit kind of messy, but as we zoom in a bit, you can start to see kind of things here, and we've got basic. In this case, we haven't added any hover items yet, any source attributes. And this is a similar thing with, let's have a look, source attributes. You kind of roughly get the idea. Create a process, let's say. It's not going very well. And you can add, in the same way as all of the other things, you can add attributes to these, and it will show up as you hover over. Similarly with edge attributes, I didn't add any edge attributes in this example, but that will do the same thing as you hover over an edge. It will show you that I haven't added any here, but if you had added them, it could show you things like, it might be like the creation time or something like that as an edge attribute. Okay, I'm just going to go straight and copy my solution here because I don't want to waste time. As I said, this was originally kind of presented as a sort of interactive workshop. We don't have any time for that. We're just going to copy the code. So here we're just looking at where the parent process is command.exe. We're adding a few attributes. but plotting a kind of a subgraph. So here, these are all the things that have been launched by Command XE, and you might do things like look at things that are launched by PowerShell or by Word, for example. You know, Word, you wouldn't expect that to launch a PowerShell subprocess. Example of how you might use it. So it will, as I said, there's an alternative thing. So this is not for plotting, but for creating a network X graph, which is usable and importable by lots of things. You can use the built-in. I thought you could use the. You should be able to use the network X plot, which uses matplotlib. It's a lot more kind of primitive, really. But you can import it. You can export it as dot files, or for importing into other graphing tools. But just to show you that even if the draw doesn't work, our NX graph. Is really a network X graph behind the scenes. Whoop, quite a big one. I'm not going to scroll down all of that. Get rid of it. So as a little appendix, I don't think we actually got around to doing this in the workshop session, but we've got a few other visualizations. So one of them is a matrix plot, and this is just a very simple, kind of a little bit like a network, I guess, really. It just shows us the relationships between two X and Y parameters. And you might say this is like a little bit boring, but sometimes if you want to find like which account has run what process, for example, or who is talking to who, these kind of visualizations are often quite useful because you can immediately see that this interaction is a lot more common than most of these items. And you can imagine this also with like different computers talking to each other, that kind of thing. And there are also some variants of this matrix plot. One thing you might want to look at is the inverse of this. So you see like on here, like larger circles represent more interactions, but this just plots like the inverse of this thing. It's showing larger circles as being rarer interactions, which is often what you want to see on the graph. You can also apply kind of log scaling to some of these things to sometimes make it a little bit clearer. And this is just another example showing you processes executed by individual users. The final one, I think I showed you an example, at least in the Keynote presentation yesterday, but actually seeing it in real life. So here we're reading in a data set from Cobalt Strike C2s and just getting the IP addresses out of that. And then we're plotting them on a map. Anyway, that mostly worked. And there are different options you can supply to the folium. Like you can add additional layers. You can provide a grouping column that will break the things into different layers and control kind of clustering parameters and stuff like that. So that's the final, I think, section of Mystic Pi visualizations as they stand. As I said, the one thing we want to try and do in the near future, or two things really. One is supplementing the Bokeh graph visualization with a PyVis, which will give you like interactivity, the ability to like filter dynamically, change the physics of the graph, and drag nodes around, that kind of thing. The second item is we wanted to expand the timeline visualization so that you can interactively add additional data sets, maybe scope the time range for each of the sets, and also introducing something that I'm borrowing from Seaborn, which is like having a jitter in the timeline. So if I scroll back up to my original flat timeline, so rather than have these all in a single line and everything overlaying each other, sort of moving these around vertically so they're kind of clustered, so you get a much better idea. It's really difficult to see from here like exactly how many events are happening here versus here. They both look a very similar kind of color, but so it's just like a display option. And I think that's around about all I had to say. Depending on how much time, I do have like a little bit of extra stuff. What are we thinking, Roberto? How far are we from the next?
Yeah. No, I think that we should be good. So the next one starts in 4 minutes. So that's a good time.
Okay.
Yep.
Mm-hmm.
Yeah, let me see if there is some questions in here. I think that we have some comments about what you were presenting. So there is, let me make sure that I can bring this to this other screen. So there was a comment by Ryan, who presented also yesterday. And he says, aside on visualizing time series data, one of my new favorite visualizations for multidimensional time series data is Plotly's density heat maps. So that's something that he's sharing. I don't know if you've seen that one. There is a link also in the message, so maybe you can see what he's talking about.
Yeah, we definitely have like we kind of like so far, because we so far avoided using. I mean, Plotly's got some great visualizations. We so far avoiding using Plotly directly in Mystic Pi, partly because we just hit on Bokeh initially, and we're just trying to like limit the number of packages that people have to install when they install Mystic Pi. But I'm kind of feeling that that we're gonna have to bite the bullet at some point, like maybe introduce Panel and Plotly. Yeah, it'd be a great thing to look at. And we also have like optional dependencies, so we could use that. That's great.
Nice.
Yeah.
Yep. So the comments were around that, and I think that there is some more details in there. There's like a long text that maybe you could take the time to see if there's any comments that you have on that. And then just others that are liking your presentation. Also, I believe that the next presentation will blend in. It seems like, based on the comments of the speaker, that it will blend with what you presented a little bit. So that's super cool. But thank you very much, man. There is a lot of stuff that I still like. I'm still learning about Mystic Pi. So the more I see it like in action, I'm like, oh, so you guys had this feature as well. So to me, like, I know that I can read the docs, but I like when it's like sharing. It's like, oh, we have this, you can do it for this, right? So
yeah, I've learned so much over this last day and a half. And I had exactly the same thought. Well, I could always read the docs about that, but then like Panel is a good example. But you never, there's only so much time in the day, and you never actually get around to it until somebody shows it to you. It's like, oh, look how easy this is.
Yeah. And of course, just for those that are trying to follow this as well, like in the stream. So Ian added the link, right? Because this is part of the workshop that was provided, right? Right?
Yeah, you don't get any narration, but they're fairly well commented, so it's pretty easy to work out what's going on. And as I think, there's like little exercises in there, but there's like a drop-down hints thing that just gives you the answer in most cases. So you should be able to kind of navigate your way through it.
Awesome.
You should turn it into sort of tutorials at some point.
Awesome, man. Thank you. Yeah, thank you very much, Ian. And I guess we're moving to our next talk. Ian, you can take
Yeah. Yes, I go from presented. I don't know.
that.
From introduced to introducer. Yep. So I'm delighted to welcome Janantha. So a couple of months ago, I'm not sure how long ago it was.
Yeah, about 4 or 5 months ago.
Yeah, reached out to me on LinkedIn and said, "Hey, I've got this kind of like notebook that's kind of cool. Uses a bit of Mystic Pi." And I said, "Oh, this is awesome." He's like, "You mind if I like tweet it out and mention it?" Because I was super enthusiastic about seeing people use Mystic Pi, and I think it was like, I don't have a great Twitter following. It's like a couple of thousand people almost. But it's like, I think it was my most retweeted tweet ever. So it was just like, and it's even a couple of days ago, somebody like recently liked it or retweeted it. This is like 4 months later. So, so it's done wonders for my, like, it's a great, really interesting notebook. And, obviously very popular in the Twitter sphere. Well, at least as long as that lasts. But, great. So, so great. Thank you very much for joining us. You're joining us from the other side of the world?
Australia, yeah, in Sydney.
Yeah. Okay, so it's
well caffeinated, yeah.
Early in the morning. Not quite as early as for Thomas, but
yeah.
So thanks very much. Yeah, I'm glad it's not just me that has to get up early in the morning. I'll try and set the timings next year. Try and have some more influence over the timings rather than Roberto. Anyway, so let's get on with the next session. I'm anxious to hear this. It'll be really good. So
take sure. Let me get the. You can see my screen, right? Cool. Okay.
Yeah, you might want to zoom in a little bit.
Yeah.
Text. Yeah, that's perfect.
Cool. All right. So this notebook, it's my very first notebook. So I want this again. The intention for this Python script is to actually have some kind of a structured manner to go through Windows memory dumps initially. I'll probably expand this to other OSs like Linux and Mac. But what I've seen in the DFIR space is you have some great talks in like Black Hat talking about memory forensics. You have the SANS memory forensics poster, which actually describes a method where you can actually go in a structured manner, but no one has actually gone and thought like, okay, how can we use that great research work and make something in a scripted fashion, and also for an entry-level analyst to use that, go through that and learn how to actually do the initial triage. So this will not do the full kind of investigation. This will give you the leads that's required for you to actually assist you to actually get, starts from somewhere and then, expand and broaden your investigation. So I thought about it, and initially it was a Python script, like a very, very, I would say, boring Python script. And then Ian happened. So I was browsing because I was at a stage where I wanted to do visualization, and somehow I bumped into Ian's session and Pete's session as well. I watched both videos just to get my head around how Mystic Pi works. And yeah, I invested time watching that, and I then saw, all right, here are some of the use cases I can actually use and convert this very boring Python script to like a proper notebook. For this particular project, I decided to use CrowdStrike Supermem. The reason it's kind of I would say an abstraction from you doing a lot of manual commands. So you can just literally say, here's the memory dump. There are like 3 different triage modes. For this, you can actually use 2 or 3. What it does is it automatically recognizes the operating system. It picks the actual volatility profile. So people who do not know about memory forensics, volatility is an open source memory forensics framework. It's heavily, developed, and it is used widely across, different investigations. So Supermem is just a wrapper around volatility, and it basically simplifies stuff. And the beauty is, apart from it running plugins which are available in volatility, it also dumps other stuff such as DLLs and various other bits. So this is an experimental notebook, which is still being developed. I still got a lot of cool ideas which you can implement, but yeah, keen to hear your feedback. So as I mentioned, I'm using Mystic Pi. I've already got intelligence APIs pre-configured. So currently in this example notebook, I got gray noise and alien world OTX for the data enrichment part. It uses obviously the pandas data frames to do things. So all you have to do is you need to run volatility, and you very much use the CSV files output from the CSV files, because you can do like memory forensics manually, like, all right, PS list the processes, manually go through it. But then you have the questions, okay, can I see, SVC host, which is trying to mimic the actual legitimate SVC host? Or can you actually see quickly the SVC host with a 0 in it? Like, it becomes harder, and some of the memory dumps that we get in production environments pretty complex with a lot of processes, and it actually will kill your brain going through it. So this notebook, it intends to assist you with that by going through that in a structured manner, so you actually don't miss anything, right? So if you do not have the CSVs generated, I have a cell where you just give the memory image and the CSV output, and it'll run the actual plugins that's required for this notebook as well. So currently I'm using the Australian Cybersecurity Centre's CTF that happened a few years ago. It's readily available. If you want to actually use that as a data set, please go ahead for your projects as well, because it's got about triage dumps from, I think, 6 Windows hosts as well as a memory dump. So I'm using the memory dump to actually go through this notebook. And here I'm pretty much loading all the CSVs that we are using for this notebook into a different data frames. There's a bit of like massaging of data that we need to do, because for example, the PS list output within volatility, it gives you the parent process ID, but it doesn't give you the parent name. So I need to actually, I had to find a way to actually create a new data frame which actually adds that parent name, because it's more human readable and you can actually do a lot of other cool stuff with it. The other part that I'm doing here, as you can see, is I'm looking at widely targeted Windows processes, which may be used by adversaries to actually blend in, right? As well. So they can actually have, iExplore with, some other character and things like that. And then you have like Windows processors that should only have a single instance of it. So I'm putting those in separate lists. And also, then we basically start the analyst, I would say, tasks. So the way I segregated this book is you have several tasks for finding out suspicious or malicious processes, or get you to actually run those. And then you have the network parts where you can actually look at the network telemetry, see if there's any suspicious or malicious behaviors, and then you pretty much go to like the kernel level and so forth. So I'm pretty much going through like from one pointer to the other. And as I mentioned, this is an experimental notebook, so it'll keep on evolving as I add new stuff. So the very first thing, I'm basically checking whether there are any processes where there's more than one instance. And obviously in this memory image, there aren't, but if it did have that, it'll actually flag it in red, saying that it actually found it. Like, for example, a second LSAS process spawned from a different directory. Then we look at, troubled kids. So, so you're looking for suspicious parent-child process lineage in that scenario. So I got a bunch of processes which are commonly, I would say, seen in the wild, and see if we can actually find any outliers in that kind of parent-child process lineage. The other one I've got is the using Demereau-Levenstein distance. So that for some people may not know this. So Demereau-Levenstein, what it does really is it actually calculates the distance between two strings where a change can occur. So for example, if you have SVC host and SVC host with a 0, in order for me to change that, it's just one change. So that's the distance. So a lot of malware developers, or threat actors, they actually use that to blend in with the normal processes. So I'm using the Jellyfish Python library, which has the Demereau-Levenstein distance function, and I'm actually first grabbing all the live processes that are there, and I'm just using the Levenstein distance to calculate the changes. So I'm actually using the list in here. And then because that's the most targeted ones, you can keep on adding stuff as you find based on Intel. And I'm calculating that that distance. And currently it's actually firing on up to 2 equal to or less than 2 changes. I found that if you actually put 3, you get a lot of false positives. So I've been keeping it at like level 2, but obviously based on requirement, you can change it as well. So as you can see, it actually got the live process and the base process. Base process is what you're basically comparing against. It actually detected the W in there, and the distance is 1. Next thing, we go for runDL32 and SVC host, commonly seen without any command line arguments. And then we actually look at processes spawned from suspicious folder locations. So in this scenario, we already found our first lead, right? So the PS client.exe is spawned from public classic, and you have an IP there with a port there. So you could actually start your investigation. It even captured the memory dump that was executed on the host. It uses WinPMM. The other cool thing that Ian showed earlier, which is a nice segue, is actually do a visualization, because as humans, we like visualization. If we see things, we can actually analyze things easier. So in this visualization, I'm pretty much plotting getting that parent-child relationship and putting it in a nice graph. So I already, because of time, I already zoomed it in. And as you can see the PS client spawning from PSM Prob Force. So it's using PowerShell remoting to do that as well. So that pretty much shows you the thing. And I've also included tooltip. You may find the NaN in exit time, because not every process will have an exit time recorded in the volatility dump. So it's a hit and miss if it exists or not. So that's something to watch out for. And then I'm also looking at anomalous process detection using time series. So you can actually see the process start time and end times and stack it against and see which process was spawned after what, right? So I thought this would be a really cool thing to have, to actually find out, okay, the subsequent kind of processes that are getting spawned after, like, that exactly this malicious process spawned. So I won't go in deep, because you've already covered this in Ian's session. Then we look at these suspicious command line arguments, because from the volatility image, you get the full command line arguments as well for every process. So I basically run a regex on top to see if there were any command line arguments that are there. Also, I've used the IOC extractor to extract the observables that are there using the command line parameters, which is really cool, which I really liked. And also look at runDL32 spawned by suspicious parent process, such as Winward, which is classic. And the next one I wanted to show was this network interaction. So you can actually see which IP communicated with what IP kind of thing, which will give you like clues in doing stuff. And I thought it would be a good visualization for the analyst. And then also stacking by number of occurrences of a public IP, which gives you potential avenues for investigation. So I'm trying to put tasks so you can actually catch someone at least one of the tasks. That can be a lead that can be fed into the investigation and expand and start pivoting from off that. Then the other cool stuff which I really like is doing data enrichment. So currently I'm grabbing all the closed connections, because volatility in the memory dump, you will actually get closed connections as well as live connections. Sometimes you may find malware beacon IPs in the closed connections. So what I'm doing first is, okay, give me all the intel where there's an actual positive hit on closed connections, and it actually runs it and actually gives you that, like, this will only show you if there's an intel match, because that's kind of actionable to me. So right now it actually gave some information from the OTX. Then I want to check suspicious web connections that are not related to browsers, right? So I'm looking at the standard web connections and see which ones are not like getting there may be some whitelisting you need to do, but I found it interesting to have that in there as well. And also it actually provides the enrichment based on the IP as well. Next thing is IP address in command line, which is classic. A lot of adversaries still use the IP without using a domain name. And as you can see, we caught that outbound connection to that very strange port. Then we look at kernel callbacks. That's the kernel callbacks CSV that we previously talked about, to get an understanding if there's any rootkit based activity. So from this way onwards, I'm actually looking at rootkit activity. This was based on like the SANS posters as well as the memory forensics knowledge that's out there. So I'm pretty much running this query for you. So you can just run the notebook and see if it has an actual hit or not. So there's about, I think, 3 rootkit based kind of searches that's used to do indicators. And then we look at suspicious service names. Again, that's service file name. So what's actually inside the service file name field. I basically put some of this based on my my experience in working in different cases. What are the common things, strings that you find within the service file name, and if it's something there, just fire it. And then also looking at regex based searches on the actual service name. This is based on various research that's done by the open source, open thread research community. And then I go for the name pipes, which is pretty good to find, SMB beacons. So that actually runs a long regex here, which is based off, again, open thread research kind of people done. And I pretty much put a regex to actually cover it all to find out any suspicious ones. And also the DLL and driver files that are located in suspicious places as well, unusual locations, or if there's an actual what you call in the path, like it'll actually pop up as well. And then some malware, they have really long file names. So I'm trying to catch that as well. So any DLLs which got like a really long name anywhere within that DLL list output, I want to know about it. And the classic is, for process injection and so forth, you can do malfind plugin, gives you a quick win most in the cases. So I'm pretty much looking at the MZ header within the output as a first kind of pass. And then I'm looking at another way of detecting injections using malfind using like the actual assembly code that's used. So yeah, pretty much that covers the notebook so far. So any questions?
Yeah, thank you very much. Yeah, thank you very much, Jananta. And I was actually looking at some of your stuff that you have under Blue Team Ops in GitHub. And a lot of cool stuff, man. I like that. I like that. Yeah, so I got to spend some time to dive into all those resources. Ian, do you have anything you want to share?
Yeah. Yeah, thanks very much. That was a great session, and it kind of well, uncovered for me like how much interest there is in kind of analyzing forensics. Like we kind of started life with notebooks and Mystic Pi as like a thing to look at logs in something like seems like Sentinel or Splunk. But the forensics has always been to me like a little bit of a kind of thing that other people have done and I've known a little bit about. But yeah, I was like surprised at how much interest there was, and also maybe even more surprised that stuff in Mystic Pi is kind of like directly useful for analyzing that stuff. So one of the things we wanted to try and do in January, we have like a hack month where we can just kind of explore new ideas and things, is taking stuff like this. Because one thing we might be able to do is just like make things a little bit more easily usable, is like take the output from a kind of memory forensics dump and just make it available as like a data provider in Mystic Pi. So you can just like run the tool and it will kind of hoover up all of the CSVs, convert them to DFs, and we'd like to try and do that with like Velociraptor and OS Query as well, which are sort of similar kinds of things. So this is like a new area. I mean, I've always assumed that like forensics was just such like a detailed, like reverse engineering binaries and things like that, which is like completely outside my area of expertise. So it was great to see that it might be useful somewhere else as well.
Yeah, thanks a lot. And also, like, this is just for like one memory dump. I'm also looking at a project called Orochi. It's in GitHub. It's done by a party called LDO Cert. You can actually upload multiple memory dumps there, and it will index everything in Elasticsearch. And it provides APIs. So that means I could potentially connect my notebook to that and do like at scale. So I'm just got the idea yesterday actually that should explore that one as well. So that you can actually look at the scaling. How can we, like if you get 50 hosts, 100 hosts, how can we actually scale that? And you could then go into like anomaly detection across a fleet kind of thing rather than just one.
Yeah, particularly where you're kind of trying to understand some relatively large break-in in your organization, and you've kind of got dumps from hundreds of hosts. That's kind of
So some of the I guess comments right now. Well, there's a question first by Ryan Cup. So out of curiosity, how do you generally collect your memory images for analysis, or are you just connecting to the host via things such as fresponse, for example?
It depends on you can use open source tools as well, and it depends on like if it's a VM or a physical host. So if it's a VM, you grab the vmem and vmsn and you go down that path and do that. Of course, you can use fresponse, or there's WinPMM, which is I've seen used widely, which is stable and provides that. There's other tools that are paid that are there as well. The only thing is Windows memory dumping is and analysis is good, but then you have this Linux side, which is totally a different, especially when you have investigations on like a very old Linux version with an old kernel. there are some advanced techniques that you need to use to actually pass the pass the data. So in terms of tooling, it depends on, you can use fresponse. You can, if it's a VM, pretty easy in that scenario. Usually, if it's a physical machine, you need to be doing minimum damage to the source host. So you either do it via you mount the actual binary on the network share and mount the actual network share on the target host and grab it from there, or connect via USB if it's somewhere that's isolated, disconnected, or like in a, I would say, gap kind of scenario. Hope that answers the question.
Yeah. And then overall, I think we have some comments like, super useful notebook, right? Great presentation. For example, some comments are around that, like doing memory forensics, right? It takes time, right? Because of some of the things that you need to do. Sometimes, right, even like manually, like running a few things. So some of the comments is good to see like how these kind of expedite some of that process, right? So the notebook is super useful. Then comments around how with things such as EDR, for example, like talking about memory forensics or analysis, even like live analysis, right? Because you can do as far as I remember, because it's been a while since I've done memory forensics, to be honest. Like I used to use recall for live memory analysis, right? So that was something that was super useful, right? Just to kind of so for me, my process, and this is probably where a notebook would have been super useful. I used to use, and please no one laugh at my process, right? It was just like a very hacky way to do it. But so what I did is I took something such as PowerShell. So what's it called? PowerShell Netcat. Okay, what is the name in PowerShell? I forgot the name of the project, but it's pretty much like Netcat, but in PowerShell. I think it's called PowerCat. There you go, PowerCat. So PowerCat, and then kind of like modify the code a little bit just to make it easier to add some modules. And then I would use recall on boxes. So I would connect to the box, do the stuff. But of course, it was more for like research purposes. Like I was trying to figure out how to do that because that's not some of that the connection, of course, is not, I would say, like appropriate in some scenarios, right? Just to connect with PowerShell. But I mean, it's using a built-in protocol, I guess, like PowerShell remoting to like also, or TCP connections as well, if it's using PowerCat. So I was trying to test both, right? How to use PS remote and PowerCat with TCP connections. And then recall was the thing, just to start, running a few commands that I had in this PowerShell script. So I was trying to go and do this live analysis, but I think that Jupyter notebooks would have been useful to have like a couple of different workflows and explain exactly what I was doing, because it was hard then later to do like, what do you do in this box, right? So it's pretty cool to see now it's possible, right, through a notebook.
Yeah, and the other thing that I'm working on is, once you have that lead, to auto run some of the surrounding stuff I want. For example, I want to know what else is in that public user/public folder. So you can use the file list within the memory image to see that if there's anything else. So like what happens around that time within the memory. So using the memory dump, what other things happen, what other files were dropped, likewise. So that context kind of thing, you pick one thread and you just try to go through that kind of lead. So
awesome, man. Yeah, this is pretty cool. So once again, another example of like how useful in another area of cybersecurity, right? Or just security in general, like some examples of notebooks. So to me, I'm also taking notes of like when there is a use case for like malware analysis, let's say, or direct, memory forensics, which of course could get into like dynamic analysis, right? But I like to see like people like working in specific areas. So next time, there is a question about like, hey, do you know anyone doing forensics, like memory analysis forensics? I'll be like, talk to Jananta and go to this project. So, so it's kind of nice to do that, because there is just so much to cover, right, with notebooks. not necessarily like data analysis and using machine learning, right? It's actually used for a lot more than that for the security field, right? I think that's what I love about this, like different use cases. So
cool. Thank you very much for the opportunity.
Thank you very much. I really appreciate it.
Yes,
great work.
Cool. So I guess we're taking a quick 5 minutes break, right? Just a quick 5 minutes, it looks like. Yeah, 5 minutes. And then we have our last talk or section of the day, because we have the talk by John Mack about CVE data, which is it seems to be like a project to dive into some of that. And then also we have a speaker panel. So some of the speakers that would like to join us, we also have invited a few speakers directly that could actually stay a little bit so that we can talk about some of the topics that were in the Discord server, and then also answer any questions or simply brainstorm about some of the future things of Jupyter Notebooks. So stay with us just a couple more minutes, and then we start with the last section of the conference. So see you all in 5 minutes. Okay. Thank you.
Thanks.
All right.
Hey.
That's good. Last talk of right. Last but not least, last talk, right? Right.
Hey
Pleased
guys,
to
can you hear me okay?
Yep.
Okay.
Yeah, very pleased to welcome John Mack, who's an independent researcher. Going to be talking again about CVEs and deeper dives into it. So I'm a little bit flagging due to lack of sleep and too much talking today. But yeah, very much looking forward to this in our final session.
One thing that I wanted to say on that is that it's pretty cool that you're bringing like your first experience, right? Diving into a Python package, and Ian has a lot of experience like building Mystic Pi as a Python package, and every time I think about the packages that I try to put together to do something with Python, and then I see Mystic Pi, I was like, man, I have a long way to go to make this a very robust project. That's just my experience, right? Doing some of this, but also I like also your background. Like when I see your blog posts, for example, and the recent things that you've been sharing with the community, it's like this very technical Windows internals type of experience. And then now you're saying, all right, let me dive into Jupyter notebooks and see how that could help, right? So pretty cool. I just wanted to add that because I forgot that's. Now I'm kind of clicking like, oh, you're Paul, like this guy from Twitter that is sharing a lot of cool stuff. And so, yeah, thank you for being here, man.
Yeah, no, I'm happy to have the chance to be here. Yeah, this will be a story of my dive into Jupyter Notebooks, my kind of first look into it, and kind of the value that I saw applying it to my project. So I'm gonna go ahead and start. I'll go ahead and share my screen. I think I can do that. Let's see,
Cool.
Chrome tab. And I just learned how to write these. The Jupyter slides today. So here we go. CVE data. This is a story of me looking into CVE data in more of a way to kind of glean information from it. What can we observe from kind of the public CVE data that's out there? Microsoft has CVEs that come out and they publish that, and they make it available via their API. And what can we glean from that? And I started to look into these things, and this is the kind of that journey along the way. You guys have introduced me. I like to write about Infosec. I got into blog writing this year. I've really enjoyed it, and I'm happy to have this opportunity to speak here at this conference. I say I'm a pretend data scientist. I am not a data scientist at all. I am much more a security researcher who plays around with data, and you'll see what I've done here so far. CVE data itself, it's like the slide says, it's caught somewhere between a data collection tool where it's going out and pulling a bunch of data in, trying to refine that and parse it, and then providing an API for some of my other projects so I can kind of quickly use it. This is my final documentation, and this is kind of the output of the project itself. What I'm going to speak to is how I got to make it look like this, and I get to this point where I'm excited to share it and to walk through the data that's inside.
John, could you zoom in a little bit? If that's possible?
I think so. Let me see what I can do. No, it's not
Browser just
working. Browser's not happy about that. Yeah. Oh, I'm not sure if I can or not.
Okay, well, don't worry. We'll just.
Okay.
Yeah.
Can you see that? I mean,
so maybe the previous, I think, image was kind of like little, so that's what it looked little. But I think that the slides are now showing bigger, like the text is a little bigger. So
yeah,
that's
sorry.
Okay, good. Right. No problem. So this all began with a side project of mine called CVE Markdown Charts, and I had a tagline, basically, your Infosec reports will now write themselves. And the basic kind of premise behind the project was I needed a way to turn like a MITRE CVE search, like if you search for a Chrome used after free in the CVEs, the list of CVEs would come up, but I wanted to copy paste that into my Infosec report, or maybe my README on GitHub. And so I had found this library, and it's pretty ubiquitous. Or it's everywhere. It's in GitLab, GitHub, several. I mean, VS Code supports it with an extension. Jupyter Notebooks support it with an extension. Or sorry, Jupyter Books do if you have the right extension. And what you can do is kind of take plain text and turn it into a chart that looks like maybe this, like a Gantt chart. And or you can take a you can search for Windows something to do with the Windows MSRC API, and you can pop out something like this. Like, here's a distribution of tags across the update from August, or for Chrome data, here is the type of CVEs that you're seeing across the board. And so that was my tool. It was pretty simple. I basically pulled a bunch of data from MITRE, from Microsoft, and some Chrome CVE data. I put it to a magic script, and out came an amazing CVE chart. And so it was, began as a nice, simple Python script, and I think it progresses like all of our development projects do. We all start out with this idea of, I can automate that, and I'll turn a simple script, and it will be done. But it never seems to finish that way, because you always have this new idea. You always have this new feature that you want to add, and you never quite get to the done. And so what happened was I started to add a lot of data sources. And I was losing track of even the ones that I was adding to the project. And it was difficult to kind of keep track of what all that was. And so it was time to pull the data collection utility out of the tool and make it its own package. And then that's kind of how CVE data was born. And so I made it into a Python package. I put it into its own space. And so CVE Markdown Trust can just import that now as a package. And it was still pretty lacking, though. It didn't have much documentation, as I hadn't written any. And again, it was still this junk drawer of data, a collection of data. And I really needed a way to kind of to organize it. I had no way of seeing if the data was accurate. I was just collecting data, dumping it, and kind of doing my best. And so that's kind of how I started my journey into Jupyter Notebooks. I started to look around, and I found examples like Roberto, your project here, security data sets. This is one of my big inspirations for how I also automated a lot of the documentation for CV data, and kind of learned a lot from your project there. You'll see in my examples some familiar code. I think Jerry was going to present today, and this is another example of a Jupyter book, presenting data very well and very clearly. And again, Jupyter book was kind of another tool I had to learn to kind of build CV data and to improve it, to fix where it was broken. And so, we found Jupyter Notebooks, but I didn't really know how to use it. So I had to start experimenting with the data that I had. But I did find that, and I think even you mentioned this in your keynote, Jupyter Notebooks don't have to replace your work. They can augment it. They can make it better by allowing you to look at your data, know if your data is accurate or not, or improve the way that you're collecting data. I found a lot of improvement when I started to use pandas versus list comprehensions in my, parsing through JSON myself, and pandas really opened up that world for me. Obviously, you guys have heard amazing talks the past 2 days about data visualization. You guys know these things. There's a rich community. It's growing. There's even an Infosec flavor, which I'm so excited to be a part of today. And what else? And I think I'm at this point now, and this won't apply to all my projects, but now that I know about Jupyter Notebooks, I can't really see going back to what I was doing before. And so those are some of my thoughts. So this part is a lot more basic than what you have seen prior, but it might inspire you if you have a similar use case, or if you want to add Jupyter Notebooks to your project. And so this is kind of what I had done to take my simple kind of data collection scripts and to create something valuable out of them. So automation for your documentation, it's not quite as simple as calling this command line here, Jupyter book build docs. You do have to write quite a bit of code to make it work, but there is this nice package out there called MB format that allows you to programmatically build your Jupyter, like a Jupyter notebook. And this is where I saw this in security data sets and Roberto's code there. and realized, oh, this is really powerful because now I can automate the way that I build my documentation. To start the automation, though, you're going to have to, you have to start with some metadata. You can't just point it at your JSON file and make it work. So you will have to go out and build a metadata file that kind of captures all the data that you want to document. And so in this case, every time I would build a new data source, and this is some code from CV data, I basically would just call update metadata and call that for each data source I wanted to do. And I would capture the time it took to generate the file. I would capture the source, where the data came from, and then also some variables in there, such as do I need to normalize the data? And you can kind of see that in the parameters there. And it, in the project itself, I call it about 45 times. And it's building up a file, a metadata file that looks like this. And inside that metadata file, I'm keeping track of how big it is, how long it took to generate, and some key information like key index. Do I need to swap the accesses? Do I need to normalize the data? And that helps me build a dynamic notebook. So using code and within CV data to say, like, if my data file ends with a GZ, I need to gzip, or I need to decompress it before I load it up. And you can kind of build that throughout, and you end up with something like this. And so from this, I can auto-generate this file. And for all the generated data that I have, for each one, I can call in, and I can come in and then search that data to kind of see, V8, is how many components have V8, and it just kind of builds this automated file for you based on the logic we've put in there. And go back. Oh yeah, so talk about automation. So I just kind of, hopefully I've explained a little bit about how to build a notebook automatically from a data source. And then you can add that data source. This is my example of my GitHub workflow to build the book and then publish it to GitHub pages. I basically pull down my package, I download the data for it that's been pushed in the release. I call create books, which I think is the same name that you use in security data sets, and build the docs. And then you can call that build docs, and it becomes simple for you. This is just a screenshot of my book being built, and eventually it builds this page for me, and also what I just showed you. All that generated data, all the data sources I have now, the 45 different sources there are auto-generated as Python notebooks and available to me to explore. And so I kind of spoke to this, but this speaks to the presentation side. There's a lot of powerful packages for Jupyter notebooks. DataFrame obviously is the standard one, and this is what that looks like, for my data here. But with the simple addition of iTables package, you can add JavaScript tables. I realize the formatting here is not so great, but it does work as far as you can search again normally on that page, and it makes it dynamic. And so that's a really easy way for me to explore the data I've collected, sort on it, filter on it, and also display it to those who might want to use it if they want to import the package. Normalization, this is powerful, and again, these are the basic concepts of for pandas in this case. In my case, I'm pulling down information from to get the MSRC security updates, and I'm calling something like JSON normalize on this, and this saves me a lot of time in that I don't have to parse all that data out myself. I'm automatically getting all those columns to be defined well, and then I can just start using those with little to no work on my side. And that's a very basic thing behind pandas. It's not actually Jupyter Notebooks itself, but it was very powerful for me. It started to transform the way I was bringing in data and parsing it, and it really helped me out a lot. Analysis, of course, as we've been talking about this whole time. I've got some simple examples here. I built it's basically, uncache this. This is a simple chart using one of my resources here. I was able to map out kind of the greatest of all time researcher based on CV quantity. And so some of the data that I'm pulling out from the CV data is the names of researchers, how many they have, And the top 25, you can build simple charts. My charting skills are not so great right now. I'm pretty much doing bar charts and pie charts, but like you can quickly see like, okay, here's the researcher with the most, and then the next thing kind of move along there. You can also do a lot more complex things. And so as Roberto mentioned, looking at Windows internals, something I do often is patch diffing and trying to map a binary patch diffing on Windows. And if you're trying to map, a CVE to a certain binary, there's some things you have to figure out. And this is an example of me doing some analysis on data that I've been collecting. We'll take a look at that real quick. Using the notebook, there's a Mermaid.js chart there explaining kind of what I'm doing or where my data sources are coming from, what I am building. I'm trying to build a list of binaries from some of the data I've collected from this public project, and looking at Microsoft security update feeds. And as I came across here, I'm not going to walk through all this because I'm running short on time and all of those things, but I started to understand, okay, what is inside this data that I am collecting? How many unique updates do we have across the board? I started to be able to look into the data and to see, like for all these CVs that have come out, how many of them have actual a knowledge-based article about them with, and I started to chart and to see how many have extra information, how many don't, how many is missing, and then across time I can use that information to understand, to improve my data source. Like what type of CVEs don't we have any KBs for? Well, that could be a result of we're not pulling that data in, or they don't exist. So in this case, I'm missing all Microsoft Office KBs and SharePoint because those aren't included in the standards that I'm looking at. And so I can see that across the board. I can start to improve the source of my data by looking at all of that. Oh yeah, that's all. No, I have one more? No, that's it. That's kind of like the basic, a short, quick presentation on how I learned about Jupyter Notebooks, how it improved my CV data, and how it made it go from a very sad README page to something I could automate as something that looks a lot cleaner, and allows me to explore things that I couldn't see before without. This is a quick chart of like how long does it take to generate each source, and some of them take longer because they're doing a lot more legwork. I can see that across the board if there was an issue or something like that. And so to head back to the summary, I don't know. In conclusion, think about if you haven't jumped into Jupyter Notebooks, maybe this could be applicable to you. Maybe you need a way to document, and you're collecting a bunch of data and you need to visualize it. This is encouragement to consider that. I do have a lot to learn. I still feel like very new in this space. I think it's about a month and a half I've been starting to look into this, but I found it very powerful, and I can't look back anymore, I feel like.
Awesome, man. Yeah, thank you very much. Thank you very much for sharing that. And I think that it's pretty interesting how, let's say, for example, you mentioned, I was trying to do some basic things, and then of course it turned into some complex type of processing of data. But the basics took you to so even documentation, so even the basics of like building a project, right? Like it took you to some of those libraries that are pretty new. Like Jupyter Book is technically, I believe it's only 4 years old. I think it is, if I'm not mistaken, 4 to 5 years old. And they're still developing it. I mean, the whole Infosec Jupyterthon site is built in Jupyter Books. And when I wanted to update it for this year, I found a lot of functionalities that was not available last year. And now it's like a really cool docs right concept, like with the embedded Jupyter notebooks, and I think that just speaks for how we're getting into this stage, I guess, to start integrating docs with live interaction of code, visualizations of, it's something that, once again, a lot of companies are still looking for. Like, how can we build a wiki that is already integrated with our processes to query data, right? It's pretty interesting that you're already there in your project, right? It's amazing.
Yeah. Just been my first experience, but I feel like that project, Jupyter Books, is it worked really well for me. I felt the documentation was really good. It was pretty straightforward to follow through, and then I recommend that as well for people looking to document their data, especially.
Yep. One thing that that I wanted to say is so I started interacting with Jupyter Books since they came out, like trying to see what I could do with all that. So if you have any questions, or I would say if you would like to brainstorm a little bit some of those new functionalities, like I would love to do that. Maybe questions just to see what are the things that I probably did that didn't work, maybe, but I'm still new into that package as well. And then the other thing is that, for example, you were looking into how to programmatically create some of the Jupyter notebooks, right? And I actually had a conversation with Ryan, who presented on day one. He talked about magics, for example, and I was trying to build Jupyter notebooks from YAML files. And that worked kind of very well, because you can programmatically get the YAML files and then create your notebooks by using the NV converter, I think it is, the library. But then the more I was adding to every notebook, like the more descriptions I was trying to generate, my YAML files were just going crazy, right? There is just so much information that at that point you are building a JSON, like a Jupyter notebook in a JSON format. You're trying to just create all these nested things. And Ryan recommended to look into Jupytext. And Jupytext allows you to have markdown with syntax for Jupyter notebooks, so that then your your file actually could translate to a Jupyter notebook, and then the Jupyter book project will say, oh, this is a notebook, this is not a markdown file anymore, because it has the Jupytext header on the top of every file. And you can create some of that also programmatically. The advantage of that is that you can actually have a repo that will be able to showcase the markdown file like very well, because it's marked down, but then it could be executed or taken as a Jupyter notebook as well. So that's just something that probably, I don't know if it applies to your project, but it's just an idea that I was thinking when you were also, kind of like experimenting the creation of notebooks automatically, right?
Yeah. For me, it was just kind of starting with the basics.
An idea, I guess.
Yeah.
Yep. And then, so do you have any other questions, Ian, in the chat? Or
I don't think so. I was just going to comment on
there
Jupytext as well, because I think this is like an awesome. I can't remember the name of the Markdown extension they use as like a particular name for the.
Yep.
So, kind of like markup encoded and code blocks and stuff like that encoded in Markdown code blocks, like the triple backtick. It's kind of really cool.
Is it different from the MyST like that? I saw in Jupyter Books they support like this MyST format?
Yeah, MIST. I always pronounce it MIST. MYST.
Yeah, I didn't know how to say. Okay, MIST. Yeah.
MYST. Yes, MIST markup or Markdown.
Is it similar?
Yeah, this is like something we were kind of looking at, because we like maintain a lot of notebooks, and the fact that you could kind of generate a notebook or like combine multiple parts together from Python files means you can maybe test the stuff outside using standard Python testing stuff. Then you can kind of compile it into a notebook. It also makes stuff like Jupyter notebooks in GitHub are often like difficult to, because every time you save it, it updates all of the metadata. So when you try to do a diff, it's like 3,000 lines of differences when you've only changed one thing. So saving it in this Jupytext kind of MIST markup format allows you to just, it gets rid of all of that stuff and just like focuses on the kind of code. Yeah, so I think it's a really interesting area. I'd like to have. It's another thing I need to spend more time on.
Just need more time, right? Everyone needs more time.
Yeah. I kind of really sympathize with your point about, well, I just add another feature here. This looks kind of, yeah, that's the story of my life with Mystic Pi. It's like, oh, well, it'd be good if we do this. And then another day has gone.
That's right.
Yeah.
Right.
Yeah.
Okay. All right. Well, thank you.
Okay. Well, thank you very much. That was just, yeah, that was a great presentation, and actually a really interesting slant on. We've had lots of different data sources. That was the first time over the weekend we had a look at CVE as a data source. That was really interesting. Kind of things you could. Yeah.
It's a little bit different, a little tangential to maybe events or security events. It's looking like at the data itself to see what I can glean in the way of research for security, like in support of like Windows internals for me personally, or just what information is available to you. And also, I thought the researcher ranking is pretty funny. I think one of the features I'm going to release for CVE Markdown charts is a researcher vanity chart where you can generate your basically your resume or your CV, basically. based on your CVEs, but that's not here yet because I have too many side projects. But that's coming.
Yeah. Also, there's like potentially a CV embarrassment chart as well with the different products of like who's at the top.
That's true.
Yeah. Unfortunately, many of them seem to be from the company that I work for. So
that's because they have available data. They publish a really nice data set. That's it's a double-edged sword.
Okay. Yes. Roberto's disappeared somewhere. So I think now it's sort of time for our speaker panel. 5 o'clock. It's going to be a little bit unstructured. I thought Roberto was going to run it. I thought maybe a good kind of way into it.
Yeah. No, sorry. Just I was having issues with my my connection. I think that it was just all over the place. So I'm sorry about that. I'm trying to fix it. I think it's still a problem. So yeah.
No worries. So I think it'd be kind of good to, if I can do this, maybe share the. I don't know. It might crowd the screen a bit. I don't know how. Or I can just read out the things from the Discord channel. Some of the topics we. But maybe let's start and see if anybody has any initial kind of burning things that they want to. They want to raise. I've got a couple of things. There's a whole bunch of things actually in the Discord. I won't share it because it will push everybody else off the screen. And we want to see you all. Probably people don't want to see me because they've seen too much of me already, but the rest of you.
I can kick us off, if that's all right.
Yeah.
I happen to be at the center of the talking heads, so I think that this is the authority granted to me by the committee. So I really loved the analogy of the hiker and the parking lot and the chasm, and from the day one presentation. And I guess I was going to bring up to the group in regards to getting users into notebooks and making them feel comfortable and productive. Are there any things in particular that really stand out to you that were most important to kind of fix or solve or provide for them to kind of get them on that path? I can think of a couple things that were really effective for us, but I'm just really curious if there were a couple that, for you folks were most impactful for your users to get them feel encouraged to actually use your notebooks.
Anybody want to? I've got some thoughts about that. But,
I think I can add a few things. Maybe I see like from the various notebook presentations, like everyone has like the Python library and all of that ecosystem is so huge. Everyone does kind of things like a single visualization with like 10 different ways, right? And then probably even like as a beginner, if you start looking at few things, going from documentation or like some preferred GitHub links, there is a lot of I guess like a lot of things to look at, and then maybe that kind of push back a little bit, like if they don't have a structured approach, all those things. So I think I was kind of mentioning earlier yesterday that probably creating a structured catalog of things. We do have like a trainings and other things everywhere, but maybe like some kind of necessary startup things, if we can have like available as a structured manner, like either through Jupyter book or a few other things, that will kind of put like a one single place to look at, not necessarily pushing things like a single way, but probably just providing like these are the recommended beginner friendly ways. That's what like I feel like most top of the mind things.
Yeah, because there's two kinds of mindsets, I guess. There's like people who want all the options. It's like, oh, I want to look at all of this, like how different work. I remember my introduction is like, oh, which plotting package? Matplotlib, Plotly, Bokeh, you know, it's like at some point you need to just that just starts to interfere with you doing anything because you're just overwhelmed by the choice. So sometimes just like saying, well, let's just do this one and kind of package it up in a certain way. I think that was a kind of a big thing for us. I also think I think there's an unsolved problem which some cloud services have tried to address about how people just start using notebooks, like people who haven't ever installed Python before, or who haven't, you know, are used to just like clicking on an app store and it all happening, you know, not doing this like pip install this, pip install that.
Yeah, for sure.
I think
we in our experience, I think we're feeling so many of the same pains. So even if you do use an off-the-shelf hosted notebook service, it's still BYO dependencies, which in Python, everyone knows, not a fun time. So what we kind of came up with was there was a PEP, a Python basically agreed upon convention a couple of years back that are called zip apps. And the whole idea is like, hey, normally you install a bunch of packages. They go into this place called your site packages directory. Python can find them and import them. Wouldn't it be really great if you could just kind of like literally zip those up and then ship them kind of like a virtual environment, but as an actual tarball or a zip file. And even if we do use a hosted notebook service internally, but having, you know, our users try to go through a conda install, especially in those odd cases where like the pip dependency resolver will just take a really long time to find all the things, the many packages we have in our environment. It was just discouraging users from even doing it in the first place. It was like, all right, sign in, go and make coffee, come back in 30 minutes, and maybe your environment's done, or maybe it broke halfway and you don't know how to fix it. So what we started doing was centrally building in our GitLab a zip app which contained all of our dependencies. So we had one system, one pipeline would build one environment, push it up to S3 whenever the users would come in for the day. We just had basically a very simple script on the hosted Jupyter server that would pull down the zip app, effectively tell the Jupyter kernel, hey, or register it as a kernel, say, hey, this is an environment that you can actually choose from. And the benefit of that, beyond just being a lot faster to install, was that it kind of had a sort of a convention enforcement for us to basically say, like, look, folks, we're going to use Plotly for rendering. And that comes for free in this environment. If you want to do it somewhere else, you are perfectly welcome to do it. But it's at your own, you know, at your own danger. You have to learn how to install it. And by having that kind of guardrail made it just faster to actually get up and running, and less likely we're going to have problems when they actually do start using the notebook. That was big for us.
Yeah, that sounds great. I never thought about that. I mean, we've experimented with virtual environments and kind of scripted. Like Conda has a similar kind of thing where you can just specify an environment as a YAML file, and but it's still, yeah, there's still kind of a lot of moving parts before you can get to creating a Conda environment. Yeah, I think. I mean, there's some progress. I think the fact that Jupyter Lab is now available as a desktop app, and VS Code, I think, does a pretty good job of, you know, you install VS Code, assuming you've got Python somewhere, or kind of, but put most things together and you can just start running a notebook, which is kind of really what you want. I guess VS Code is maybe a little bit more intimidating for people because it feels like I'm not here to write code, I'm just here to run a notebook. I think maybe we need something like a VS Code schema thing that just hides all the stuff that's to do with writing code and just like presents the notebook as a full screen item. I'm interested in zip apps. I haven't really heard about it. I know you can distribute a Python package as a zip or a Python application. I haven't heard about like an entire environment. That's kind of cool.
Yeah, LinkedIn open sourced a project called Shiv that we use. It's just an implementation of it, but it really is just a zip file with a particular structure and then an entry point script. So it's the only thing you kind of really need to know up front is what is the path to the interpreter that will unpack this zip app. And the case of, for us, like we use Amazon SageMaker for our hosted notebooks. We know predictably for these ephemeral notebook servers or notebook instances where those are going to be. And it really couldn't have been easier. So we've been super happy with our experience with zip apps for sure.
Okay, I'm just going to list some random, not entirely random questions. So I think it's from you, Ryan. So it's like a debate about the Jupyter wars. Like, what do people like prefer to use? Jupyter Classic, Jupyter Lab. I think we've seen all of them. VS Code. It's also PyCharm and cloud-based services. And if you like one, why? I noticed Ashwin, for example, was using Jupyter Classic. Any thoughts on, other than just I
use Jupyter Lab and VS Code together, and one thing that annoyed me with the VS Code was that I was not able to copy paste text in Markdown.
Yes,
I cannot copy that.
That's really annoying, isn't it? It just picks up the whole cell.
Yeah, it's just the whole cell, and you just move it around. But on the other hand, Jupyter Lab, you need to be careful about the extensions, or sometimes you need to install the extension manually and enable it. And sometimes it doesn't work because of some of the dependencies in Python packages, etc. So it's also a bit annoying. I think it a bit depends on how complex stuff you are developing or you are working on. So if it's basic, simple, and if you don't need to import lots of packages, I think Jupyter Lab and both VS Code are good options. But maybe the most robust one, the Jupyter Classic, because it always works. You don't have to do anything specific.
Yeah, officially been out of support for several years, but yeah, it's still enduring presence.
I'm sure the Jupyter Lab developers would not want to hear this, but we were held back from adopting Jupyter Lab as our primary interface for all of our internal users because QGrid didn't have a proper Jupyter Lab extension. And that was such a common, we want an interactive table for data frames in general, and that was what everyone kind of used and relied on. And that kind of held us back because there were so many bona fide amazing extra features in Jupyter Lab. The tabbing and the multi kind of views and everything are really fantastic. The built-in Git integration for MB Git puller is now just part of Jupyter Lab. That's amazing for exposing catalogs of playbooks or notebooks for users to kind of choose from. But we're really kind of hoping to get past that rather silly shortcoming, frankly. But it's definitely one that a lot of the users would not leave behind.
Yeah. I mean, hasn't that been solved? I thought QGrid was now had a lab extension.
It does now, yeah.
Yeah, I'd have liked to use QGrid as well, but we have really our users. We need to support VS Code. We need to support Azure Notebooks. So wherever you need an extension of any kind, that's like that's why I was so interested in the panel tab that Mehmet showed earlier. That was what I can't remember what it's called, the table browser thing.
Tabulator.
Tabulator.
Yes.
Yeah, that sounds kind of awesome. Kind of anybody else on the current question? Why they prefer it?
I only know VS Code. Sorry, I mean, my only experience has been VS Code, and that's so I've not seen anything else really. So can't help you there.
So I was a confirmed Jupyter Lab user for many years, and the thing that took me to start doing I used to write all the code in VS Code, and I would do all of my experimentation and feature building really in Jupyter Lab. But the debugging in VS Code, I know Lab I think now has something if you install the right kind of kernel, but particularly building things, so you can go from a notebook and you can step into code, which is like a package developer. You kind of not just want to debug the stuff in the notebook, but you want to, ideally you don't want to use the built-in debugger because it's really horrible. But the fact that you can in VS Code navigate through your code and you can set breakpoints anywhere, that was like a killer thing for me, that just okay, I'm switching from Jupyter Lab, but I still have a lot of fondness for it.
I can't live without Pylance. Like if you do any type of type annotation stuff, having that ready at hand and have it yell at you and you do something silly, it's hard to develop on regular Jupyter Lab in comparison now. I'm sure there are some extensions that support Pylance or Jedi or something, but yeah, the VS Code experience for library developers is really, really nice.
Yeah, I think there is. Just before I stopped using it, data does have its own kind of language server and IntelliSense. So things like Black support, and so I kind of miss it. I'm still very fond of it. I was going to put up the next question, or next kind of I don't know. This could get into. I don't think it should be which hosted service is best, but particular challenges maybe with hosted services. Because I think there's there's SageMaker, Colab, there's kind of roll your own Jupyter Hub. Microsoft have a couple Azure Machine Learning and Azure Synapse. But if people have used that, any particular kind of challenges they've found with those, using hosted services versus running notebooks locally, or benefits?
So I would say that, I have worked with SageMaker before, and now I also experienced the Azure ML notebooks interface, and I think Ashwin can actually talk more about this, but I'm putting Ashwin on the spot in there. The functionality is not the same, right? There is a couple of things that are still missing from what someone is used to when you are working with Jupyter notebooks like Classic, Jupyter Lab, and that's what a lot of these services. So maybe this comment is more about the interaction experience of the service, right? I feel that when the service starts getting very close to Jupyter Notebook Labs or Classic interface, then they add the feature of oh, you know what? Let's just drop you into the Jupyter Notebook experience that everybody's used to, right? And I think that maybe at the beginning of this year or last year, some of these services were still, in my opinion, not as rich, with a lot of features. And some of that gets confusing, right? But I know that over time, all of this is improving, and I guess that maybe there is even a updated interface that it's easier to interact with. But I would say beginning of the year, last year, it was not where I believe I wanted it to be as a user, right? So that's one of the comments that I have, and maybe complaints, all right?
Yeah, I think there are right now there are very few options that will allow just going from a GitHub notebook link to an editable hosting interface, right? Binder Hub is kind of one thing, but apart from that, we used to have like notebooks.azure.com, which is like decommissioned now. But then Google, and then I think I've seen like DeepNote in few repositories, but there are like very few which still requires like probably like easier just log in with your existing Gmail account and then get going. So with the free CPU and other things, that will be good. Yeah.
Yeah, I don't know what it is with I mean, when I say we, like Microsoft, also, and it's kind of a nice interface. I think the Interact stuff, but because it's different from Jupyter, it's not kind of like a Jupyter Classic, Jupyter Lab. There are things that just don't work as you expect them to, and I think that's also the case with Colab and SageMaker. They're kind of like, they are notebooks, but like you can develop a notebook and put it in one of these environments and it just doesn't work because there's some dependency missing, or widgets work in a different way, or they don't display. So I mean, I think one of the things I found like Azure ML at least allows you to kind of remotely use VS Code or open a Jupyter Lab interface, which is kind of like a way around that, but it's difficult to find. So there is another option, which again, I think I'm still on Ryan's comments. Has anybody tried Jupyter Lite, like Pyguide, like Jupyter in a browser?
It is absolutely insane to me. They got as far as they have already and seem to have a lot of momentum to keep this up. Basically, any pure Python code, for the most part, will just work transparently in the browser now via WebAssembly. Anything that has a C extension, you generally have to do some sort of porting to get that up and running. But at this point, they already have more or less the kind of classic data science stack working in the browser. And to have, instead of having to worry about instances or your Binder Hub container and where it's actually running, to just send a user a link and have their own browser, give them a Jupyter Lab interface, is just, the idea is incredible. There are tons of rough edges still that like will absolutely burn people. And also some kind of anti-patterns that are unique to the fact that you are working in WebAssembly. You're not really in Python, at least natively. But I think it's super promising from a tutorial perspective, or if companies want to start incorporating Jupyter as a product feature without the headache of actually hosting a notebook environment for their customers or something, it's pretty amazing. Kudos to that team.
Yeah, the libraries that I showed today, they support Jupyter Lite or Pyodite. So which
really?
is quite cool. Yes, they also implemented that. You can just deploy it.
Wow. Yeah. I think
we should do a Mystic Pi hackathon and try to get everything up and running.
Do we try it? I think Ashwin tried it, and it kind of nearly works. I can't remember. There was some dependency.
Got to try harder, right?
Yeah, I'm not sure I kind of like rebuild other people's libraries, because they're like Mystic Pi is pure Python, but there's a lot of dependencies that are like C extensions. And, I think most of those are probably there, but it's always like the one or two packages that haven't quite made it yet. But it's such a cool idea. Yeah, the fact you can just open a browser and you don't point it to a URL and everything is there. You don't have to like install anything. That's like, I think that's the nirvana for, and that may really change the audience for notebooks. I think. I think we already seen that in like there's some stuff in the Microsoft Data Explorer where there are notebooks there, and people use those quite a lot, I think, because they don't have to do anything. It's just there in the browser. But yeah, having everything in the Jupyter Lite yeah, I'm looking forward to that all working. Yeah, we should probably have a go, see if we can get that going. I was going to. So the next thing, scheduling notebooks, Papermill. If people want to talk about anything else, by the way, I'm just like putting these things on the screen that were put there in the, feel free to like add a topic or just start talking about anything else. I can.
We've gotten a lot of mileage out of Papermill. Obviously, it's really great. It's a great package. It works super well. In regards to scheduling notebooks, we do, for example, run Jupyter in Lambda functions, which has worked really well for us. There are obviously quirks about the installation because, kind of, in the case of Lambdas, they have certain kind of conventions that they have to enforce, and they can only run for so long. But other than that, Papermill has been really an indispensable part of our toolkit, and we really rely on it for almost all of our customer delivery. For threat hunting, for example, is ultimately delivered on Papermill. And likewise, we have our own kind of internal equivalent of Scrapbook that we wrote as well. The idea that you can run a notebook asynchronously in the middle of the night, get results for your, a data frame, serialize that in such a way that an analyst the next day can just log in the morning with their cup of coffee, pull down a notebook, and not have to wait for a long query to complete, but that all those results are there basically as if it were a hot notebook running the first time is incredibly powerful. So, I mean, Interact and that company is really proud of like the innovations in general they've provided to the notebook community, because both of those are, again, indispensable for our workflow.
Yeah, Scrapbook, for people who don't know, is like it's a way of like inside your notebook, you can set some value like, vulnerability or like severity equals high. And then without opening the notebook, you can just query the notebook and it will say, is there a severity marking in this notebook? And then you can act on it entirely programmatically without having to, or just search through a lot of notebooks. So the kind of two go together. Yeah, I'm a big fan of Papermill as well. I think there's more of a challenge to like creating the operational environment around it. Like, how do you schedule it? How do you trigger the notebooks? But as far as actually executing, and it's kind of a really nice interface. So I think I don't know how far through we are in these things.
Hey, so one of the things that I believe will be interesting to covering here, I guess, is that from a security perspective, right? Because I think that we've been talking about some of the, kind of like so how to use a notebook, how to actually use it to automate things. But what about security, right? The security aspect of the tool itself, right? And to me, it's something that, for example, with the recent, I guess, vulnerabilities even found in some services in the cloud that started by using a Jupyter Notebook service, right? But then all the way to also maybe whoever is watching this, that there is actually a Jupyter security, like I would say, team. Like it's not a team that is going to be doing like a lot of the fixes, but there is a team that is actually meet. I believe it's on a bi-weekly basis to talk about like security of Jupyter Notebooks. I share some of the links in the Discord channel, and maybe we can put them in the banners right now. But those are pretty good because one, it kind of tells you some of the topics that they are actually talking about, in regards of security of Jupyter. And now there is a section where you can actually even, there you go. There's a GitHub repo that goes along with that, where you can actually see the notes of every single meeting. And I attended at least 1 or 2 meetings, but then I got sidetracked with other projects. But I've seen, for example, other folks such as John Lambert, for example, from Microsoft, attending some of this and trying to also figure it out. What could be something that we could do as a company that uses notebooks to help some of that. So just the concept of Jupyter security, and I wanted just to provide these resources, of course, but what do you guys think? Like the future of Jupyter notebooks when it comes to security? Yeah, anybody?
Yeah, for me, it's a bit scary. Because I guess there's like we've always kind of treated notebooks as like well, the users running this, they have like complete trust in their data, and running it locally. So there isn't really any like security worries that we have to think about as far as like Mystic Pi. But then once it's in a cloud, then you're suddenly, oh, what about cross-site request forgery? Is there something that we're doing here that opens people up to attacks that they wouldn't otherwise be expecting? So you shouldn't have brought this up. Sorry.
The Jupyter protocol is remote code execution. If it doesn't do that, then we have a problem. We can't actually run our notebooks, right?
Yeah.
But some of the more like the Databricks or any kind of like collaborative notebook environments, we have multi-user on the same instance. Those I think tend to exacerbate that problem because you have this sort of appearance that these are separate users. But ultimately, if you're on the same instance, you're running the same code. There's an opportunity to steal other credentials from your peers who are on the same device. If it's, again, an instance, if it's shared among multiple users, there are definitely concerns there. Also, just in general, the health of the Python ecosystem for malicious packages. For like you recently with the fast API kind of typo squatting malicious packages, those are really scary, especially if, God forbid, we make a mistake in one of those in some of our requirements or dependencies, where many, many downstream users now could be, affected by it. So I think, if anything, going back to the zip app conversation, one of the things that does, in theory, let us do is have proper reproducible builds on Python, because you know exactly what you're going to be shipping ahead of time. It won't help you find the bad things, but you'll know what you are actually going to ship each time. But yeah, it's certainly a concern. But in general, I feel like most of our our internal security folks, they are more focused on, again, the protecting the build pipeline than they are kind of securing the actual Jupyter instance. Because for us, at least, it's per user anyway. Everyone gets their own entirely separate instance. So that's how we're segregating mostly.
Yeah, I'm also quite concerned about the Python packages.
One thing we have an issue that's kind of like a to-do item for Mystic Pi is to provide a kind of an installable version that just uses hashed kind of like locked versions, which is a requirement for governments, and we haven't actually got around to it yet, but it seems like it's not that difficult to do. A lot of people don't do it. I know Dustin Ingram at Google is like one of the Python core devs, is a big advocate of this. There's like a double-edged sword in that if you're locking kind of package versions, then you're installing it to somebody else's environment that you don't necessarily know about. Like for Mystic Pi, we don't have the same kind of luxury as like we're managing a user's environment. We don't know where we're kind of going, so you don't want to have to reinstall 50 different packages because people have got slightly different versions from the version you have. So it's difficult to know, but I think as an option, I think, I just want this, and I want to be sure the versions are have valid signed hashes and stuff like that. I think it is definitely something we should actually move from the to-do list and move to a to-done list. Looks like, I don't know whether Roberto's disappeared entirely. There's an interesting thing about like cross-language data frames and processing. I think again it was like Ryan. I'm just gonna. No, hold on.
Yeah, the basic idea of the question was, there are a lot of different kinds of engineers or notebook users. Some of them are going to be actual data engineers who maybe primarily actually using Spark, or they're Java devs first and foremost. Then you get your analysts who are more pure Python. They try to interface in the middle when you get data sets that are a little bit too large to do in memory. And I feel like lately there's been a lot of or more interest in how do we bridge that gap between what you can actually run on a single instance of Jupyter versus what you need to scale up to some kind of distributed system. And is there hope of interoperability for those one way or the other? And I think packages like Fugue are like particularly inspiring because they have basically a certain awareness that a data frame is sort of a concept that transcends Python and transcends pandas. So like if we're going to basically say something that's PyArrow backed and is a columnar data store, how do we deal with that as a general problem as opposed to a per language, per library type of solution? So basically our solution to this, for what it's worth, is basically the universal interchange format is Parquet. So spit out Parquet, consume Parquet. We don't really care how you got there, but ultimately that's what we need you to get it into before we can kind of go on to the next stage. But I'm just curious, how are you guys handling those types of cases where, vanilla pandas doesn't scale up and you pick a different library to do it instead?
I'm going to nominate Ashwin to say something. He much more than me has had like experience of like using Spark data frames, Python notebooks. I've got like a limited like knowledge of it, other than messing around a little bit with Dask.
No, I think yeah. I mean, I've also like not handled many problems where I needed this, but very few occasions I think have always fallen back to like a persistent storage. Like if I can dump that file to somewhere like a blob storage or data lake and then probably reuse that across notebooks, that's kind of like a easier solution. But then again, for scaling and other things, definitely like for my recent the password analysis data set, I had to go back to the Parquet and then zzip that, which kind of works very well because Pandas also allows you to load from a zip Parquet, which is pretty cool. Like it saves a lot of space and move things around much faster. So yeah, those file systems and knowledge of those are really great. If you're in the Spark, I think probably like partitioning and if you can know like distributed processing well, Spark data frames can be also like powerful if you know like how to work it out with distributed operations and then get that speed advantage. So yeah, those are kind of like a couple of things that I've done so far. But yeah, that's pretty much.
Okay, I have one that I just kind of invented myself. That I'm kind of interested, like how people like deal with data schema normalization. Like when is a process name not a process name, or do people deal with that? I mean, for the most part, we've just kind of tried to ignore it. Not ignore it, but like try to be like flexible for like people's different schemas. But I'm really interested in OSIM. We have like a somewhat long-running project to try and get kind of OSIM support. OSIM, for people who don't know, is like a open threat research project. I'll say is kind of running it, doing a lot of kind of great work in that. That provides a kind of, at least the goal of it is like a universal mapping from like any data source. What's the kind of canonical mapping for like a process name or a process ID or a file hash? And we'd kind of like to get that into Mystic Pi so that any consuming it from anywhere, you can have like this is a known schema, so we can maybe some of the visualizations, it just like by default, if it knows it's about, let's say, logons, then it knows exactly, it just says, what's the account name, what's the logon type, without having to know anything about the underlying data. But I'm interested if anybody has any other views, thoughts on issues with data normalization, how you deal with it. Do you just ignore it?
Yeah, sometimes, I mean, even if you have normalized schema, some products do not generate the same type of data. For example, product A can produce the username in a fully qualified domain name or UPN name, and the other product generates the same information as a NetBIOS name. And even if you have the same field for that information, you have different values, which represents the same thing. And it's quite difficult to tackle with that.
Yeah, actually, can you guys hear me?
Yep.
Yeah, actually, what Mehmet is saying is true, because I would say, like, the normalization, right, of data is not just based on the name of the feature, right? Like, all of them could have the same name, like, I don't know, process name or process ID, but then the format that they use for the value, it might be different. So it's like you have different, like, multiple possibilities, right? So it's not just the name of because you might think that, oh, okay, these three tools give me the process GUI, right? Okay, the name of the feature is the same, so my normalization is ready. Oh no, you need to go to the data, and then the format of the value is different. So that's another level, like a second level of I would say normalization that you should consider, right? So that's why, for example, what we are doing in OSEM is we're focusing right now on the name of the feature, just to, at least be sure that the like the
field name.
Yeah, like the tool that you are using, right? It could be Sysmon, it could be, or any other tool. At least the data is there. But then when you are trying to implement that with your queries, right? When you're trying to normalize the data that you have, then that's the problem that we have right now. It's like the format is different. And the last exercises that I run a couple of weeks ago is about the registry. I have a lot of fun with the registry, because, like, the format is like different depending on the tool. The name is the same, but the format, I hate the format of the values.
Nice.
Yeah.
I like to call it abnormalization, because I get both sides of the argument. As a developer, I would love a protobuf schema that I can reliably say, this is my format for all the data, and it's just going to work, and I can push that concern to some other team to make sure they feed it into my software properly. On the other hand, as an analyst, it's very frustrating when maybe there's like an FBI flash alert that says you should look for this specific combination of Windows event IDs, and then you have to translate that native description of the telemetry you want into whatever schematized format your vendor or whatever is supporting. And that also has some cognitive overload or overhead that you have to like consider quite seriously. I also, my personal opinion is that for a lot of the EDR vendors, especially, not conforming to a spec like OSM is actually probably by design. So, if you think about if you're trying to support an EDR that works across all operating systems, well, I don't want to have an event that's a literal one-to-one with a Windows 4624 event. Why? Because semantically, this should be a user signed in, and that could happen on Linux or on Mac or on Windows. But if I'm building some sort of advanced analytic and it's relying on specifically logon types, well, that just won't translate well. So even if your schema is generic, I think people often still apply operating system specific logic on top of that, which you end up with weird situations where, again, you think you write something for all things that send me this normalized standardized data, but in reality, it only applies to a subset. You don't find out until you miss that pen test, right?
Yeah. Awesome. Well, I think that we're already right close to
Overtime.
Close to time. Yeah, closing time. So a couple things. So first, thank you all for taking the time to join us and being part of all this, like speakers, everyone in the live stream and whoever is gonna watch this later, because I've seen like a lot of also retweets and likes the day, like a couple of hours after or the day after, is because everybody's also enjoying the weekend and watching the World Cup maybe. Right? There's a lot of stuff going on, but yeah, so I think that for next year, I think we're gonna try, right, Ian? Maybe if it's possible, I don't know, like to even do it live, like in who knows, right, in Seattle maybe. So like actually you have to go there maybe. So or
we'll probably still do an online version of it. So
yeah, exactly.
I don't know how much people are prepared to pay to come to Jupyterthon. But
Yeah, no, but I'm saying like an online. But then if people want to attend, I guess then maybe it would be good to do it, I guess, in a place that would give us a place to do it for free. That's what that's what I'm thinking. That maybe since we work at Microsoft, I guess maybe Microsoft might want to do that. If anybody from Microsoft that has the power to do that, let us know. So yeah. So hopefully we can do some of that, kind of like still do online version, but then also have the face-to-face interaction. I think that would be cool too. So you meet others as well, and maybe get a couple of drinks after, which is always good.
Yeah,
right?
real beer is much better than emoji beers.
There you go, like Ryan. So yeah, we're trying to improve this whole format. I mean, that going back to live stream number 1, we got just to kind of share a few things, kind of like closing out the conference, I guess. We played some music, then the whole live stream was banned for like 30 days. So a lot of mistakes as this conference started just by saying, hey, why don't we talk about Jupyter Notebooks, since everybody's working from home now because of the situation where we were. We're still a little bit, but where we were 2 years ago. And then every year it's just becoming better. Last year we got a workshop. This year now we have a better, I guess, streaming features, having a banner and all this stuff. So a new logo, like a new site. So we're trying also to improve all of that, right, for every year, and hopefully next year, bring us like more topics, like new ideas, and new collaboration, like also like ideas for everybody, right? So yeah, so thank you very much, everyone who joined this. Any final thoughts? Any final words from the panel? One sentence, one word regarding Jupyter in general. What do you guys think? You want to start, Ian, with like a final thought?
Well, I'm feeling a bit exhausted, but I was like, I've learned a tremendous amount, probably more than any of the previous Jupyterthons. Have been like, I think the depth of talks and the like variety of different technologies that people have brought in and showed like in a often really practical way. It's like, oh, I can actually use this, rather than it's just like a very academic, interesting thing. It's been great. I really enjoyed it.
Cool.
Even though I'm really tired and can really do with beer.
Same here, man. Same here. I'm about to probably go get some crepes and just get some coffee and just relax. Yeah. Let's say Ashwin.
Yeah. I think one thing that I noticed, we had like probably 4 or 5 different ML or like pretty deep ML type of notebooks, which definitely have to go back and rewatch to get a little bit more grasp. And then there were like few talks which were entirely focused on visualization. So we had like a good mix of notebooks and then variety of things that newly introduced, even for intermediate or like advanced users. So that's kind of like a good insights that I'll probably take away from the event 2 days. Definitely a lot more learnings. Yeah.
Sounds good. Let's see. Mehmet?
Yeah, I enjoyed a lot. They were really great presentations, and yeah, I will have to rewatch them to learn.
Nice.
Because it's like 2 days of knowledge streaming in time.
Definitely. That's what we call it, like Jupyterthon, man. It's just so much to cover. Right?
You think it's only 2 days, but it's really a week.
Yeah.
Yes.
It was great.
There you go. Thank you, man. Janantha?
Yeah, I think there's one for everyone in terms of notebooks, from as Ashwin and Ian mentioned, there's like very deep, very complex analytics going on, to like things that is good for starters as well, to get them onto notebooks and then start their journey as well. So I think this was a really good opportunity for me as well for learning. and a lot to digest, as Mehmet mentioned. So I'll be spending a lot more time going through and taking apart and see how we can, how I can, contribute more to the open thread research community. So thanks for that opportunity.
Oh, Ryan.
I guess my parting thought would be, it is so refreshing to meet other people who are approaching similar problems with similar solutions. And it is wonderful to know that as a researcher, it often feels like you are in the dark by yourself, and we're not. And it's really, really nice to meet new people, hear new approaches, see so many great projects. So thank you so much for putting this on. Really, it's been incredible. Appreciate it.
Awesome. Thank you, Ryan. Jose.
Yeah. Well, I'm planning for next year trying to complement Ashwin's idea, not only sharing notebooks for intermediate or advanced users. I would like to start with the beginner one, trying to show them how to use Jupyter notebooks to start developing machine learning models for security. So that's my plan for next year. Maybe if there is a workshop, I would like to provide one for beginners, like to start from zero all the way to develop a model. And the other thing is, like, I invite people. There might be people here that are watching us or listening to us that are red teamers. So I would like to, see a presentation that says abusing the Jupyter Notebook service or something like that. That would be cool for next year.
So the Jupyter, thank you, Jose. I think the Jupyter community or the developers might be like, what's going on in here? Why are you encouraging people to do that? But that's the reality of things. I mean, it's the reality, right? We're seeing, threat actors seeing that that's something that we are very interested. So why not try to figure it out, right? And that is why there is a lot of new features that are now kind of protecting you from a like VS Code perspective, asking if you trust the source. A lot of these things that are new, and I think that's a reality. So I also agree. I would love to see more use cases where notebooks are either used to run attack simulations, let's call them, right? Or notebooks are the attack vector for other things, right? How the notebook fits in the kill chain, right? It's an interesting use case, right? So that will be interesting to see as well, because that's how it is in our security field, right? Not only how it is being used, but how it could also be the attack vector. That would be cool to hear in security. So thank you very much. Thank you all again for staying with us, and thank you all for participating. Appreciate it. And I'll see you next year. And happy vacation time, I guess, for the next couple of weeks, next month.
Are we taking a picture of the...
Oh, sorry. Yeah, I mean, if you want to take a picture, let me just make sure I'm ready with my Snapchat. Okay, 1 second. Let me just 1 second.
Also, the Discord, OCR Discord server, that's up all year. So we have like Jupyterthon, like Karen communicating on that.
Sounds good. All right. So I'm going to take a quick snapshot, do whatever you want to do. If you smile, if you want to do it, or do whatever you want to do. There you go. So 1, 2, and 3. There you go. All right. Thank you all, and I'll see you next year.
See you guys.
Yeah.
Thanks, everyone. Bye.